Why do we need clay settling areas? So the clay minerals they're natural minerals, but they're very fine-grained, as you saw in the video. And they expand when we mine them and separate them. They expand greater than 10 times their volume when we first mine them. And this graph on the right shows an initial spike when they expand, and then the curve goes down and shows you with time, those are years on the bottom of the graph that show you with years how close we get back to the original volume that was mined. So they take about 4 years, we get most of the volume back, the water is released, we recycle that water and put it back through the plant rather than pumping fresh water. Clays by nature have a low hydraulic conductivity. Water doesn't like to flow through them because they're very fine-grained and they create a physical structure that doesn't let water flow through them. And they're plastic, that's why they swell and why it takes a while for them to consolidate. And when I say plastic, think of like molding clay, Play-Doh or something like that. They deform and they, but hold together. So why do we need CSAs? Well, one of the biggest reasons is we store and recycle a lot of water. So rather than pumping water, we use these, in addition to disposing of clays, we use them to maintain water inventories that help us reduce our fresh water. They provide water treatment. We have a lot of storm water that falls on our site. We can't just discharge it. We pump them to our CSAs. We allow it to settle and clear water. When it comes out the other side, when it meets discharge quality standards, we can discharge that water, but we couldn't do it directly without CSAs. They maximize the amount of land that we can reclaim with sand tailings. That's been a request of agencies over the years to minimize the clay footprint, so that's one way we can do it. And then of course they provide that volume that we need to allow the clays to expand before they finally consolidate back to something close to what they were in the ground. Sorry, this is just a photo of a CSA. I think we saw the same one in the video, but it just gives you a bird's eye sort of overview. Clays coming in through those pipelines on the bottom. They flow across the pond and then are discharged out the other side once the water has clarified. Oh, now the video is going to play. Already played the video. I guess we'll have to let it play, or I can advance it. So in terms of permitting and regulatory, CSAs they require multi-level approvals and multi-agency. Just because they get approved in one place doesn't mean we can go build them. There are stringent rules and permit requirements that govern how we build and how we design CSAs, where they are, how we operate them. And the siting and the configuration of the CSAs is integrated into the reclamation plan for the site. In terms of dam safety and rural history timeline, what you have on this graph on the bottom axis is years 1940 through 2015, and we could expand this out to today if we wanted to. On the left, you see a big block between 1940 and 1968. There were a lot of CSA failures in the industry. That was the period that predated modern design standards. In fact, in most cases in those years, as you'll hear later, there probably was no design. It was probably just somebody stacking some dirt up and storing some water behind it, in essence. As a result of all those failures, there was a rule that was enacted sometime around 1968, drastically reduced and improved the dam safety. Pushed us down to, I think, one CSA failure in that 68 to 71 period. And then between that period and 1994, there were 2 additional recorded CSA failures in 1994, which resulted in another rule change, a new design standard addressing those problems. And since then, we've had no CSA failures in the industry. So there has been, a lot of progress over the years. Today isn't the same as the past. In fact, we have over 100 CSAs that have been constructed to that new standard, and there has been no failures of those in time. The 2 that have failed, as I said, were not were not designed or constructed with the current standard. That was one of the reasons for their failure. And so, we continue to work on that, but so far we've had a pretty good track record of addressing failures that have occurred, long in the history of the industry. In terms of design and construction, our Florida rules are comprehensive and they're very conservative. In most cases, the standards that we have to live up to exceed most other guidances from, for instance, the U.S. Army Corps of Engineers. They're comprehensive. They require site investigations and characterizations to make sure that we are looking for unexpected conditions. It's geology and things you have to investigate. Our design process is very modern. There's been huge advances with computers and analytical methods that, as you'll hear later with Mohammed's presentation, that allow us to do a lot better job of designing today than we did in 1940, obviously. And then there's very strict construction quality assurance and certification requirements that make sure that the design is good, and now we are making sure on this end that the construction meets the design. In terms of operations, we have a very extensive inspection and maintenance program. We have daily inspections, we have weekly inspections, we have annual inspections, we have third-party inspections, and Keith will go through some of that later. Our teams are well trained. We look for anything and everything and address it as we see it. In terms of hurricane preparedness, we have part of our hurricane plan is obviously focused on CSAs, not just CSAs, but we do have a hurricane procedure, and every year during the hurricane season we're very active in planning and preparation. We have guidelines and requirements for how we monitor and when we take certain preventative actions and try to alter our operations to reduce risk based on what weather we expect. And really our plan is as you'll see in this next slide, it's not progressing too far. There we go. So it's kind of a three-step process. Before a storm, we review what's happened in the past. We update our plans. Operations change. We conduct drills, and we inspect. During an anticipated storm, we of course keep a close eye on weather conditions, what the storm tracks are. We activate our incident command system, coordinate with agencies, vendors, make all the preparations you can think of. And then after the storm, of course, we assess what happened, what we can do better in the next time, what we need to do to recover, and a lot of times how we can help employees and neighbors that were impacted after we've make sure that our operations are safe and everything has been addressed. In terms of emergency response and planning, we do breach and flooding assessment studies. I mentioned that earlier, it's part of the ordinance. Those are generally worst case scenario type, what if the sky's falling, and they're intended to give you planning insight on who you contact, and the worst case, who would you contact and what timelines, those sorts of things. What's the emergency response plan? And then, of course, we've seen numerous hurricanes over the years. This shows Charlie and I think it was Irma a few years ago. Directly impacted our sites. No significant consequences to our CSAs. We did have to go back and do cleanup and some minor maintenance, just like you would at your house or your yard. But our preparation served us well there. And then finally, once the CSAs have reached their life, they are reclaimed. The BMPs are removed before anything's reconnected, before the watershed is allowed to, receive runoff from them or any other impacts from the reclamation process. We wait until those are all done before we remove the BMPs, and then we replant per the reclamation plan. So with that, I'll turn it over to Keith Allen. He's going to talk about the beneficiation process. pointing out that thing.
Welcome, commissioners. My name is Keith Allen, and I am the Senior Engineering Manager for Mosaic's Florida Mining Operations. I received my Bachelor of Science in Chemistry and Master of Engineering and Chemical Engineering from the University of Florida. I've been employed at Mosaic for over 12 years, with much of that time supporting Mosaic's Florida mining operations. For this clay settling area workshop, I'll provide a high-level overview of why and how we separate clay and sand from the phosphate matrix. I will describe the removal of clay, which is accomplished in the first step of the beneficiation process at the washer, and the removal of sand, which occurs in the flotation process. Our next presenter, Subrata Bandy, will then provide additional details about the use and fate of reagents. As a refresher, the phosphate beneficiation process is the technique we use to remove the sand and clay from the phosphate ore or matrix. The three areas of the beneficiation plant are the washer, feed preparation, and flotation process. The washer's primary job is to remove the clay and larger material. The feed preparation step will separate the smaller phosphate and sand into different size fractions. And the flotation step is where the sand is removed and sent back out to the mine to begin reclamation. Before I review how we separate clay and sand from the phosphate matrix, I'll provide an overview of the phosphate matrix itself. The Florida phosphate ore, or matrix as it is called locally, contains three different mineral groups which must be separated from each other. They are phosphatic minerals, clay minerals, and quartz, or sand. Typically, the matrix is 1/3 phosphate, 1/3 sand, and 1/3 clay. The phosphate matrix is usually found 20 to 50 feet beneath the ground and can contain varying levels of phosphate, clay, and sand. The phosphate matrix layer itself can also demonstrate a wide range of thickness, but is most commonly between 10 and 25 feet thick. The phosphate matrix is extracted by the drag lines and pumped to the beneficiation plant where the actual separation occurs. So how do we separate the three minerals found in the matrix? Well, we do this by taking advantage of their physical and chemical differences. First, let's look at the clay, which is very small and between 0.01 and 0.1 millimeters. As you can see, it's smaller than both the sand and phosphate, and this provides an opportunity to use that size difference to separate the clay from the other materials. This is accomplished using cyclones, which I'll explain in a few slides. Next, let's jump to the other end of the spectrum and look at the pebble phosphate product. The pebble is the largest product we separate and is between 1 millimeter and 1 inch. Like the clay, this also allows us to take advantage of that size difference to capture that material. The pebble is separated by flowing the phosphate matrix over screens with 1 millimeter openings. The pebble, which is larger than a millimeter, is captured, and the material smaller than a millimeter passes through the screens. This brings us to the middle size distribution between 0.1 and 1 millimeter. Here we see there are two products in this range, the sand and the smaller phosphate called concentrate. We use the differences in the sand and phosphate surface chemistry to separate those materials through flotation. To recap, the initial step in the beneficiation process is the washer. The washer's primary role is to separate the clay and phosphate rock that is larger than 1 millimeter, which is the pebble product. The first job of the washer is to remove anything that is greater than 1 inch. This would include rocks, sticks, and large clay balls, which do not have any phosphate in them. Next, through a series of screens and log washers, the clay is broken up and mixed with water, where it can be separated with cyclones. Finally, as the material passes over the 1 millimeter screens, the pebble phosphate product is captured, while the sand and smaller phosphate product passes through the screens and is sent to flotation. The equipment we use to remove clay from the matrix are called cyclones. Cyclones work by spinning the matrix slurry like a tornado, which will cause the heavier particles to spin to the outside and fall out the bottom through the cyclone underflow. The smaller particles, which consist of clay, are then pushed up through the top or the overflow. Cyclones work well with a high volume of water, so the particles can move more freely. So where does this clay go? The clay material that is separated into cyclones is pumped through a series of pipelines to a clay settling area where the clay particles sink to the bottom. Once the clay is settled, clean water is pulled off the top through a spillway and flows back to the plant in water return ditches to be reused in the process. The use of clay settling areas is what allows us to recycle and reuse more than 90% of our water. In addition to clay not having any phosphate value, there are added benefits to removing as much clay as possible. One important reason is the impact clay has on flotation reagent cost and flotation performance. Please recall that at the washer, all the sand and smaller phosphate that is less than 1 millimeter passes through the screens and is sent to flotation. If we did not remove all the clay from the stream, it would increase the use of flotation reagents and it would reduce the amount of concentrate or small phosphate we recover. I discussed how we separate the clay from the matrix. Now I will explain how we separate the sand. During the flotation process, reagents are introduced to prepare the phosphate for separation from the sand. These reagents are mostly biodegradable fatty acids from the pulp and paper industry. The fatty acid coats the phosphate particles and make them repel water, just like a freshly waxed car repels rain. Next, we introduce water with air bubbles. The air bubbles will attach to the coated phosphate and rise to the surface where the phosphate is skimmed off. In addition to the biodegradable fatty acid, we also use fuel oil, which enhances the water-repelling property of the coating. Soda ash and sulfuric acid are also used to maintain acceptable pH for flotation. Finally, amine is used to float any residual sand and help produce a final phosphate product that can be effectively converted into crop nutrients. Again, my name is Keith Allen, and I appreciate the opportunity to present at this workshop. Next, I will turn it over to Subrata Bandy, who will review the use and fate of reagents.
Good morning, Commissioner. My name is Subrata Bandy. I work for Ayers Associates. It's a consulting company. So let's get started with the definition of reagents. Reagents can be a compound, a mixture, or a solution, and it's usually added to a system to either initiate a process, start a reaction, or to find out if a specific substance is in a solution or is in a reaction. The most important thing to remember about reagent is that they are not necessarily consumed in the process. They are more like catalysts that make things work. In the beneficiation process, reagents are used essentially to take advantage of the surface properties of the minerals. It also improves the bubble size. As Keith indicated, we have infiltration sails. We have finer bubbles that float up and catches selected particles. So we need to strengthen those bubbles. We need to have a control on the flotation process, the froth stabilization, and control of that. So those are the key purposes of the reagents. The key reagents that are used in the beneficiation process in flotation are fatty acids, amines, fuel oil, and soda ash. So what is a fatty acid? The most common sources that we all can relate to could be vinegar. That's the simplest acid that you can think of in terms of fatty acid. That's actually called acetic acid. The other common sources are olive oil, which has oleic acid, safflower oil, that has linoleic acid, and soy oil, which got linolenic and adiabatic acids. So where do these fatty acids come from? They come from the pulp and paper industry. Pulp and paper industry are interested in the fiber from the plants. Everything that is left in the extraction process is called a tall oil. And when that's distilled, we get the fatty acid. So it's a completely organic product that is derived from the pulp and paper industry. And again, it consists mainly of oleic acid and linoleic acids. These are long-chain organic molecules, and they are highly biodegradable. Let's talk about amines. Amines come from ammonia. Ammonia has 1 nitrogen and 3 hydrogen atoms. When one or more of those hydrogen atoms are replaced by a radical, then we have amines. They are also degradable in natural environment. And we use amine salts in the flotation process. Fuel oil is the heavier fraction of the distillation of petroleum. Most common usage of the fuel oil is in power generation and heating. The fuel oil that's used in beneficiation is obtained from a crude vendor who recycle oil and distill them to specifications, and they are a highly regulated entity. Fuel oil also degrades in natural environment, however, it takes longer periods. This is a simplistic schematic of the beneficiation process. Keith has talked about the separation of clay. What I will be talking about is what is left, which is sand and the phosphate particles. The feed is conditioned using fatty acids, fuel oil, and soda ash. It goes through the first stage of flotation. The phosphate particles float up. Then it goes to the second stage of flotation, where sand particles are selected for flotation, and then we get the final concentrate. And I will provide a little bit more details on those. So flotation. Flotation is a process of selectively targeting either sand or phosphate particles to float up and basically physically separate the phosphate particles from sand particles. The reagents are used to utilize the different surface chemistry that we can achieve because of different pH within the solution. Like I said, either you can float the sand particles or you can float the phosphate particles. And it's done in 2 stages. So the reagents that are used in first stage flotation are fatty acid that's blended with fuel oil and soda ash. Fatty acids work as a collector. And what I mean by that is they have 2 tails, if you will. One is a hydrophobic and one is hydrophilic. The hydrophobic end essentially does not like water. Hydrophilic end likes water. So the hydrophilic end adsorbs to the phosphate particles, and the hydrophobic end, which does not like the water. So the concentrate that we got through this process still has about 10 to 20% sand in it. So we still need to get some more separation. But before we do that, there is fatty acid and fuel oil that are still coated on those particles. So we have to rinse them, and that rinsing is done using a sulfuric acid wash at pH 3 to 4, and essentially dewater and clean. And then that part, the rougher concentrate, which is cleaned and rinsed, are introduced in the second stage of flotation. In the second stage, amine salts are used. They adsorb on sand particles, and the hydrophobic ends, like the other one, attaches to the bubbles, and this time sand particles float up. By that process, this 2-stage process essentially concentrates the phosphate rocks, physically separate the sand particles from phosphate, and now we have a feed that is ready for fertilizer manufacture. So let's talk about the fate of reagents. We need to understand that beneficiation involves a very complex, advanced organic chemistry. We are dealing with a very variable process, if you will. Matrix by nature is variable. It's not a homogeneous material. The reagents that are used, the fate of those and the degradation of those are well understood, but it's very difficult to track various molecules as those reagents pass through the different parts of the process. Because we are in a very, very dynamic environment, the nature of the mining and beneficiation process inherently is very dynamic. The recirculation water that circulates in all parts of the mine, that's a dynamic equilibrium, and there are simultaneously many, many chemical and biological degradation processes that continue to happen within the mine ecosystem. So if we look at the beneficiation process and look at input as reagents, let's look at what comes out and where and how it can come out. So let's look at the environmental pathways of the reagents. One way is the surface water discharge. The only way any water is discharged from an active mine site is through permitted outfalls. These are FDP regulated NPDES permitted outfall, and that's the only place where water can be discharged to a receiving water body. And then the other possible pathway would be the mine backfill and the reclamation area where sand tailings are deposited. Let's review the regulatory framework under which the phosphate industry works. There is a significant oversight by FDP, and the philosophy of FDP, based on which the regulations are created, are solely hinged on resource protection. Every drop of water that falls on an active mine site is managed actively and can only be discharged through those permitted outfalls. Water quality monitoring is mandated with specific parameters that are tested every time a discharge happens, and the water quality monitoring data is reported to DEP on a monthly basis. And if there are sensitive species and other conditions, then water quality is also monitored, as well as biological monitoring that happens on receiving water bodies. So the data that's collected during permit renewal, we call it 2CS sampling, and this is a part of permit renewal process. About over 150 compounds are tested for the discharge water, understanding of what is in that discharge water. It includes all kinds of metals, cyanides, phenols, volatiles, and pesticides. Once those screenings are done, then only our permit is renewed for NPDES discharge. So far, no indication has been seen that any beneficial reagent has been found in the discharge water. Sand tailings, they are also analyzed annually from the discharge point, and I have a list of parameters that are tested annually, and routinely they are below detection limit. If ever there is a trace amount that's found, they're usually 100 to 1,000 of drinking water standards. South Fork meat could be analog for DeSoto. Groundwater data is collected from our South Fork meat mine, and it's reported to Hardy County. Trace levels of oil and grease occasionally has been detected, but the levels are of magnitude lower than the wastewater effluent limits that EPA usually proposes. The literature supports and has enough evidence that amines and fatty acids are highly biodegradable. And there are documentation that is out there that shows that over longer periods of time, full degradation is possible. Fuel oil is also degradable at a slower rate. Naturally occurring microbes, a combination of bacteria, fungi, capable of degrading hydrocarbons over a longer period of time, even to a level below the regulatory cleanup level. Soil attenuation is a well-accepted method of remediation, and that is adopted by EPA, by the industry, to treat soils that has been in touch with the fuel oil, or fuel oil has been found or spilled on soil. So in natural environment, the natural microbes are fully capable of degrading petroleum hydrocarbon. So the industry has made significant progress in last 25 years. The technology, the process has been improved. The flotation additives, the amount of flotation additives that are used, that's been significantly lower. And there is continuous improvement that's going on in the process control, artificial intelligence, and we absolutely expect that to accelerate optimization of the reagents. With that, thank you. Thanks for the opportunity to present this material. Thank you, sir. You're welcome. I will now hand it over to Mohammed.
Good morning, commissioners. Good morning, audience. My name is Mohammed Al-Hawari. I'm the President, Fardaman and Associate, and the Senior Consultant. I hold a bachelor degree in Civil Engineering from University of Damascus. I have a master's degree in Geotechnical Engineering from the University of Alberta, and an MBA from Rollins College in Orlando. Been practicing geotechnical engineering for over 22 years. I hold licensed professional engineers in engineering in the state of Florida, Louisiana, Georgia, North Carolina, Minnesota, Idaho, Alberta, Canada, and Queensland, Australia. Worked on projects in 6 continents. And I think I'm going to go over the engineering design and some regulatory background of clay settling areas. The topic I'll be presenting is I'm going to go over some background of the engineering and the regulatory framework of clay settling areas. I'm going to go over the clay settling areas site overview, field exploration, laboratory testing, engineering design, regulatory requirements, construction, quality assurance, instrumentation and monitoring, and inspection and maintenance of clay settling areas. Sorry, the slides are moving a little bit slowly. That's why I'm going to push.
About how my interaction with computers and slideshow works too.
There you go. I think there is misconception on the clay settling areas, and some people think that clay settling areas are built by pushing some dirt around without regularity oversight, engineering design, construction quality assurance, monitoring and inspection, and maintenance. And that may have been true prior to 1968. Just like cars did not have seat belts, airbags, anti-lock brakes, or any other safety systems. In fact, today CSAs are heavily regulated
and they undergo a thorough and rigorous permitting, design and construction process, and continuous monitoring and maintenance. CSAs are very important part, they play an important part in the mining cycle as they are integral to the reclamation process of mined areas. Let's see if this works. It's giving slides. Okay, now it's working. As Scott mentioned, in fact, between 1940 and 1968, there were 32 recorded incidents. And that's pretty much triggered in 1968 the Chapter 17-9 Florida Administrative Code to be adopted to regulate the design and construction of earthen dams for Florida phosphate industry. And it requires that all dams must be designed by professional engineers, and they must be inspected daily during operation by employee of the owner and semi-annually by an engineer. And that worked well until 1971, and in 71 there was another incident of a dam failure. And that prompted the change into the rule, and 17-9 became 17-672 Florida Administrative Code. And it required seepage control and tow road. And it required that the dams be designed and inspected during construction. Now there is an inspection during construction by a professional engineer, and that engineer must be experienced in the design, construction, and maintenance of earthen dams. So you could see that how the rules are improving. And then they were required to be inspected weekly during operation by a trained employee of the owner, and annually by a professional engineer experienced in dam design, construction, and maintenance. And that worked also well until 1994, where there were two recorded incidents where I think there were piping failure along the decant structure pipe penetrating the dam. And in 1995, there was a memo of practices issued by FDEP, the Florida Department of Environmental Protection, and it included putting a flowable cementitious fill to be placed beneath the lower 1/3 of a conduit penetrating through the dam. So they recognized there was an issue there in the dam design and construction, and they addressed it. And they also required that the initiation of the spillway flow to be during daylight hours. So that would allow for the inspectors to look, inspect, and to check if there is any problems or conditions that warrant doing different things. And then in 1999, the 62672 Florida Administrative Code was revised to incorporate these design changes. And since 1994, there hasn't been a dam failure in the phosphate industry in Florida. Now, I'm going to start talking about why dam fails and how to avoid these failures. So if you look at the statistics of dam failures, and that's not only tailing dams, that's all dams. Overtopping is one condition why the dam fails. And think about overtopping if you have a bucket of water, let's say it's 24-inch deep, and you get rain event. And if you have a rain event of 12 inches, the bucket is not going to fill to the top and it will not overtop. But if that bucket was connected to, or it's under the spout coming from your roof, and the roof area is 5 times or 10 times the bucket area, then the volume of water you're collecting is 10 times more than the surface area of the bucket, and if you have a 12-inch of rain, obviously that bucket will overflow. That's overtopping. 45%, about 45% of dam failures are due to overtopping. And why that's not an issue for us here? Well, one reason is because our clay settling areas on the top, they only collect water over their bonded area, which is equal to their watershed, almost equal to their watershed. So you don't have a large catchment area reporting to these ponds. So that's why if you get 100-acre top area and you get 12 inches of rain, the water will come only 12 inches. Now, we design these clay settling areas with freeboard, and the freeboard is the distance between the water level, operational water level, maximum operating water level, and the crest of the dam. And that's typically about 5 feet. And your heaviest rainfall event, the 100-year storm, is less than 12 inches. So if you have 5 feet of freeboard, and that's between the top of the dike and the maximum water level, your risk of overtopping is non-existent. Plus, you have the spillway structure, which you're going to start flowing through the spillway structure before you get to the top of the dike. And we take into that design consideration the wind speed and wave setup and wave run-up to make sure we have enough distance so the water wouldn't overtop the dike. So that's really not an issue for Florida clay settling area, because mainly the catchment area is almost equal to the ponded area. The second reason why dams fail is piping. And piping is the phenomena that happens when soil particles start eroding along a preferential path and create a conduit. And typically that happens, and as I mentioned earlier, that usually happens in an area where there is changes in the material, and it happens along the pipe penetration of a spillway structure through the dam. I'm going to talk about the engineering design, but this issue has been addressed by having a special design for that penetration, where you have seep shields and then you have flowable fill under the pipe itself, so that can prevent piping failure. Now you could have piping through the body of the dam itself, and the engineering design addresses that issue by putting drains and filter within the dam body, and I'm going to show you that later. So now that's 30% of dam failure typically are piping. Then 20% are slope failure, and that's slope instability. And I'm going to talk in details about that. And then you have earthquakes and liquefaction, and that's typically not an issue in Florida usually. And liquefaction, clay material doesn't liquefy. I mean, liquefaction happens in a loose sand, silty sand type of soils with some dynamic event like earthquakes. So really that's not much of a concern here, but it could be addressed through design, but that's typically 5% of dam failure. So let me go back to factor of safety. I don't know if everybody understands the concept of factor of safety. It's a really very simple concept. Is if you have a driving force, that's something trying to move an object, and then you have resisting force. If your resisting force, I think I lost the slide there. If your resisting force is larger than your driving force, that object is not going to move. And what you would do usually in engineering, especially in geotechnical engineering, you divide the resisting forces by the driving forces, and that will give you how much your resisting forces are higher than driving forces. So, for example, if that division is equal to 1, that means you're at equilibrium, your driving forces are equal to resisting forces. If it's 1.5, then you have 50% more strength in your resisting forces. If it's 2, you have 100% more resisting forces. So how do I avoid dam failures? Obviously, we have to start with adequate site investigation. We need to know the foundation, where we're building our dams, and how that foundation will behave under the load. We have to do adequate material characterization of that soil and the material we're putting behind the dam. We have to have good foundations, a proper design, proper construction, adequate monitoring, and adequate inspection and maintenance. Just like everything in life, I mean, your vehicle, if you don't maintain it, it'll break down. So, and continuous inspection and maintenance is very key here. So typically what a clay settling area site goes is the site review, and the site review is done to characterize the subsurface conditions and the geological history. So you look at visual observations, you look at aerial photographs, site geology, you look at prospect borings, you review existing borings and data lab test results, you generate the top of bed clay contour maps. As you've seen in some of the slides, there is the bed clay, where that's the confining unit of our Floridian aquifer. You look at site photolinears and you characterize the geology and the history of that site. And you do that from the beginning of the mining operation. So while the company is mining a mine area, they have geologists and they have operators that are always looking at what they are mining, where the clay is, where is the sand, where is the confining unit, and they would report to management any unusual conditions to be investigated. That's well before even a clay settling area is designed. Then you look at photolinear studies. And photolinears really is kind of like a method used in Florida and other places to look at the structural geology, but not really into the geology beneath the ground. You're looking at superficial features that may be indicative of what's happening under the ground. So there is a method developed in Florida to look at these things, and you draw these photolineal, and they have certain angles and certain direction, and they connect certain features. And when you have some of these photolineal in a site, you inspect the intersection location and you drill some boreholes there to better understand the structural geology of the site. And then you go with a field investigation. And the field investigation really focuses on understanding the soil conditions of the site and how that would play, what role that would play in the stability of the clay settling area and the safety of the clay settling area. So you would advance boreholes along the dike alignment, you would advance some boreholes in the interior, you advance some boreholes in certain features of interest, and collect that information to help you with the design. Now, the field exploration is pretty much what you're doing. You're drilling boreholes and collecting samples, and taking these samples to the lab to do some testing. And the testing, soil testing today is very sophisticated. I mean, lots of research and development were done on soil testing to understand the behavior of material, especially the behavior of clay. And you start with soil classification, and that's just to tell you where that soil fits. Is it sand? Is it clay? Is it soft clay? Is it sensitive clay? Is it coarse sand? And that will give you an indication of how the material will behave, and that will also give you an idea of what other testing you would want to do. So the initial screening testing is grain size, moisture content or water content, and Atterberg limits, and that's a special test for clays. Then you look at the in-place density of soils, and then you could take samples and do compaction tests. And I'll explain why compaction tests are important. It tells you how this soil would behave under a certain energy load that you put on it while you're building a structure with it. You do tests like the triaxial tests to determine the shear strength of the material. That plays an important role in the engineering design. You do hydraulic conductivity or permeability tests that tells you how fast or slow water flows through this material, and that's very important to designing the different components of the clay settling area dam. And then you look at the consolidation test, and I think Scott touched base on that. I mean, you look at the clay. Clay is like, I give the example of popcorn. You get a little bit of popcorn, and then you cook it, and you end up with a big bucket. But then you try to bring it back to that small portion of corn seeds that you put. And that's a consolidation test. That's how that test tells you how that material is going to behave with time and under different loads, and how much time it's going to take to go back to its original volume. We do a lot of tests, and we summarize all these test results and the graphs that we use as engineers to determine how that material behaves. Again, I'm not going to go through these. Engineers on the crowd probably understand what all these tests are and how they are used. The compaction test. Here is a test that I think most people are familiar with this test. If you're building a house, obviously you want to put your foundations on solid ground. A lot of counties today, many counties, require compaction tests on their foundations. And what that test does is really, you take the soil at a certain water content,
You compact it with a certain level of energy, and you see how dense it
becomes with different water contents, and then you pick the optimum, and that's what you want to compact in the field when you're building a structure. And you compare that to the natural density there and what density you would design for. Okay. Why is that important? There are a lot of research that's done on the effect of compaction on the strength and permeability, and these are two graphs. They are in geotechnical engineering books, and one of them from Gibbs and Holt, and the other one is from Lamb and Whitman. And you could tell that relative density, which is that when you add more energy and compact the soil, what that does to the penetration resistance, which is strength. So as you increase the density, the strength increases. And if you look at the graph to the right, that one is the compaction effect on the hydraulic conductivity. The more you compact soils, the less permeable or with less hydraulic conductivity it would have, so the slower the water would flow through the soil. This is the strength test results that tells you how strong this material is. So you try to shear the material, and you get what we call, for sand at least, an internal friction angle, which is, even for clay you could get that, and that's how that material would resist forces that are trying to shear it. And you could get Andre shear strength and other parameters from these tests. That's the consolidation test, and those are actually from actual projects that we've done for clay settling areas or other dam design. And now you go into the design itself of the dam. We collected all the field information, we've done a lot of testing. Now we're going to use that information to help us design a structure that is safe under the operation and the natural condition that is going to be experiencing through the life of that facility. A typical design feature of a dam is the freeboard, and I mentioned what a freeboard means earlier. So the first thing you look at is the freeboard. How much freeboard do I need to put in this dam? And that's a function of where the dam is located, the depth of the water, the prevailing wind, the shape of the dam. I mean, think about it. If you are in open water and you have wind coming, it will build big waves. But if you have a small ditch and the wind is blowing through it, you are not going to generate a big wave. So there is calculations actually that goes into determining what that freeboard is. And we do that calculation, but most of the time you add more freeboard than you need to be in the safe side. A crest width and elevation. Obviously, the crest width is very important to the dam stability, but also it's important for inspection and operation. So that's usually about 25 feet to 30 feet, the height of that dam. Obviously, nobody wants to build something that not going to use. So if we think we need to store certain volume, we try to optimize the volume, we try to optimize the footprint and the height of the dam. So we're building only what we need. And then there is the slopes, and that's a function of the stability. So think about it. If you have weak material, and angle of propose comes to everybody's mind, if you have material with a very weak structure, then it's going to have a flat angle of propose. If you have a stronger structure, it will be steeper angle of propose. Rock would stand vertical, where sand you have to go at 30 degrees or something like that. But that's just a simplification of what the analysis that we do for stability. Then the positive seepage control, and that's where drains become very important. I talked about the piping features. So we know what the problem is as engineers, and we have a solution for it. So if we know we're going to have a piping problem, we put a drain inside the structure and we put a filter. So the material cannot wash away and cause a problem. Then there is this billway structures and return hydraulic ditch, and that's very important for the overall functioning of the facility and returning water for recycling. And there is a two-inspection road, that's what we would use to make your daily inspection, weekly inspection, monthly and annual inspections. So that's the big picture of dam design features. Now, as you go through the, after mining, this is the picture after mining, you could see that the alignment of the dike is going to pass through different areas. And sometimes you pass through area that was not mined because there was no phosphate rock there. You could go pass through an area that completely mined out and you have cast overburden and spoil piles I would see here. Or you could go to, the dike could go through an area which has portion of it mined and portion of it is unmined. So the design itself of the dike would be different for every area, so it's not one size fits all. This is, for example, a cross-section for an unmined ground. So in unmined ground, you're dealing with the natural soil conditions. So you have the sand, the superficial sand and the superficial soils, and you would have that design to address these soil conditions. This one is a portion of a dam that's built on a mined out area, and that was backfilled with a cast overburden. That's the material you remove before you mine the ore and gets the place. That will have different design analysis. And this one, portion of it goes through mined and portion of it goes through unmined area, and that will have different design feature and engineering analysis. Okay. So, as I mentioned, clay settling areas are very heavily regulated. So they're regulated under rule, the FDEB rule 62672-300-1D and E. And the stability analysis includes a flow net analysis. And I'm going to show you what that means, flow net. That's the analysis, the engineering analysis you do to understand the water behavior inside the soil of the dam body. It tells you how much pressure, how much flow it goes through the dam. And the design must use maximum design fluid level. So when you design these dams, you're not designing them for best case scenario, you're designing them for worst case scenario. You're putting the water level at the highest elevation that it could reach. And then it requires minimum factor of safety to be applied. For example, on the horizontal shear along the base, that's the whole thing moving in the base, it requires factor of safety of 1.75. For horizontal shear with fill due to seepage through the outer slope, it's 1.5. Bearing capacity 1.5, and circular arc is 1.5. And I'll show you some of what that means. These FDEB rules exceed the U.S. Army Corps of Engineers rules for clay dredge disposal areas, which the Army Corps owns and maintains, I don't know, miles and miles of these dredge disposal areas, where their end of construction factor of safety is 1.3. Their long tail is 1.5, and they have factor of safety of maximum surcharge pool of 1.4, and rapid drawdown 1.1 to 1.3. We don't have anything this 1.5 with the Florida rules. So you could see we are more stringent than the Army Corps. We're more stringent than the Interior Bureau of Reclamation. You could look at the list to the right, and you have factor of safety for different conditions from 1.2 to 1.4, 1.3, a lot of 1.3s. Again, our minimum is 1.5, and we go to 1.75. That's for the Florida rules. For the DeSoto mine, we're also more stringent than the Florida rules. So I put comparison table of some of where we are more stringent than what's required by the Florida rules. The minimum freeboard for FDEB rules is 5 feet. We have 6 feet for DeSoto mine. We use a wave run-up and run-up design using 120 miles per hour wind, which is very, very high wind. Side slopes for upstream and downstream, the Florida rules require minimum of 2. We have 2.5 for upstream and 3 for downstream. A crest width is 30 feet, so I mean, it's the highest of a crest. Tow road is 25 feet, there is no requirements under the Florida rules. And you go on with the factor of safety for bearing capacity. The Florida rule is 1.5, we are more than 2. Horizontal shear, we're more than 2 compared to 1.75. And so you could see how stringent this design is compared not only to the Florida rules, but also to the Army Corps of Engineers and the Bureau of Reclamation. So what's seepage analysis? I mean, we collected soil samples, we did lab testing, and now we use that information to draw what we call a flow net in geotechnical engineering. And the flow net really is it's a fancy word to tell you the distribution of the pressure inside the dam and the flow path of a water drop through that dam body. So if you look at this, the blue lines tell you what the pressure is everywhere in the dam body. So if you take the line that says 130, that means the pressure along that line, the total pressure is about 130. And you could see the pressure drops and the water would flow from high pressure to low pressure. So the green line will give you what a drop of water, how it would flow through that dam when it's in operation. Okay. One main thing, I think Scott touched base on that. The flow through these dams is very small because they're very well built, very well compacted, and what they store behind them is a clay which has low hydraulic conductivity or permeability to start with. Okay, so the seepage analysis, and I'm going to compare later how it was done in the past, but in the past we used to draw it by hand, and that's a very complex process. Today we have computer programs, we have finite element and finite difference programs, and we could build these cross sections with almost an unlimited number of soil parameters and soil types, which allow us to fully understand how the water flows inside that dam body and the pressures at every point within that dam. And what we would do with that information is really that would tell us where we have high pressure, and where we have high pressure, we want to relieve that pressure or control the flow in that area. We put a drain and we would filter, so we capture that seepage and control it. So that's what a flow net is, and that's a seepage analysis using finite element programs. Stability analysis, I think I mentioned what a factor of safety is, but now what you do with that, all that strength information and density and index testing that you did, you use limit equilibrium analysis, and what that would do, you would, again in the past we used to do this manually, and I'm going to talk about it at the end, but today computer programs could look at where potential slip surface would be, and would analyze not only that slip surface, but they would look all around. They would keep searching for a single slip surface. They would do 18,000 runs. The program would do it automatically with different stability methods, and to determine where the lowest factor of safety is. And if we found it that's lower than it's required by design criteria, then we have to change the slope or improve on the material. Here is one example of stability run. And this is from the output of the computer program. That's a limit equilibrium computer program. And for what you see there in the green and slices, the program is running 18,000 simulations. And what you see in like the rainbow color above, that's the contouring of the minimum factor of safety. And you would look at the center, that is the lowest factor of safety. And it is higher than what's required by design and by rules. So that's only one slip surface and one scenario. Now, what do these programs allow us to do? We could go to every point in that dam and look at that slice and know how much strength we have in that slice. We know how much that slice weighs. We know how much pore water pressure we have in that slice. We could plot along that slip surface what the strength is, what the driving forces are. So all that is done really today in a few hours, where in the past it used to take months and months to do only one run. So from the engineering perspective, if you did the site investigation, you did your lab testing and your characterizations, and you run your engineering modeling from the seepage and stability, you have a very good understanding of how this dam is going to behave during its operation. Then we come to the spillway design. I mentioned earlier, piping is one of the reasons why dam fails, and people learn that you have to pay more attention to the design of these spillway structures. So they are designed today with concrete cradles and with seep shields. They have structural design. I mean, everything is designed by professional engineers from the beginning to the end. And here is a cross-section example. You can see how that concrete cradle prevent piping along that lower piece or the crown of the pipe at the bottom, because you filled it with a flowable film, so it is material that can't erode, and then you have seep shields to stop water from going through any defects there. Now that we investigated the site, we designed it, and we permitted it, and now we're going into construction. And you start your construction with removing topsoil, or if there is any material, undesirable material, organic material, you remove it, you store it for reclamation later, and then you come back the foundations, and that's done through heavy equipment. This is a picture of the spillway outlet pipe, how it's constructed with the concrete cradle there. There is concrete testing is done, compaction and density testing is done on this. It's not built without oversight and supervision and inspection. It is heavily inspected. Here is a picture of the seep shield with the concrete cradle. So remember those two incidents that happened in '94? The reason was there was piping through these outlet pipe structures, and that the design recommendations that came out of that investigation, and several professionals, including professors from MIT, were involved in that discussion, and what the best way to design these pipes without having to deal with potential piping failure in the future. Here is a picture of the reinforcement that goes into these structures. Here is the final picture of the spillway. And I think you've seen these, that will control the water level inside the pond. So what do we do during construction in terms of inspection? I'm going to talk about that in details here. There is quality control, which is done by the contractor. The contractors, they bid on a job and they have to meet certain design criteria and specifications. So they do their own testing, but then there is quality assurance that is done by a third-party engineering company to make sure that the contractor is building it in accordance with the design and specifications. Density testing is performed, and again, I mentioned how important that density testing to the performance of the dam, and there are, depending on the material, you could do a sand cone test. This is a picture of sand cone test. That's you're measuring how dense the material after compaction in the dam body or in the foundations, and you compare it to where you would like it to be based on the design and the specifications. A drive cylinder is another method. If you have a clayey material, that's the method you would use. Then you go into instrumentation and monitoring. So now we build the dam, we investigated the site, we designed the dam, we built it, we inspected it, but we're not leaving it alone. We're putting instruments there, piezometers, and those piezometers will tell us what the water levels are, what the water levels are within the dam and the foundations, and we compare these numbers to what we expect to see based on the design criteria that we have. So if there is any changes from what expected, that will give an early indication to the operator that there may be a problem that we need to address, and typically they address it very quickly. You could lower the water level, you could check on the drain if there is a problem with the drain, or you could do other engineering measures to make sure that the dam is stable. Inspection and maintenance, as we mentioned, these dams undergo regular inspection, daily, weekly, monthly, annually. Any feature that is found, erosion or anything unusual, it is reported to management and it gets addressed promptly. The crest road, sometimes vehicle drives on it and goes rotting. That gets reported and it gets maintained, so you don't allow water to accumulate in these rocks and cause softening of the dam body. So it's not by luck that there has been no failure in Florida phosphate industry dams since 1994. But with all the things that we talked about, we still continue with the progress and improvement. And what I mean by that,
If you look at field investigation methods and the tools,
to the left is very rudimentary method of collecting soil samples, and in the middle somewhere in between, and to the right is where what we have today. We have very sophisticated drill rigs that could get high quality samples to allow us to characterize the foundations and the geological structure of the site. I talked about the flow nets. Those of us who went to school 30 years ago remember drawing these by hand and how complex that was, because anytime you transition from soil to soil, your flow net lines will change. And that it could take you days to draw a very simple flow net with 1 or 2 soils. And today you could, with these finite element programs, you could analyze a dam body with hundreds of soil types and the properties in a matter of hours. Stability analysis. Computer programs made a huge difference. In the past, if you look at to the left, to analyze one slip surface, one scenario only, not 18,000 runs, one run, you would have had to generate a table like you see in the left, split that slip surface into segments, and analyze each segment by itself because it has different unit weight, different strength, and then you calculate what the driving forces are, what the resisting forces are, and come up with a factor of safety for that one slip surface, which could take you days to do one surface alone. Now we do 18,000 scenarios or potential slip surfaces within the same area, and we do multiple scenarios. It allows us to do sensitivity analysis and evaluate different safety situations for the dam. This would not have been possible in the past. Today, we run multiple slip surfaces, multiple scenarios, thousands of runs, and we would have really a clear picture of the behavior of the dam and the factor of safety. Inspection, inspection is usually done on foot or through driving with a vehicle, and we still do that. But today we have advancements. We have drones that today they could fly, take aerial photos in a matter of hours with heat sensors on them and moisture sensors on them, and would allow the operators to identify potential trouble areas way before they become an issue. So, comparing to what was done in the past and we still do today, but to what we could also be doing and we are doing today is really like day and night difference. The advancement in inspection and maintenance, there is a huge improvement in the annual training frequency and inspection. There is one official inspection per week. That's what's required. But Mosaic and trains multiple water safety officers. Everybody who works on the site gets water training. And they are trained to look out for trouble areas in the dam and report it to management so it could be addressed. To the left is a photo of a slope of a tailing dam pre-1972. Okay, to the right is what you see today. That's what an inspection of a dam should look like. The dam has grass, it's mowed, it's clear, the road is clean, there is no rocks, there is no trees that could cause a problem in the dam structure. There is advancement also in inspection maintenance in terms of using durable surfaces and doing more inspection of these surfaces. To the left is again pre-1972, and you could see what rotting could do to the dam. Water accumulates, it softens the soil below that, and then it could trigger a problem. To the right is a crest road today with durable surface and well designed, well constructed, well maintained. So what goes into the design of these clay settling area dams? We talked about the design, but I want to show you just what goes behind the scenes in terms of design. Who works on these dams? This is one example of actual clay settling area in Central Florida. There were 1,200 design hours, that's involving engineers and geologists. 60 boreholes were advanced at that site, 80 soft sediment probes, 23 test pits, and 200 lab tests. There were 5 professional engineers, 2 professional geologists with combined experience of 281 years. This is not designed by somebody who's just learning something about dams. These dams are designed by very qualified, very experienced people. Seepage and stability analysis, we did 8 design sections, so each one is design section. I mentioned to you, you pass it through different soil, we have to change the design section, with 17 scenarios each, and each scenario runs thousands of potential slip surfaces. Freeboard analysis with site-specific wind and wave run-up analysis. If you look there, you have people with bachelor degrees, master's degrees, doctorate degrees, and they're all professional either engineer or geologist. So that's who really work on the design of these clay settling dams or clay settling areas. Now, what goes into the construction quality assurance? More than 42,000 hours of engineers, professionals, construction managers, engineering technicians, making sure that that dam is built in accordance with the design and the specifications requirements. You have senior consultants with 50 plus years experience, professional engineers, senior project manager, 15 years experience, professional engineer, master's degree, project 5, 20 years experience, master's degree, professional engineer, and then you go into technicians with different education, minimum high school with, I don't know, from 2 to 31 years of experience. So again, these clay settling areas dams are very well investigated, very well designed, very well built, very well inspected and maintained. And really, I mean, the story is very clear. Science and engineering you learn as you do things, and I think the lessons learned back in the 60s, 70s, and the latest lesson in 94 were taken very well, and you could see the difference in the performance of these clay settling area dams. That's it. Thank you for listening.
Thank you, sir. Next.
Keith, there as well.
Good morning.
Good morning, Commissioners. I'm Keith Bereswell. I'm a geotechnical engineer. I'm an engineer lead with the Mosaic Company. I have a bachelor's in civil engineering from the University of Central Florida and a master's in geotechnical engineering from the University of Florida. And today I'll be speaking a little bit on the operation, inspection, and maintenance of clay settling areas. So each, and Mohammed dovetailed into this pretty clearly, but each active clay settling area is inspected once per shift by a Mosaic water system operator. These shifts are typically 8 to 12 hours a day, depending on the facility, so there's a minimum of 2 inspections per day. Some facilities have 3 inspections per day. Each of these inspectors, or WSOs, are trained by a third-party professional engineer. To date, this year, we've had 89 individuals that have gone through that training. And we'll talk a little bit about that in some other capacities later on in the presentation. Inspections are generally performed via pickup truck and on foot. The WSOs perform the following tasks 24 hours a day, 365 days a year. So they're inspecting for water levels in the CSAs and the water return systems. They're adjusting spillway flows for target management level, operating restriction, and maximum fluid level. We'll talk a little bit about those. Mohammed introduced the maximum fluid level, and we'll introduce the other 2 here in just a moment. So they're maintaining water levels and maintaining the water quality. They're documenting the levels on shift inspection forms, and they're inspecting the drainage features of clay settling areas. They're inspecting for signs of cracking, seepage, erosion, inspecting the spillway conditions, both at the inlet and the outlet. So professional staff, Mosaic engineers and consultants work with the site operations to develop a mine strategy that conforms to the operational and regulatory conditions for each of the individual clay settling areas that we operate. There's 3 progressive limits for water level management. There's the target management level, which is a Mosaic internal limit. It's a conservative threshold that allows for adjustments to respond to operational needs and to rainfall, as Mohammed introduced. There's also the operating restriction. It's another internal Mosaic limit. It's a conservative safe operating level with a built-in buffer. And then there's a maximum fluid level. This is a permit condition. It's a maximum level determined by the permit and the design engineer. And the spillway structure does not allow for adjustment above this maximum fluid level. So to explain it in kind of layman's terms, this is the equivalent of a high-level overflow on your bathtub or your sink. So it'll allow water to be ponded up to a certain elevation, at which point it's controlled and it automatically overflows. It's a fail-safe, if you will. This is an illustration that roughly depicts the maximum operating water level and the prorated restrictions below that, the operating restriction and the target management level. And then this is a graph that illustrates the way the operating levels interact with the actual inventory elevation. So the black line on this graph indicates an actual inventory elevation of one of our clay settling areas. The green line depicts the target management level, yellow depicting the operating restriction, and then the red depicting the maximum fluid level. So from there, as Mohammed mentioned, there's additionally one official weekly inspection in addition to all of those daily inspections. The weekly inspection is done by a senior geotechnical technician. The geotechnical technicians are trained through the same training as the WSOs, and a senior inspector must have a minimum of 5 years of expertise in CSA inspection. Senior geotechnical inspectors operate independently from mine operations, so they are focused solely on inspection of clay settling areas and stormwater pertinences for the mine. They are not involved with operation of the mine on a day-to-day basis, so they are focused solely on inspection. Geotechnical technicians perform the following tasks during daylight hours. They inspect the CSA water levels and return water systems. They document water levels on their weekly inspection forms. They inspect drainage features, including crest drains, toe drains, stormwater swales, which you guys may recognize as drainage ditches or other terms. And then they're also performing special inspections following major storm events. This image on the slide is a picture that was taken via helicopter after Hurricane Irma. And in the slide, you can see the effectiveness of the toe swale or drainage ditch containing the stormwater runoff from the back slope of the embankment. This is some typical imagery from weekly inspections performed by the geotechnical technicians. So the image on the left depicts a crest road that's in good condition, very similar to what Mohammed presented in his presentation. These roads are graded and maintained using motor graders, and they seek to avoid ponded water at the crest and direct it to a crest drain. The middle image is a picture of a damaged crest drain, so our inspectors are out there detecting these types of damage. The repair for this particular type of damage is to simply come in, remove the concrete, form it up, and recast it. The image on the right is a picture of recasting a crest drain. Geotechnical technicians are also performing spillway condition assessments. They're inspecting the spillways at the upstream and again at the discharge points. They're looking for irregularities, signs of corrosion, need for paint maintenance, and then just making sure that they're operating properly. They're inspecting for water quality to make sure that clean water is returning to the plants and that clays are settling out as intended. This is a picture that relates a little bit back to what Mohammed described. So throughout the embankment, there's various locations where there's piezometers or wells that are installed into the embankment and into its foundation, monitoring for conditions that were depicted in the design flow nets. And so these piezometers have a water level that's standing within them. They have minimum and maximum prescribed by the design. And we go out and the geotechnical inspectors read these piezometers on a weekly basis, and then they upload those into a database where they're analyzed and reviewed. The picture on the left is of an individual holding a water level indicator. The water level indicator has measuring tape on it and a sensor at the end of it. The sensor will set off a chime whenever it encounters water, and then the inspector can use that to record the depth to water. This particular zoomed in photo on the right depicts a depth to water of 41.72 feet. They would take that back to the computer, upload it into the database, and record it with their weekly reporting. So this is a slide that's an example of a piezometer water level reading. The line in orange is the clay settling area water level elevation, and then the darker blue line is the water return ditch elevation, with the lighter blue line depicting the water elevation in that piezometer. As you can see, as time progresses, the water level in the piezometers tend to decrease. Going back to Mohammed's topic, that's an increase in factor of safety. So as these areas are filled with clay, their stability improves with time. In addition to those inspections, they're also operating the CSAs to control vegetation around the spillways. They'll use weed eating and herbicide for walkways, maintain safe access for personnel and visual inspection. Ditches and pipelines are much the same. They'll mow the slopes using specialized slope mowers. The picture in the top left is a typical farm tractor. However, it's got dual wheels on the back axle to improve for stability while mowing slopes. It's pulling behind it a batwing mower, and they generally mow most of the slopes using these battling type mowers. However, we also utilize articulated boom mowers in the top right. This is a typical mower that you might see in county roadside maintenance, maintaining roadside ditches and things like that. It is specialized. And then the image on the bottom is of a typical CSA after mowing. So they're going to mow the crest, the swales, and the downstream features, as well as slopes. There are also earthwork repairs that the geotechnical inspectors are identifying and then conducting repairs on. So these earthwork repairs would be erosion or washout repairs. They clean ditches of sediment. The image on the right is of a wave erosion that was repaired using earthwork and senior construction specialists. We'll talk about them in a little bit. They're also repairing, as we spoke about, the crest road drainage using motor graders and maintaining the crest road drains. And then they're also revegetating slopes following earthwork repairs. Those are part of the best management practices to control water quality on our sites. In addition to the non-technical staff, we also have several professional staff within the group that are involved in operation maintenance of clay settling areas. So we have a superintendent of geotechnical operations. They're a Florida licensed professional engineer. They manage the inspection team, the clay disposal planning, and they coordinate the annual inspections of third-party professional engineers. They review the findings of the inspections and then relay those for repairs and action.
So there's a senior engineer within the group. The senior engineer interfaces with mosaic engineers and consulting engineers. They develop new CSA designs under the current regulations and engineering standards, working with third-party designers.
There's an engineer lead, geotechnical, myself. I provide overarching technical guidance to the team, interface with mosaic engineers and consulting engineers, aid in planning, operation, maintenance, and reclamation of CSAs. And then there's the director of geotechnical practice area, also a licensed professional engineer, aiding in the resource allocation and planning, providing technical leadership, and managing the workflow. We also have technical support staff. We have 2 construction specialists. Both are former geotechnical technicians with 20 years experience each. They support the senior geotechnical technicians. They manage CSA repair projects that would require equipment of more than 1 or 2 days. They support construction of new clay settling areas, perform inspection audits of the senior geotechnical technician staff, and then we also have a licensed FAA drone pilot, and I'll talk a little bit about how we're employing technology on inspection and maintenance. Supervisor of the CSA inspection team is a senior geotechnical tech, or former senior geotechnical technician and construction specialist, also holding in excess of 20 years of experience. This individual coordinates for inspections, reviews the findings of inspections, triages repairs, provides CSA construction support, manages the workflow, and coordinates maintenance contractors, mowers, slope repairs, crest drain repairs, etc. This is just an example of how we're utilizing technology to evaluate existing conditions of clay settling areas. This is a video that was taken using our thermal imaging drone, and it allows us to detect conditions that aren't visible to the human eye. So with that, I'll let this end, and I will introduce Lisa Landon. Lisa will talk a little bit about clay settling area reclamation.
Thank you, Keith.
Good morning, Commissioners. My name is Lisa Landon. I am a reclamation superintendent at Mosaic, and I've worked in the industry for 23 years. Over the course of my career, I've had the opportunity to hold various positions supporting our operations. This morning we've heard an overview regarding general operations, beneficiation, and what a clay pond is, why we need CSAs for our operation, how these areas are designed, and how they are used. I understand we're going to have a separate workshop to talk about our general reclamation techniques. So today I'm here just to highlight and focus on reclamation, or what happens to these areas after they've reached their operational capacity. These areas are typically reclaimed as pasture for agricultural uses, tree plantations, and other upland and wetland uses that serve as wildlife habitat. The reclamation process for these areas takes approximately 4 to 5 years from start to finish. And the plan is made up of various phases, starting with general dewatering, allowing for crustal development, followed by revegetation, earth moving, reconnection of these areas back to their watershed, and finally, formal closure. To briefly recap on general operation, clay is introduced into the clay settling area as a very dilute solution and settles to the bottom of the water column relatively quickly. And at that point, the clear water is decanted through the spillway, structures that allow water to gravity flow to our water recirculation system for operational use. So this slide illustrates the initial filling of a CSA and the typical spillway structures we use, which you've seen several times this morning. This also illustrates the dual use of these areas. One, to store the clay, and two, they are utilized as a water reservoir for our operational needs. Once a certain fluid operating level is reached, the area temporarily no longer receives clay and is allowed to consolidate or rest for a certain period of time. This consolidation creates additional storage and allows us to keep the CSA in service for continued use. Once the clay has consolidated, the area is returned to active operation and filling will continue. While resting, the clay is pumped to another CSA for storage, and this process is called stage filling. This allows for the maximum utilization of the pond, and these structures are several hundred acres in size and very expensive to construct. So we only build what's necessary for our operations and use them to their maximum capacity. Eventually, the CSA reaches maximum design and is ready to be reclaimed. This slide shows an area that's currently in the dewatering phase, and water is being decanted through the spillway structures. To initiate this, we open up the spillways and allow for water to flow to our clear water ditch associated with the CSA. Each one of these ponds has its own designed clear water or recirculation ditch associated with their operation. This particular ditch associated with the CSA is part of a larger recirculation system that encapsulates the entire mine. Water moves around our facilities through a series of designed ditches and conveyances and is only allowed to be discharged off-site after water quality criteria is met and only through a permitted NPDES outfall. Well, once gravity has done all it can do for our dewatering efforts, the remaining water is removed with a mechanical pump, again through the spillway structures, reporting to the clear water ditch. Well, clay likes to hold on to water, so to help with the next phase of reclamation, which is crustal development, we ditch the clay surface to allow more water to be removed from the area. And this is through the introduction of rim ditching, which you can see on this schematic. And those ditches are located very close to, initially very close to the dam wall. And this allows for, again, additional dewatering and crustal development to begin. And as the clay dries or desiccates near these ditches, the surface is dried enough to allow machinery to work from the dam wall to the further to the interior of the CSA. This slide just shows a couple of examples of typical machinery used to install the dewatering ditches. There's no special equipment that we use. We do use the use of mats for that initial ditching, but again, as the surface is dried, it does hold, machinery is held up on the surface and able to work the surface effectively. This slide shows some examples of the effect of ditching inside the clay pond. The upper left photo shows us the beginning stages of dewatering with these established ditches, and the lower left illustrates the intermediate phase. You can see the crust beginning to form, and the photo on the right shows an area that's been effectively dewatered. The crust is formed, which will allow for equipment to operate on the desiccated clay. The clay is now ready for revegetation. Well, we begin our revegetation process, ironically, with vegetation removal. Techniques used for this include herbiciding, mowing, and burning. As with all of our reclamation areas, we are required to revegetate these CSAs according to an approved conceptual reclamation plan, as well as other various agency permits. The dewatering process takes approximately 20 to 24 months, up to 2 years, to complete, and as the areas are dewatered, revegetation immediately begins to grow. Much like your yard, if something is disturbed, vegetation moves in, and often it's not the vegetation that you had intended. So what we do is go through a series of maintenance procedures to remove that undesirable vegetation and then replant according to our plan. So this slide just shows us mowing activities with, again, typical equipment used on the clay surface. Well, the reclamation plans for the majority of the CSAs are as improved, as pasture areas. The hay grass is typically used. Other land uses to a much smaller extent, but do include forested uplands, herbaceous and forested wetland systems. We do have some mitigation requirements for wetland construction on these clay settling areas, but due to the length that they're in service, those are primarily associated with older permits. Due to the length of service for the CSA, we typically do not build wetland mitigation on our clay ponds because we like to have them in service for as long as possible. The reclamation plans for the majority, I mentioned that already. The orientation and height of CSAs vary depending on the position in the landscape and operational design. However, once vegetation is established on the interior or the clay surface, the dam walls are contoured just above the dried clay surface and the material is pushed to the inside of the CSA. This creates a gradual transition from the post-reclamation design to the outside of the CSA footprint. The contouring phase is completed with typical earth-moving equipment, and here are a couple of examples of the type and size of the machines that we use. Revegetation of the contoured area is completed in sections immediately following earthwork to control any turbidity that may be caused from stormwater runoff. To the left is a photo showing the staging area for the mulch that's used during the revegetation activity. And I have a short video on the right, I'm not sure if it's going to play for me, that shows the seeding and disking that's followed by mulching on the contoured side slopes. So, I'm not sure if it will. This was a small, just a very brief video clip showing the dispersal of the seed, the disking using the farm tractor, and then we follow up with mulching activity. Well, once our side slopes are seeded, the areas are allowed to establish. And what is seen here is a side slope of a CSA with full vegetative cover in the foreground, transitioning to a forested upland area in the background. And you can see that by the location of the pine trees. As with all our operation and reclamation activities at Mosaic, we employ a number of measures, or B&Ps, like we like to call, best management practices, to control off-site turbidity in the event of a rainfall event. These measures include silt fence installation, single or sometimes double row, depending upon our activity, hay bales that reinforce the silt fence installation, straw wattles for additional filtration, and mulching and grassing of the newly disturbed areas to establish ground cover as quickly as possible. During construction, we perform daily inspections of these B&Ps, these measures, to assure their integrity through the establishment of revegetation. And at this point, we've discussed dewatering, contouring, and revegetation inside and on the side slopes of the CSA, and the area is now ready for reconnection to its watershed. Just as the size, shape, and orientation of the CSA is different, its reconnection location is different as well. And the reconnection is a specifically designed notch in contoured side slope that allows for surface flow from the reclamation area to the adjacent wetland. Once the connection is built, pre-connection water quality sampling is performed to assure the water leaving the site meets water quality standards, and the FDP is notified of the reconnection. After the reconnection is established, Mosaic will request formal closure, which is certified by a professional engineer in the state of Florida. Since this is a reclamation area, just like any other type of reclamation, we must meet reclamation standards for the CSA according to Chapter 62C16 of the Florida Administrative Code. And what that means is the area will continue to be inspected on a quarterly basis to assure the vegetative communities that were planted are according to the approved design and other agency permits. Those areas are inspected until all vegetative requirements are met, and the area will then be released from further reclamation obligation. So that was an overview of typical CSA reclamation process. I'd like to just walk you through a couple of some time-lapse aerials to see how it all progresses. So this first slide will begin with dewatering a CSA. This particular site is located in Hillsborough County in 2010, and you can see the majority of the water is located on the eastern, northeastern section of the clay pond. Moving to 2011, you can see the water still moving to the spillway, and I'd like to point out the location of the clear water ditch and the spillway structure, which again is part of a much larger conveyance system around the mine so that no water at this point will be directly discharged off-site. Water quality is monitored and must meet established standards prior to discharge from our property and may only be discharged through a permitted NPDES outfall. We move on to 2012. It shows us dewatering is relatively complete. Here we are most likely finishing up with dewatering through the spillway with the use of a mechanical pump. 2013 shows us we can see the initiation of rim ditching to pull the additional water from the clay and allow for desiccation or crustal development. You can also see vegetation naturally recruited into the area as shown by the majority of the clay settling area shown in green. Well, lots of activity from 2013 to 2014. We see ditching activities moving farther into the interior. The spillway and clearwater ditch have been removed. Mowing and vegetation removal of undesirable species is ongoing. And initial work on the connection has begun as well. And we get to 2015, we've now completed contouring the dam walls, we've revegetated the outside, and the reconnection has been fully established. There are always questions regarding the utilization of these areas in the post-reclamation condition, and you'll hear much more about that in the following presentations. However, I'd like to point out the reclaimed CSAs are an intentional part of our overall reclamation and landscape design. We incorporate these areas to serve as productive wildlife habitats, as well as provide potential opportunities for agricultural and commercial uses. This short video shows us one of our reclaimed clay settling areas in Polk County. Now, I'd like to point out the diversity of the established vegetation and habitats created in this area and how the CSA has been incorporated into the previously mined landscape. I thank you for the opportunity to share this information about our reclamation process for these particular areas, and I'd be happy to answer any questions you may have at the end of the presentation. I think now I will transition the podium to Bill Bramall, and he will be discussing wildlife utilization.
Thank you, Lisa.
Thank you.
Good morning, Commissioners. Hopefully it is still morning. We've been at this a while. I promise you I have no graphs, I have no scatter plots, I have no crazy engineering drawings, hopefully just pretty pictures and that talk about wildlife utilization of basically the active mining operation. Well, maybe I want to back up. I'm Bill Bramall, Senior Manager of Mine Permitting at Mosaic. I have over 25 years experience in the environmental permitting field, 10 of that at Mosaic. Prior to the manager of mine permitting position, I was the lead ecologist. So in that position, a lot of my responsibilities revolved around management of wildlife during mining operations. So mining wildlife are a constant present in the landscape. Wildlife will oftentimes beneficially use a lot of our operational areas, and one of those areas are clay settling areas. So here, again, I promise you pictures, no graphs or anything, so I'm going to be going through a lot of pictures and just trying to explain what are on these pictures. So what you see here in this picture is the spillways that we've been talking about quite a bit. You have quite a few the white birds there in the foreground are least terns, so that's actually a state-listed tern species, and they will beneficially use settling areas to forage. And what's unique about the spillway structure is that where that intake structure is, there's an inflow of water that attracts small fish and invertebrates that they can forage on. The other picture you see on the right are 3 or 4 different species of ducks. So it looks like there's teal, wood duck in there, maybe a gadwall, and you see a great egret in there in the background, and then a bald eagle foraging over a CSA. Again, not a graph, just pictures, I promise. Again, more ducks. These are migratory ducks, I'm sorry. And you'll see that duck there in the foreground. It's a pretty unique duck. It's that white-fronted, it's a bufflehead duck. Again, you get those in migration, fairly common residents of CSAs. And you see more terns foraging over CSAs. So there's a pretty active prey base for them to forage on, and that's why they're present pretty often. Again, some more pictures. What we have here is you see a wood stork on the left there. So wood storks are pretty unique in the amount of distance that they fly, and they typically soar. They use thermals to soar, and they could soar 70 to 80 miles, traverse from foraging areas to their nesting areas. So we get a lot of wood storks that use thermals and take advantage of the CSAs. And again, you see alligator at the top in the picture there, and then that is a cattle egret, again, just soaring over the CSA. Alligators are pretty abundant in CSAs. If you've ever taken a tour of CSAs, they're fairly numerous, and a lot of that has to do with they're very opportunistic feeders, so there's a ready available prey base consisting of mostly tilapia, and sunfish species, bass, brown bluegill. They'll also forage on wading birds that are unlucky enough to be on the edge of the settling area. So what this picture is depicting here, as CSAs, we've talked about them kind of getting toward the end of their beneficial life. So as they get toward the end of their life, shrub species become established. And what you see in this picture are mostly wax myrtle and willow shrub species that wading birds, we've documented nesting wading birds in, and it's a pretty common occurrence that they will nest in CSAs toward the end of the beneficial use. You see there, the top picture on the left is a great blue heron. The other two, top right is anhinga, and then below that is a little blue heron. So again, these are all actively using CSAs to nest. In addition to CSAs, wildlife beneficiaries will use other water features within the mine site. What you see here are on the right are hooded mergansers, again, a migratory duck species that is opportunistically using a water recirculation system. And on the left, you see that that's about 20 or 30 or so wood storks. So wood storks have a pretty unique way of feeding. It's called tactile location. So what they do is they forage in open water bodies with their beaks just slightly open. And as soon as they feel the contact with prey, usually a small fish, they collapse their jaws and forage that way. Another unique requirement they have is that they rely on the dry season drawdown in Florida. Typically in the dry season, the wetlands become drawn down, and it concentrates prey for them in smaller pools. And that's actually what this BMP ditch here is doing. These are designed ditches that flow up and down with the water table. So this is toward the middle of the dry season. What this ditch is doing is concentrating a prey base for them that they beneficially use. Again, just more representative pictures of white pelicans and looks like anhingas or cormorants, tough to tell in that picture on the left. They're using a water management area. And the other picture on the right are, again, more wood storks and actually eagling in the middle, adjacent to a mine cut area. So most of what we've been talking about is wildlife using CSAs, but again, wildlife is a pretty common occurrence through the course of the life of a mine. What you see here are inland nesting birds. That's a least tern and actually a chuck-will's widow. There's always historically been a segment of the tern population that nests inland in Florida. And what the terns do here, and we have other nesting birds that use sand tailings areas. So this is the tailings that is pumped back to fill the open mine cuts. Unfortunately, these are temporary habitats because the tailings are temporary until the permanent land use comes in. It could be a forested upland or wetland or native area. But what we decided to do is and operationally these become a problem because if they're in a sand tailings area, then we basically have to stop work. They're state listed species, so we have to wait till they nest, barricade them off, and basically work around them. So we had a unique opportunity in the Four Corners Lonesome area. This is at the corner of 674 and 39. We had a post-reclamation lake that was in the landscape, but we also had some excess sand tailings and overburden. So we decided, we were wondering if we could create and mimic this beach nesting habitat, and that's what we did here. So we created an island. It's a small island, it's only about half an acre. But we tried to make it attractive for least terns to nest. And they did. So we managed this area, we keep the vegetation pretty much off of it. And we did a study about 3 or 4 years ago to see if we could get terns to nest, and again, they did. So we documented over 30 nests on the site. At one time or another, there was over 70 adult terns that were using the colony. And I think I have a video. Can we play that? I'll try and play it from here, see if this works. So and what you're seeing here real quick, this will be like so we set up some trail cams on this island to capture and document the nesting. We might have played that. And so what you have here is courtship behavior, basically. So these are least terns. You see the male giving the male some a small fish there. And you can see the net just barely getting ready to sit on it now. And then I'll go to the next video. Oh, it's the same video. Here we go. Now this is the next video. You'll see this chick. This bird is sitting on the net. No, hang on. This is a good thing. So that bird is on the nest. Again, obviously they're ground nesting species. Oh, there. Oh, it's so close. So I'll try it one more time. If it doesn't, I'll just move on. It's actually on the nest, and this video captures the actual young hatching from the nest. Oh. That's okay. I'll move on. Well, anyway, so we banded multiple juveniles from the site. Of the nests, we had about 10 successfully fledged, and we got bans on 4 of them. The interesting thing about this study is there's a active, birding community that once you band a bird, it has a unique ID, so it could be tracked to where it was banded. So we documented banded birds at this site and other inland sites at 4 or 5 different areas. The furthest one we got was on Anclote, which is about 60 miles from where it was born. And again, on the Mosaic Turn-On. I was going to finish up with just briefly going over some other areas that provide recreational wildlife use. These are older mined and CSA complexes that were mined well before, or for the most part, before 1975, the mandatory reclamation rule. One of those areas is the Tenor Rock Fish Management Area. That's in Lakeland. It's a complex of about 8,000 acres of, again, it was mostly mined before the mandatory rule, so it's open mine cuts on spoil areas. But it is managed by FWC, and it's a very productive bass fishery. It also has recreational opportunities, hiking, archery, sporting clays, multiple recreational activities available there. The other area I want to briefly talk about is 7 Wetlands Park. This is in Lakeland. Again, the majority of this area was mined, 50, 60 years ago. In 1985, the city of Lakeland bought this property to use it basically as filter marsh system for its effluent. And so what it does, it kind of serves as the final polishing for their effluent, but they've also recently added hiking trails and nature trails to it. I think I end on a video. I didn't have luck with the other video. So again, this is just some drone footage showing a CSA area. You'll probably see some wading birds flying over and a gator or 2. With that, I'll be around for questions afterwards. I believe Mr. Bart Arrington is next, so I'll allow him to mosey on up there. Thank you all. Appreciate it. Thank you. You don't want to read that.
You might want to hear it again. Good morning, Bart.
Good morning, Mr. Chairman, County Commissioners, County Attorney, County Administrator, friends, family. My name is Bart Arrington, and my title is the Senior Manager of Land Management. I'm based out of Wauchula, and I'm glad that the short part of the presentation is over. I'm going to lead you guys through the last 3 hours, okay? So basically, the first of that 3 hours is a test. You guys saw the graphs. We're going to have a test in a little bit. But kidding aside, it's not fancy words.
Well, anyway, when the slides come up, what I wanted to do was kind of take you through past, present, and future. You guys seen a little bit of that throughout the presentation on some of the agricultural uses that have taken place on CSA specifically. I know in time we'll have another reclamation presentation. You can talk about other reclaimed land, but this will be specifically to clay settling areas. And so the past, I'll start with a study that was done that occurred over a 10-year period done by FIPR. And it was conducted from 1985 to 1995, and the results published in 1996 on that. And what it did is it looked at several different crops in several different areas, and some of those crops included watermelon, cucumbers, snap beans, tomatoes, and the slide we showed up, so I wouldn't have to read it, but anyway, so it was a list, and you can certainly read the report yourself, of different crops that they tried in different areas, and the goal was to make sure you could, number one, grow it and grow it safely. So, what did that study show at the end of the day? Well, it showed that you can grow these things successfully at a commercial rate on clay settling areas. And, of course, there are challenges, and it's noted in this report, and, but they did note that the reasons why some of these things worked as well as they did was because of the nutrient content in the soil. It has phosphorus in it, so it doesn't need additional phosphate added to it. And because it's clay, it does have the ability to hold water a lot better than sand. Of course, it has its own management challenges, which we'll talk a little bit about later. So some action photos from that time. Why hit that too fast? Right, Mohammed, you hit it too fast and it goes right past it. So we're using conventional equipment to prepare the land. I promise, I'm not mashing up on it. So,
Are you messing with him, Sylvia?
I would. If I knew any better, I think JC was mashing about it. So anyway, this shows kind of some pictures. It looks pretty typical to farming operations that you see on non-clay settling areas, but and you can grow it just like it. But like I said, there are some differences in that. And so anyway, since it wants to go here, this is where we'll go next. So that's the past. What we did in the past. What are we currently doing? We continued some of those things that you saw on the first slide since then, and continued doing some of those on different clay settling areas. And this is a list of things that are currently on clay settling areas. We certainly have grown some things since then, but this is what occurs currently. And the first 4 of those are trees, and those are different. There are different reasons why we planted those trees. Some were studies that the University of Florida asked us to conduct. Some of them were like the eucalyptus. We were approached by the mulching industry to plant them on clay settling areas, and Pongamia just so happened to be a good Pongamia tree salesman, because I really don't know what the end market is for that. So, but we have them, and they grow very well in a lush state. Indigo, we were approached by some indigo folks. We tried that actually on mined land, mined and reclaimed sand tailings land, and on clay settling areas, and they perform actually better on the clay settling areas probably for various and sundry reasons, probably because of water holding capacity and the nutrients. And the last 2 are not ours. We don't have cattle, but we have a lot of folks that do lease some of our land, and some of that is on clay settling areas for cattle. And then blueberries, which we grow blueberries, but we don't grow them on clay settling areas. In fact, a company out of Bartow called Clear Springs does that on clay settling areas. So these are some pictures of our areas that we do, and I guess it doesn't like the pictures. So anyway, the middle picture shows a kind of a distant shot coming up to an area, one of the areas that we have clay settling areas planted with eucalyptus trees, and it's looking north, and that those trees in the background are the eucalyptus trees, and as you get closer, the picture on the left-hand side are those trees, a portion of those trees, and they're about 4 or 5 years old. And then the center bottom picture is Pongamia. It's not in this area, but it's within driving distance, or the close driving distance of the eucalyptus. And these grow exceptionally lush on the clay settling areas with almost no effort, no maintenance. From time to time you might mow through it, mow around it, but that's really it. With no maintenance, nothing added to it, no irrigation, these trees grow on their own. Of course, There's a lessee, actually kind of close to where these eucalyptus are, to the south of where this eucalyptus area is. And they have some cattle and they have leased in. There's hard to see the cow pens in the back, but there's certainly cows and cow pens and back behind there. So that's what's going on right now as we speak, and you can go out there and see these right now. So what does that mean going forward? We talked about some things that were done in the past. Well, what are you guys thinking moving forward? And this is actually started a couple of years ago. We've identified some clay settling areas that are in different forms of being reclaimed right now. You heard Lisa talk about some of those techniques, and we have a couple of areas, all told about 1,800 areas roughly, that are in various stages of that reclamation. Actually, one of them is pretty close to being finally released and being reconnected. All the vegetation work's done. In fact, we're going to have to go back afterwards and remove some of the undesirable before we make it available for agricultural use. And then there's one that they're doing the earthwork now and starting the vegetation removal and planting on that area. So we're trying to use some beneficial grasses that Lisa had mentioned, the Haya, and we're also trying some other ones that grow on clay settling areas as well, like alfalfa. And then, well, the question then becomes, well, what about ones you've already done? Well, that's a good question. It's a fair question. Like the study that was done in the mid-'80s to mid-'90s, we're going to prepare an area where we can do different crops than the one that had been studied before, and begin the commercial operation side of things. The study showed that we could do it. Now we need to take the next step and showing that we can do it and develop some best management practices so we can do it and do it in a commercially successful way. So that is what that 50 acres is designed to do, is test that and develop our commercial operations on. So if you go back to the study, the director of FIPA director of Reclamation Research at the time says, what's really needed now is an entrepreneur with the resources and courage to seize the opportunity to do that. And we are. Thank you.
Thank you, Bart. All right, we've got just a little bit here before we break for lunch, so I would like to go ahead and invite one of our county presenters to come up, and our first one will be Mr. John Delishaw. If you would let us know where you're from and what your qualifications are, and then we might have a couple questions we can squeeze in for you before we break for lunch.
All right.
Good morning.
Good morning. Thanks for having me here. My name is John Delishaw. I'm a professional geotechnical engineer with the Root CPWG. I've been practicing in Florida since 1991. Transplanted from San Diego into San Diego State to get my bachelor's of science degree. I've had a lot of experience in dam design, working on mines, also just water storage facilities, and then a wide range of other geotechnical practices.
Thank you, sir. Okay. I think we've got some slides to pull up for you.
Okay.
Hopefully they work.
There you go. Yeah, so Madrid was selected by the county to serve the interests of the county and the residents of DeSoto County, and we're part of a team that includes, again, myself. Today we have myself, Brian Murphy, Alba Moss with Hydro Solutions, and Michael Mosley, who's an independent consultant. We also have, for other workshops, Monica is another firm that's on our team. But our role is here to serve the county's interests. I wanted to have everybody give a little bit of background. We don't really have as much of a slideshow as was prepared. We could start with background from everybody, or go through however you'd like to do it.
That's fine. Yeah, if you want to go ahead and make the other
Brian Murphy is our professional geologist. Brian?
Good morning, Brian.
Good morning, everybody. My name is Brian Murphy. I have a bachelor's degree in geology and master's in business administration. The bachelor's was Miami University out of Oxford, Ohio, and the master's from Florida Southern. I've been working in the phosphate industry in ore control geology, mines planning, mine operations, and in the consulting business for waste planning, mines planning for going on 40 years. Professional geologist with the state of Florida since the late 80s.
Thank you.
You bet.
This slide come back up?
Good morning.
Good morning.
I'm Alba Mas. I have a degree in landscape architecture and a bachelor in civil engineering. I'm a professional engineer in the state of Florida. I have 35 years of experience. I've worked for the Southwest Florida Water Management District in regulation for 30 years. I oversaw the environmental resource permit program and the water use permitting program. I've since retired and worked for Dewberry Hydro. I've been with them for 2.5 years. I have a lot of experience reviewing permits, and even currently with Dewberry Hydro, I do staff support for the City of Plant City, and we're looking forward to helping you review the Mosaic permit when it comes in.
Thank you, Mayor.
Good morning. My name is Michael Mosley. I have a degree from Colorado School of Mines in mining engineering. I did 12 years of experience in the mining industry. I started out as a mine laborer, working for the outstanding wage of $2.65 an hour. Worked up through mine engineer, and my last job as a mine engineer was chief mine engineer at one of the phosphate companies in Central Florida. After that, I did 20 years of mine reclamation. Reclaimed over 200 different projects of various mine reclamation projects. And then following that, I moved to Jamaica and Suriname and built dams for 10 years. So much of my experience has not been so much as an engineer as has been in production, actually getting the job done. I'm not a scientist. I've done quite a bit of engineering along with building reclamation projects and dams. That's pretty much mine in a nutshell.
Thank you. Has anybody ever called you a dam engineer?
A what? Probably.
My joke's only much better than that.
So again, our experiences with the geotechnical engineering, design analysis, phosphate mining permitting, hydrogeologic assessments, financial impact analyses, reclamation, and also permitting experience. And our role is a support role for the county and the citizens. We're here to have an experienced ear and eye to watch what's going on, to look at things from a different perspective possibly, and provide some expertise, some balance, and some public assurance. The clay settling areas, as we've learned a lot this morning, I think Mohammed's presentation has done wonders in terms of spelling out the whole design process from beginning to end. But bottom line is it goes from you're constructing over previously mined land, restoring these clays. There's a lot of the engineering design and analyses to develop those. There's a lot of inspection. But the clays, they're so fluid, they don't give up water. It takes a long time for them to consolidate, which is why it takes a long time between when it stops using and its reclamation process. We've talked about the life cycle of the clay settling area, ending with the active reclamations that we just talked about. Me personally, my direct experience, when I came to Florida, the picture on the top right is what's now known as the Hines Energy Complex, but it's a power plant built on formerly mined lands. And I had the fortunate experience of about 2 years of doing inspections, testing sample collection, both on dams and in the actual clay settling areas themselves, and learning what it's like to walk and fall through the clays. So with the risk with the clay settling area, what do we have? A release or a breach, potential flooding associated with that, groundwater quality, water loss, sinkhole development. There's radioactivity is something that CSAs don't have, but sometimes there's a misconception of such. Surface water quality. And most of these things are accounted for through the research, the inspection, the field investigation, and the design process. Albert.
I listened to all the presentations that were done at the last meeting you had with Mosaic, and I heard a lot of concerns about risks. I'm familiar with the integrated water use permit. I was in the district when it was issued. I know about the metering and all the reporting that has to be done. So that will be something I will support what we will have to be doing here in DeSoto County. The environmental resource permit issued by DEP, I've become familiarized with that. I know there's a lot of monitoring, wetlands, etc., which is not, it has not started yet because there's no permit from DeSoto County. We have somebody on our staff who oversaw the NPDES program at DEP, and so he will be very familiar when that is issued and making sure that we integrate any of those issues when we review the permit application here in DeSoto. And so we will be making sure that well contamination, wetland impacts, impact to legal existing users, which are all addressed in the ERP and the IWAP permit will be reviewed, and that those agencies are actually reviewing any kind of complaints. And we also will be reviewing, I heard a lot of complaints last time about past compliance issues. We will be reviewing that as we go forward and probably coming back to you if we find anything.
Thank you. Andy, you have something you'd like to share with us a little bit about the way we're going to approach this when we come back from lunch?
I just thought that I would maybe provide some context to the county's teams, our expert team. So we didn't ask them to put together a large presentation knowing that Mosaic had put together an extensive presentation on the facts of the piece. But what we did ask them to do is to bring the expertise to the table, but as the commission has questions or the public has questions, but predominantly the commission's questions are answered in a balanced fashion where we have the professionals here from the mining industry to answer them, and we also have our professionals that do not have any skin in the game with the DeSoto applications going forward. So the predominant piece is to give you balance of qualified individuals from both sides that you can take consideration. And while one may answer, there may be a different answer, a different perspective coming from the professionals that we've invited to present to you today. So I just wanted to clarify that it's more for the board's balance than it was to make an actual presentation. And we've had a couple of calls. We all had a joint call as well to kind of coordinate today's meeting, and I appreciate them, and I'm glad they're here for us.
Great, thank you. I know I've got quite a list of questions, and I'm sure that my peers up here have the same. So what we'll do is we will begin to pose our questions, and we would like to get some input from our qualified professionals that we've invited, and then we'll also give the applicant an opportunity to give their answers as well. So we actually do have a little bit of time before we break for lunch, so we could go ahead and start with that. I'll ask if any of my peers up here would like to take the opportunity to read through your list of things you've noted down and maybe start. If not, I can go ahead and start us off with a question. And then after we get back from lunch, we'll be hearing from the public as well. I'm sure we'll come up with some more questions. So one of the things I'll ask, and so the folks that are here representing the county, whoever, if y'all look around at each other and voluntold one who's the best one to answer, that would be a great way to work out who comes up. One of the reoccurring themes that I picked up today in a CSA is that the water doesn't move through the clay very readily. I kind of already knew that about clay. Just thinking about recharge area, the way that all this land has normally recharged groundwater, and then post-mining, if you have a large CSA, it seems like that would almost be impervious surface, so the footprint of that CSA would no longer really recharge, just from what I've gathered here. I'd like to see if you could kind of comment on that question. So if you have a section of land that's primarily filled with clay, how is that watershed going to wind up recharging the groundwater?
You're correct in that the clays are not pervious, and so even if you reclaim it and put something that's more pervious that will sustain the vegetation growth that you want, essentially the clay settling area has a consolidated clay that has very low permeability, so recharge directly down is not going to happen, but what's going to happen is you're going to get runoff. That's why they do that reconnection to the watershed, so it's really less indirect infiltration over that footprint and then more runoff because it won't seep into the ground.
Do we know, are there some studies that we know of that are available that speak to the long-term effects of having multiple thousands of acres turned into impervious surface, essentially something close to a parking lot?
Not that I'm aware of.
However, as part of the water use permit, they're required to have monitoring wells, and the district and Mosaic will be assessing those elevations. I mean, part of giving a water use permit is that it cannot impact off-site, and so those water levels are monitored, and reports are given monthly, and somebody from the district goes out and checks if there's any discrepancies or anything like that.
Okay, thank you. I would give an opportunity to the applicant too, if you could shed any light on that question. If there's a difference between what we traditionally call impervious surface, which would be like a Walmart parking lot, and a CSA that's been finished its useful life and it's turned back into pasture or something. If it's not absorbing water, where's that water going and what's that doing to the recharge?
Well, clay is not impervious, it's a low permeability material to start with. So it's not a parking lot, it's not asphalt.
It's almost impervious, right?
Well, I mean, it has hydraulic conductivity of what, 10 to minus 7, 10 to minus 8, 10 to minus 9 centimeters per second. But let me answer your question. I'm assuming you're talking about infiltration down to the Floridan aquifer, recharge to the Floridan aquifer.
Basically, what my question is we all are having kind of an increasing awareness that there's water quality and quantity issues in the state. So I'm thinking about how does that affect us in the future?
So So the geology of Florida typically, and even in DeSoto County, comprise of what we call superficial aquifer. That's a superficial sand, the upper 40, 50 feet. Then that followed by a confining unit, which has intermediate aquifers. And then you have the Florida aquifer. That's our drinking water aquifer. So on the superficial portion of it, water will flow, and when they do mine reclamation, a big portion of these mines are filled with sand tailing actually. And the sand tailing will provide you basic flow to the stream. So that rainfall goes into that sand tailing and recharges your stream and where you have sand tailing areas. And water will flow around these clay settling areas because we're only filling the superficial there, that portion, what you saw in the mine cut. And part of that, if you look at some of my slides, we still have sand tailing. And when you have these spoil piles and we push the cast, you still have some layer that it is sand, that it recharges from the perimeter, sand tailings, and it recharges, it allows that flow to continue. So that's on the superficial aquifer. Then you have the Floridan aquifer, and that what separates the superficial from the Floridan aquifer is the confining unit. And you recharge to that, the Floridan aquifer is controlled by the confining unit permeability, which is predominantly clay. Calcareous clay, and it has some production zones there. But if you're looking, and we've done calculations to estimate what the downward recharge into the Floridan aquifer.
I mean, we get about 53 inches of rainfall in Florida. How much do you expect that goes to the Floridan aquifer? It's about an inch to 2 inches that infiltrates to the Floridan. And that flow will continue to go either through these sand connections that we have at the base of the clay settling area, or through the clay itself. Infiltration or downward flow is a function of two items. One is the hydraulic conductivity, but two is the pressure. And as you're putting 50 feet of the clay above the grade, that's more pressure pushing water down. And all you need is 1 inch to recharge the Floridan aquifer. I don't believe there is any documented impact into the Floridan aquifer from these clay settling areas.
Okay, thank you. I have another kind of a follow-up question along that same line, but I'd like to give an opportunity for one of y'all to interject if you have any ideas.
I think I had one question for Mike and Scott, the first presenter. We had a slide that showed kind of the clay settling pit and then the reclamation and how that tailwater and runoff went back and forth. And then on the bottom of the slide, it shows that the tailwater can either go back into the CSA, and I was kind of curious on what the purpose would be once it's been through the reclaim to go back into CSA. Is there testing standards that allow that to run back in? Is it not good water to be released? Just kind of want to understand that.
So I'm not exactly positive, excuse me, which slide you were looking at. I think it was probably the one that showed the process. Yeah, okay. So if you saw on there, we have about 2% fresh water input into our process. So that's groundwater, well water. The rest of it is recirculated. So the reason that we can bring water back to our CSAs is because that's what allows us to limit the amount of groundwater that we need to use by recirculating it. We only discharge when we have an excess amount of water. So we are actively managing our water inventory, recirculating it back to the CSAs, maintaining levels where we can minimize our groundwater pumpage. Did that answer your question?
I believe so. I mean, I just following your flow chart and kind of how it went different directions here. The other question I have is, look at my notes here. As far as, and I don't think it's directed for you, but as far as like the reagents and the, let's see, like the fuel and stuff like that. I mean, mining's been done here for many years. Is there studies of how long it takes for that to break down? Because we know it takes a longer period to,
Commissioner, unfortunately, there is no study that I am aware of that talks about specific degradation time scale within CSAs, but I can definitely say that petroleum hydrocarbon definitely degrades over time, and the microbial population that degrades that actually enriches itself when they're exposed to the same conditions year over year over year. So that's how bacterial cultures are actually cultivated in the laboratory, by feeding the same substrate over and over again. So only the population that kind of thrives on that kind of food can only grow. So it's fair to assume that in the clay settling areas, the microbial population that you have that's been exposed to the petroleum hydrocarbon related residue for the longest time, and they have thrived, and the population has been optimized to the point that it is now very efficient for degradation of the hydrocarbon.
okay. And then I think there was just in recent weeks here, there was a breach of a pipe going into a CSA, is that correct? Or was that to a sand hills? That wasn't talked about. I just want some clarity there.
Hi, I'm Beth Denise. I'm the senior manager for environmental at the 9 sites in Florida. And I think what you're referring to is in early October, we had a sand tailings line break, so it was not related to clay settling areas.
Okay. And then, as far as the sand tailings, that doesn't go to a settling area to settle out?
Correct. No, the sand tailings are what's used for the reclamation process. So in that diagram that we saw, the sand tailings went to reclamation, the clays went to the clay settling area.
Okay. Thank you. Respect.
Thank you. I've got another question I'd like to ask for our folks. It kind of dovetails off of my last question. So, setting aside the issue of recharge area, you have a CSA that is a pretty large area, quite a number of acres, and it appears that conceivably after reconnection, there's going to be more water shed off of that land than there was before the mining process took place. So, are the powers that be in our governmental regulatory bodies, are they monitoring the volume of water moving down those tributaries after reconnection? And how does that affect the folks downstream when you have, potentially considerably more water running into the tributaries off of those CSA mounds once they're complete and reconnected?
So once it's complete and reconnected, there's a period of time after which it's released. After that, you would think that since you've already monitored it, what's being released is typical of what would have been released after it's done. The environmental resource permit looks at the water quantity as well as the water quality. And so that is part of what's being monitored during the operation of the mine. And at some point to be able to release it, you have monitored for a period of time after it's complete, therefore that should be what you expect to be draining off the site.
So is it expected that it would be consistent with the historic surface water flows from before the CSA was constructed?
In the environmental resource permit, that is what you look at. You make sure that you're not decreasing or increasing because you have wetlands and other things that depend on that water. But also in the water use permit, you're also monitoring what's going on the site for the aquifer and for surrounding lands, and making sure you're not impacting anybody that might be dependent on, I believe, the Peace Creek Authority Peace River Authority came in and talked, and we had concerns. And that's part of what's being monitored in the water use permit, to make sure none of those legal existing users are being impacted.
Once they finish the life cycle and things are reconnected, do you know if there's generally a design for retaining stormwater beyond that, or is it just considered back to kind of a natural state where water just goes where it may, like it did before it was mined?
I will let them answer, but the answer should be that you would once you've created the new natural system, what's draining off that land is what would have been draining off to begin with.
Okay.
That you're not putting, for instance, more water in one direction, one tributary that went one direction and the other, which I'm thinking is what you're concerned with.
Right, yeah, it just seems to me that if you have a big area that's a mile by a mile and it's primarily has a clay surface, that it's not going to soak up water like it did before. So I'm thinking that water's got to go somewhere else. And are we holding it up, or is it? I don't have a clear comfort level with it not changing from the way that it was, invented by nature.
I'll let you guys address.
And the reason that this strikes me is because I've built parking lots, and when you build a parking lot, you have to have an area that takes the stormwater. You got to hold a certain amount of it, and you can't just let it run off and be your neighbor's problem. So I know that a clay settling area is not a parking lot, but we have established that it's fairly impervious. So I just want to understand that better.
So as part of the ERP application, there was a pre-post, takes into account the reclamation plan. The reclamation plan is actually built around two things. One is, replacing the land uses that are required by rule. The second is to reestablish the pre-post balance in terms of drainage characteristics. So as part of the ERP permit, Mosaic had a couple of studies done that look at the overall pre-mining landscape. It's done with a program called ICPR. It's used across the state of Florida. Takes into account land use, soil types, different rainfall durations and scenarios. So you establish the front end, what the pre-mining conditions are at different locations, and then you design a reclamation plan around and demonstrate through modeling the post conditions that those runoff characteristics and flows are similar. And that was done. That's what the basis of our reclamation plan is for DeSoto. It's all incorporated. There's storage built into it.
From the millions of gallons from clay slime lakes, if these berms breach. Mosaic's answer too many times is, we will monitor, we'll have inspections. In 1992, Tropical Depression 1 dropped 25 inches in our county. Roads were washed away. A number of us were trapped for up to 2 weeks. In 2003, Horse Creek was over 15 feet. In 2015, Erica, some roads were underwater. 2017, Irma brought 1.5 feet more than what was forecast. 72 was close. And this is just a sampling of the many storms we've had that are potential for damaging the berms and forcing flooding. In 2004, we had Charlie, a wind event, Francis rain, Jean rain. There was no power. All cell towers were gone. There were no phone lines. How on earth can this even be considered this additional threat to the lives and properties of the citizens of this county that these massive raised slime lakes will cause in lesser events? How can it be justified to release turbid water that will flow into our water supply, impacting fish nurseries or Charlotte Harbor? Why should the residents here have to be put in a position that's impossible in the storm evacuation of families and for many livestock? Mosaic and their plans are not compatible in a populated community. Please remember our safety when deciding. Remember our health and welfare. Okay, and then I'll just add, since I seem to have more time, there is no amount of radiation is safe, and the concentrated amount in the clay it will will be a danger to those who living around it. They show pictures of wading birds. They are attracted to large bodies of water, but that does not mean it supports them. They could be wasting valuable energy and weaken from staying instead of seeking a sustainable resource, becoming gator bait. They have permanently changed the They will permanently change the hydrology of the area with these berms, and depending on treatment, effluent that from the pulp industry, I was looking it up while I was sitting here, is either toxic to fish or at low, and that's at low levels, or when processed, it still can change the diversity, it can cause a diversity shift. And then there's the herbicide that can wash into our waterways as large areas are treated. And thank you.
Thank you, Ms. Sarah. Next, I'd like to ask Mr. Henry Coleman to come up. Good afternoon.
Chairman, Commissioners, Attorney Khan, I have 11 questions. My comments are in the form of questions to Mosaic. I request the Commission ask Mosaic for written responses backed up with supporting data. Number 1, Heather Nedley, Mosaic executive from Arcadia, wrote in 2018, every acre of land that is mined must be either returned to fully functioning natural systems and habitat or returned to agricultural uses while reconnecting historic wetlands and streams. Question is, Mosaic, do you know how 7 square miles, 4,300 acres of CSA toxins and clays up to 90 feet deep and 7 stories high will comply with Mosaic's reclamation standard as stated by Heather Nedley? Number 2, Mosaic, do you know of any reason why DeSoto should not ban CSAs and beneficiation float plants from their county like they did gypsum stacks? Number 3, Mosaic, do you know what you will do with your CSAs in other counties and in DeSoto after 100 years, 200 years, 500 years? Number 4, Mosaic, do you know how DeSoto will benefit from CSAs that cover 24% of mined land buried, I think I heard today, 50 to 90 feet deep in toxins and clay so dangerous that they have to be segregated and contained forever? Number 5, Mosaic, do you know what reagents, chemicals, toxins, radioactive materials, and waste products have gone into each of your CSAs? Do you know the quantities of each? 6, Mosaic, do you know what harm the toxins and clays you put into CSAs cause to microorganisms, plants, animals, and human beings? 7, Mosaic, do you know what chemicals are created by degradation of reagents and chemicals you put into your CSAs over time, which could also include benzene, a cancer-causing agent? 8, Mosaic, do you know if there will be a time when there no longer exists a danger from your CSAs and the toxins bottled up inside? 9, Mosaic, do you know all chemicals, nutrients, toxins that leave your CSAs through outfalls and breaches include quantities by volume and time? 10, Mosaic, do you know what percentage of waste in your CSAs will come from Manatee County mines? 11, Mosaic, do you know all chemicals, acids, nutrients, toxins, insoluble solids, radioactive materials, reagents, degraded pollutants that seep out of your CSAs through the sides and bottoms over time? Answer this question for the following ages of your CSAs: 10 years, 50 years, 100 years, 300 years, 500 years. Thank you for your time.
Thank you, Mr. Henry. Next, I'd like to ask Ms. Wanda Klopp to come up. Good afternoon.
Good afternoon, Commissioners and guests. My name is Wanda Clough. I'm a mom. Nature needs a miracle. We need a miracle. We need a miracle to stop the demise of Florida at the DeSoto border. We need this Board of Commissioners to stop this destruction and annihilation of thousands of beautiful Florida creatures and acreage. This beautiful land will be turned into future dead zones by phosphate mining processes. Once destroyed by drag lines, there is no reversal of fortune for us. There is no going back. We need a miracle. Thank you and God bless.
Thank you, ma'am. Ms. Nancy Armstrong.
Thank you, Commissioners. Nancy Armstrong, I live in Ona. The slime pond proposed for the DeSoto mine covers 4,200 acres, 8 enormous clay plugs that will loom 66 feet high, straddling State Road 70 and bordering Horse Creek, and requiring an extreme amount of maintenance. As the USGS German study 1997 states, quote, clay slurry wastes can have high concentrations of phosphorus, trace elements, and radioisotopes associated with waste solids. These are effectively trapped in slime ponds, but some material can solubilize after settling and infiltrate through the bottom of the pond into underlying groundwaters. I had something else planned for the rest of my thing, but from what I've heard this morning, I just wanted to address a couple of the issues that struck me most. The presence of the presentation so far is how immense, invasive, and requiring such high maintenance these huge CSAs will take. With all the engineering and analysis involved, what happens in a catastrophic event, when the computers break down and things can't be monitored every minute. Why so drastically change our native land and hydrology for the profit of a private company? Will they be here to complete this life of CSAs they create? How long does it take for one CSA to reach closure? How in the world can a reconnected, reclaimed, immense clay settling area not impact the surrounding low-lying areas when it's reconnected? That even to my non-technical mind, I have to wonder how that is even possible. That water is going to go directly into areas that are already prone to flooding. So I hope you will consider what your people are saying down here, because this is affecting all of us. And, you know, we're speaking from a lot of research that we've done ourselves throughout the years, fighting this in different counties. We're trying to save DeSoto County, and we hope you listen to our side of the picture. Thank you.
Thank you, ma'am. Next, Diana Whitman. Good afternoon.
Good afternoon, Commissioners. My name is Diana Whitman. I'm going to yield my time for an introduction to my husband, Dr. Rich Whitman.
All right.
I'll be introducing Dr. Whitman momentarily. My name is Phyllis Boychuk. I live in Punta Gorda. I'm the Charlotte County Dem Environmental Caucus Chair. A read letter sent to DeSoto County Commissioner Chair sent from Dr. Julie Peller, Professor of Environmental Chemistry at Valparaiso University. This relates to the data that will be presented by Dr. Richard Whitman following me. Dear Chair DeRiso, Dr. Richard Whitman, State Science Officer, Democratic Environmental Caucus of Florida, recently asked me to evaluate a 1997 groundwater quality report by the United States Geological Survey. In response to the concern of many Florida residents about an application for the rezoning of agricultural land to phosphate mining. I'm an environmental chemist and have worked on a number of water quality projects throughout my career. From my background experiences, I can offer a number of relevant statements for consideration. The list of chemical contaminants identified from the 1997 analysis is extensive, and many of the contaminants are not water soluble. This can mean that they will contaminate well water for a long time, since the contaminants will remain in sediment and other environments that are in contact with the water. Many of the identified contaminants are toxic, and it is important to know how long these leach into groundwater. Signed, Dr. Julie Peller. I would like now to introduce Dr. Richard Whitman. He is a recognized expert in water sciences, public health, and toxicology. He has written over 150 peer-reviewed scientific and technical publications, which have been cited in over 6,300 professional peer-reviewed publications. Dr. Whitman worked as a research manager for the United States Geological Survey for 20 years, where he supervised other ecologists, technicians, and clerical staff. I will donate any remaining time to Dr. Whitman.
Could you tell me your name one more time so I can find your card again?
Yeah. Phyllis Wojcik. I might have said Phil.
Thank you.
Thank you.
All right, Dr. Whitman. Yeah. Got 2 time slots. Good afternoon.
Good afternoon. I'll end this later. Okay.
Ms. Sylvia, he's got a handout for us. Could you grab that from him, bring it up? Thank you.
I can send something electronically as well.
Okay.
As Phyllis said, I spent 40 years in water sciences, 20 of them in the USGS, NASA, university professor, and National Park Service. So while I'm not a groundwater specialist and will not pretend to be, I am a scientist and managed many scientists over the years and have been proud to be part of the United States Geological Standards Survey, who has an impeccable reputation of science first, policy and politics last. In this presentation, I come to interpret and report to you. I initially thought that I'd be going too technical, but after this morning, I realized you guys can digest just about anything. Notice my eye, I don't have that much eye candy. Okay, you can go back one. Okay, this is the area of study for the USGS that they did in 1987 by a fellow USGS friend of mine named Rutledge, who works out of Washington now. They drilled 11 wells and looked at the superficial and sometimes deeper fluoride well waters in reclaimed areas. This is what they found, okay? They found that for arsenic, iron, manganese, mercury, selenium, all exceeded drinking water standards, unlike what was told you this morning. Now, that may be back in 84, 87, okay? But it's on the industry to show you that it's different today, or will be different when they come to DeSoto. They also found chlorine, naphthalene, phthalate, which they also use as one of their chemicals, amines, or is an amine, benzenes, naphthalenes, and iodine. Where could it have come from? Perhaps, probably, from diesel, or one of their petroleums. Those all exceed the numbers. Next, item number 2, the one study that was referenced just by Phyllis, a 1997 study that was done nationwide of crop, urban, and mining areas. These are all taken from reclaimed areas. Some of them right next to clay pits, some of them in old cuts. They didn't specify. These are the areas that they sampled. I think that it comes out to be about 36, 37 wells. But the ones I want to point out are the one by Bradley Junction and 2 on the east and also on the east side and the west side. These were taken because the hydrologies are well known. The two on the Peace River are coming down, draining into the Peace River, and the other is draining into some surface water by Bradley Junction. If you haven't heard about Bradley Junction, it made ABC News, U.S. News Report, and Los Angeles Times the day the water turned brown. More information, I'm more than glad to supply you with that data. But I'm going to show you some supporting information. And it's interesting that you have not, if you have not been informed of the data I've given you, I would want to know why the consultants nor the industry has made our permits writers have made you aware of these data. They're nationally available. These are the sampling areas. You can see the Bradley Junction Site 2, the two on the Peace River, one by the Peace River Park. This is the closest one to the Bradley. I sure would want to have the name Bradley associated with that particular location. It's quite a negative legacy. You can see they're filling in with solar cells. That's good. But notice they're staying away from the mining areas in the old settling times. These are the chemicals. Okay, it came up. Most of them are isomers of naphthalene and benzene. All, not all, okay, all but one are carcinogens, and some of them are linked to leukemia. It's a 33-foot well. Okay, so that is bad, but let's go to 11. Side 11. Look at that. Okay, phenol, that's bad stuff. Hexane, sulfur, some of it's cut off. Benzene, okay, these were all picked up at that well, right next to the clay mountains. Many, and I quote, well, this is Jewish, I won't re-quote it. Cited 25, even more, okay. Again, sulfur, probably natural, benzene, alkaline, phenols, okay. From USGS 1997, oil reserve residues could migrate to the groundwater under areas reclaimed using sand tailings. Also, some concern has been expressed that oil used as flotation agents could be contaminated by organic priority pollutants. I can give you those citations. Another study in the International Journal of Hydrology by Rita and about 12 other people said Peace River at Arcadia, Florida ranged from 0.6 to 2.2 parts per million. With the background, those are these samples below here, below the mining area, and then above the mining area. The background was 0.2 to 0.4, but down here, already it's 0.6 to 2.2. The drinking water standard is 1.5. It does cause bone damage. Also, they found significant lead, cadmium, mercury, chromium, arsenic, uranium, thorium, and radium in that citation. I will read more, okay? We had this Florida Southern University, a master's student that did study, where she released salt and she released bromine gas on clay mounds, okay, clay pits. And she discovered that the water coming off, you did ask about that, okay, moves laterally through channels and that become eroded, and she found, and she traced it all out, that it moves laterally over, through, and under the berm, and vertically through the thick, uncracked, massive substructure. She was in the loose cannon. She was a master's student, and she was funded by Mosaic itself. Why wasn't that cited? In Pepper Estates and Beavers, also another University of Florida doctoral student, I believe, there is no question that mining has impact on the hydrogeology of the shallow aquifer system and that watershed hydraulic characteristics. It gets pretty flashy. And around upper Peace River, springs have gone dry and so have wetlands. That area has gone from a discharged area to a recharge area. Later, Sang, who is the chair and Pepper of beneficiation and mining at Pepper was among the authors that were cited as saying, even basic hydraulic processes of the CSA are still poorly understood. Okay? And back to Rutledge, the superficial aquifer gets contaminated by seepage from sand tailings, slime pond, contamination of deeper aquifers by downward seepage can be accelerated by breaching the upper confining layer. That's how they drain the surface water so they can mine. They put wells down so they can drain into the intermediate layer. Beaver, again, the entire soil profile, this is his dissertation, is destroyed during the mining process. The substrate after mining will either be sand tailings, overburden, clay, or unknown mixtures of these components. And further, in the Journal of Environmental Engineering and Geosciences, currently, the regulatory agency and municipalities have no scientific means of assessing cumulative impacts of mining on surrounding biotic environment, including wetlands, wildlife, habitat, and flora, despite the pretty birds and alligators you saw. And this is my last point, okay? This is from Dr. Sang, who we visited with. This is 1922. Like, what? This is actually the call for abstracts that's going to be held in Helsinki next year. And
You mean 2022?
I did. Thank you. I misspeak a lot.
Okay.
In the call for abstract, the advertisement of it to his colleagues, phosphate mining and processing generates two major waste streams, waste clay and phosphogypsum, in huge quantity, emphasis mine. These waters are becoming significant financial and environmental liabilities for the industry, and they present a public perception problem as well. Thank you very much for having me.
Thank you, Dr. Whitman. Appreciate your information, and I will keep that. All right, Mr. Tim Ritchie. What would we do without cell phones?
We'd be in trouble. I would be at peace. Well, good afternoon, Commissioners, and everybody in the chamber here in the building. Before I get started, I'd like to take a moment of silence for a friend of mine from DeSoto County by the name of Julie Payne. Julie just lost her grandson about a week ago. And I believe he's about 23 years of age, and he died of bone cancer. Thank you, Heavenly Father. Well, I'd like to first start off by saying it was really nice to hear from Mohammed from Hardaby. Now, I've seen a lot of your signatures on many documents, sir. And you all put on a very nice polished show today for everybody here in the Turner Agricultural Center. I live down in Charlotte County. My name's Tim Ritchie. I am the citizen water czar, and I'm the founder and president of March Against Mosaic. I've spent 3 long years in Charlotte Harbor, in Charlotte County's VOCC chamber. And I would like to thank the city of Northport for creating the ordinance banning all phosphate mining activities in 2018. I'd like to thank our commissioners here in DeSoto again for creating the ordinance banning gypstacks. And I'm looking forward to Charlotte County creating an ordinance banning all phosphate mining. And that's happening because of the relationship I personally cultivated with the commissioners and the county attorney and county administrator in Charlotte County. And I don't want to see my hard work for nothing. I could get Dr. Zotolokin up here, top graduate from MIT. I could get Andy Maley up here, one of my head witnesses, expert witnesses. But all that Mosaic is going to do is rip every one of them down. 5,000 acres of seagrass, gone. Cause of CSA failures, overtopping, erosion, slope instability, external erosion, earthquakes. You all from Mosaic present up here like you are God. You're not God, you're just human beings. I assure you, we don't want a chemical plant where this square is. We don't want clay settling areas that look like this. We don't want a 2015 $1.8 million environmental fine in Charlotte County or DeSoto. 6 months after that, we don't want another 2016 sinkhole. Here it is. The Mosaic New Wales Mulberry 2016 sinkhole. We don't want this. Are you gonna, oh, and I heard through the grapevine, first time I'm telling anyone this, I was told that Mosaic presented DeSoto County Commissioners with the 2023 plan for the mine. That plan is not supposed to be delivered to these commissioners until 2023. Once again, Mosaic is going to bully all of us. And lastly, before I leave here today, there's a gentleman by the name of Daniel Albert. There's a police report I made with the Punta Gorda Police Department. I dropped this off to Sheriff Bill. I want to make it very clear to any water warrior in this building, you send me any violent threats to me, you send me any violent threats to anybody, and I assure you I'm going to have the FBI on your tail.
Mr. Tim, you're out of time.
Thank you, Commissioner.
Try not to interrupt you, but you run way over.
Thank you, everybody.
All right, Mr. David Adams.
And the FBI is on these threats.
It's left behind in place line ponds. Who's going to be paying the property taxes on that land? And who's going to upkeep the dams and all the structures that keep the water from flooding in the horse river? That's my 2 questions. Everybody else has done such a great job of bringing up all these points, and that's the only thing I haven't heard too much about.
Okay, thank you, sir. Thank you for coming. All right, next, Mr. Andy Maley.
Thanks very much, Commissioners, Attorney, Mandy. My name is Andy Maley. I'm a resident of Punta Gorda, 1444 Seagull Court. I have a master's degree in environmental science from Bard College. What you've heard today is a sugar-coated version of reality, decorated with pink balloons, colored ribbons, and a whole lot of BS.
And to support that statement, I'll cite the seismic movement underneath the New Wales gyp stack, which caused a suspension of their permission to expand the loadings on the gyp stack. The Bartow gyp stack, which split and continues to be a problem, shifting, and the Uncle Sam gyp stack along the Mississippi River, which is just sort of a big pile of jelly and is gradually leaning over and is being monitored 24 hours a day. No matter how Mosaic tries to tell you that the CSA designs have become more sophisticated, keep in mind they are still made of dirt. Yes, dirt. Huge piles of dirt. From 30 feet below grade to 60 feet high, 8 of them, almost a mile to a side, and they leak. And the slightest miscalculation in angles of repose or pressure gradients, no engineer is perfect. No computer is perfect. I'm sorry, I don't buy that stuff. Or flaws in arranging the dirt can result in catastrophic breaches capable of destroying all life in the Horse Creek and Peace River as it has in the past. It's happened twice on the Peace at least, and several times on the Alafaya. The Peace River and Charlotte Harbor estuary, one of America's most essential national estuaries, has never recovered from tidal waves of milky toxic sludge that came down from the north in a hellish tidal wave. Granted, it was before Mosaic's time, but it was Mosaic's forebears. Fisheries, grasses, shellfish, and plankton, the basics of estuarine life, have not recovered in over 50 years. The proposed CSAs will contain thousands of tons of waste fuel oil. Think of it as the Exxon Valdez sitting in the Horse Creek floodplain, enough to contaminate all of Charlotte Harbor, and enough to damage or destroy the Peace River Minnesota Regional Water Supply Authority, which we all depend upon for our drinking water, just downstream of the Horse Creek outlet into the Peace River. Billions of dollars would be needed to repair or replace the water authority's capacity and facility in years of time. The integrated phosphate process from mining to fertilizer to gyp stacks, including clay settling areas, releases millions of pounds of toxic waste annually. It's a clear and present threat to the biological integrity of downstream estuaries and to economic health of the heartland region and downstream coastal areas, which depend on healthy waters to support billions of dollars in economic activity. Mosaic stands to net $5 billion from the DeSoto mine, but mark my words, the people of DeSoto will not see a dime of that money. The billions of dollars in sustainable economic activity, I got about 3 sentences left. The billions of dollars in sustainable economic activity that Mosaic will displace with its destructive mining practices and degraded property values will not be made up by proceeds from the mine. That will go to shareholders and corporate executives and will be distributed across the country and abroad. One of Mosaic's staff, when cornered by Manatee County commissioners, was forced to admit that a new mine creates no new jobs. It just moves old jobs from other mines that are being closed down. I don't know why we're even here. This commission refused Mosaic's rezone request in 2018, and nothing has changed. We should end this farce of propaganda workshops and shut down the process today. Stand by your decision. It was the right one. Thank you very much.
Thank you, Mr. Mayor. Our next speaker is going to be Mr. Michael Zarzano. Commissioner Gross, if you would take the chairman gavel for just a second, I'm going to run to the restroom and I'll give you the next speaker cards if you would. I should be back before we move to the next one, but if you'll come on up, Mr. Michael.
Good afternoon, Commissioners, County Attorney, Administrator. My name is Michael Anthony Zarzano, and I'm here representing the County Congress of Florida. We represent about 4 or 5 counties in this immediate area relevant to the issue of phosphate mining. For any of the other whistleblowers that have contacted me, if you would like to make another contact, please do so at charlottecountycongress@gmail.com for whistleblowers. I would like to announce to you that there is an organization in Sarasota called the Sarasota Freedom Lovers. They have recently passed a resolution demanding that phosphate mining stop in the entire state of Florida. And this Thursday, we will be proposing another resolution to put this issue up on the ballot for the people of Florida to vote for. It is very essential that we, the people, have our voice heard. Many have died in and around the area of phosphate mining and are dying on this very day directly from the byproducts that have been released in the air in and around Mosaic mining. This is not a conspiracy theory, this is a proven fact. Many in these various counties where phosphate mining is taking place are actually afraid to speak out for reprisals, for fear of threats and damages. And the question we need to ask ourselves in DeSoto County and adjacent counties who are suffering the trespass of Mosaic with your pollution. You are sending your pollution into neighboring counties and you're committing acts of trespass, just as if you had a shooting range and your bullets went flying and killed cows. That's the same type of trespass you at Mosaic are committing. But who are we partners with? That's the question we must ask ourselves. Those of you who pay taxes in DeSoto County, you're being made a partner of the Chinese Communist Party, the butchers of Beijing. That's right. That is one of the business partners that buys the product Mosaic makes. The Chinese Communist Party. Blood on your hands. That's right. If you help facilitate this clay settling area in DeSoto County, blood will be on your hands. Have you ever thought about the atrocities that China is committing to this very day, at this very moment? Organ harvesting. Shall we help feed the Chinese Communist Party by sacrificing our beloved and spectacular state of Florida environment?
Mr. Michael, your time is up.
Clearly, there is contradictory testimony at this workshop. Brandon Mooney, we request that you get to the truth and contradictions about the toxin in this water. Thank you.
All right, Ms. Cynthia Compton. Good afternoon.
Good afternoon. Good to see you all again. The Bible says that even the rocks will cry out, and the rocks under Piney Point are crying out loud in here for the damage they've had to suffer. And the rocks under DeSoto County will cry out also if this is allowed to happen. The prayer this morning, sorry, I only have one contact and I can't even read my own writing hand. The prayer this morning petitioned for the Lord of creation for truth to be heard. And if you listen closely to the testimonies this morning and listen between the lines, you would have heard the truth. Allowing any practice of the clay settling areas and the strip mining creating a need for the clay settling does damage to the land. There were some very impressive degrees mentioned for the monitoring and the monitoring of this damage. Kind of like the degrees to repair the damage if you were to jump off the roof of your house. While doctors have degrees in the knowledge and ability to repair the damage to your body for a foolish decision, wouldn't it have made more sense to just not jump off the roof and avoid the damages? Where do you plan on obtaining the water? Does DeSoto have the means? What studies have been done to the damage to our aquifers and underground rivers that do exist, but still to this day remain unnamed. This water is shared by all surrounding counties of the state of Florida. Have you gone into conversation with your surrounding counties? Are they in agreement with this? Are you willing to receive the responsibility of the damages to the Charlotte harbor that dumps right into the Gulf of Mexico? It really, I mean, it's like, I feel like a broken record, came up with a few new words today thanks to the testimony, but how many times do we have to go over this? Is everybody not tired of hearing about how the people do not want this? The damage that it would do to the earth is not worth the risk. The pictures that were shown, nobody knows where those pictures were taken. I've seen the pictures. I saw the brochure out on the front table of the documentary that was so amazingly done called Phosphate that declares the damage to the people and the land. Thank you.
Thank you, Ms. Duncan. I know that it does seem like we're hearing a lot of the same thing over and over again, but I can't tell you how much I've learned personally from continuing to hear some of the same things. You can't always catch everything the first time you hear it, but we put it together, and it's a 3-year process that seems like a lot of redundancy, but I think that we are all learning quite a bit, so sometimes we're impatient, but we're learning. Next, I'd like to call Brooks Armstrong.
Brooks Armstrong, Omaha, Florida. There's a handout coming to you. You just have to look at the front page if you want to see where this is coming from. I wanted to talk about the fuel oil in these clay settling areas because the information I'm going to get to is from Mosaic's own 2016 Master Mine Plan, from a 2001 FIPR study known as Fate and Consequences to the Environment of the Reagents Associated with Phosphate Rock Processing, and also a visit that myself and others paid up to FIPR and to make sure that we understood this beneficiation process and this study accurately. You will see how the calculations come out, how much fuel oil goes in. This, I believe, is a very conservative estimate because the FIPR study indicates possibly quite a bit more fuel oil is used to produce these phosphate concentrate. The FIPR study says that 30% of the reagents go unaccounted for and are presumed to be released to the environment. Of that amount, most of it is actually going into the clay settling areas, 75%, 65 to 75%. That indicates, by my calculations, that about in the neighborhood of 7 million gallons of fuel oil will be released to the 8 DeSoto CSAs over the life of this mine, if this mine is permitted. The study indicates that fuel oil is of special concern because of its potential health hazard to human beings and its relative resistance to biodegradation. I want to sidetrack. I heard one of the Mosaic's experts earlier say that there are no studies to track this biodegradation, and yet he said that over a period of time it will degrade. This study indicates that over a 30-day period, the fuel oil degrades to 12% and then levels out. And Fate and Consequences seems to have some conflicting conclusions. On the one hand, the study says that there should be no concern in the environment for the use of flotation reagents. On the other hand, the statement also says that any conclusions with respect to the extent of fuel oil migration is beyond the scope of this project. The conclusion of Fate and Consequences says that Phase 3 of this project would be needed to make any determination of horizontal migration of fuel oil in the environment. I would have several questions for the commissioners to consider. Number one, can you be absolutely sure that 7 million gallons of legacy fuel oil or its constituent components, which are said to be bound up in the clay, will not make its way through groundwaters and into Horse Creek or the Peace River? You see my questions here. I'm going to skip to possibly the most important question. And that is, you have banned phosphate gypsum stacks in DeSoto County. As was indicated earlier, the other major waste stream from the phosphate industry is the CSA waste and the reagents that are disposed of in there. Would you even consider jeopardizing Horse Creek, the Peace River, by allowing for these perpetual repositories of chemical waste anywhere near your drinking water supply?
Here, here.
Thank you.
Thank you, Bruce. Ms. Carol Muller. Ms. Carroll still here? Yes, you are. Our resident historian. That's quite a hike from back there.
Yes, sir. Good afternoon, Commissioners, County Administrator, County Attorney. Thank you for this opportunity to speak to you today. According to the Florida Department of Environmental Protection, for every ton of phosphate rock, a ton of phosphatic clay byproduct is also produced. Approximately 100,000 tons of phosphatic clay are generated every day and must be contained. The conventional containment is called clay settling area, and you've heard a lot about them today. Since the beginning of large-scale, this is a quote, since the beginning of large-scale washing and desliming practice for phosphate beneficiation, over 2 billion tons of such slime have been accumulated, which contain approximately 600 million tons of phosphate rock, 600,000 tons of rare earth elements, and 80 million kilograms of uranium. And that is from a study done called the Ultimate Mineral Processing Challenging Recovery of Rare Earths, Phosphorus, and Uranium from Florida Phosphatic Clay, available to read by anybody. How Florida phosphate mining companies have already stockpiled this 2 billion tons of phosphatic clay. Why do we need any more in DeSoto County? How does it benefit our county? According to IFAS in their article, An Overview of Phosphate Mining and Reclamation in Florida, CSAs do not provide a stable foundation for buildings and so cannot be used for urban development. Although they remain wet, CSAs are not allowed for wetland mitigation because of unpredictable fluctuations in the wet-dry cycle. The most common use is pasture, although some crops have been successfully grown. This morning, one of the Mosaic presenters said that there was a misunderstanding that there were radionuclides in CSA waters in clay. I quote from Casey Beavers, some other people have quoted him as well. This is his dissertation from April of 2013. Phosphatic clay contained in CSAs have been shown to have elevated levels of radionuclides compared to natural soils. These radionuclides are believed to somehow become more concentrated by the mining and beneficiation process. Some of the CSA crops contain elevated levels of radionuclides. Please do not allow this in DeSoto County. We don't need these potentially toxic hills in DeSoto County.
Thank you, Ms. Carroll. Next, Richard Russell. Richard Russell here?
Yes, I am.
Yes, sir. How are you doing?
Great. How are you all doing?
Doing fine.
I'm Richard Russell from Port Charlotte, Florida. And there was an article in the paper today by Betsy Calder, nitrogen heavy in Charlotte Harbor. She glossed over much of the comment about phosphate. But the bottom line is, Charlotte Harbor is in trouble, and they did point that out. A few of the things I wanted to mention. Why is there nobody from FDEP here today to dispute or comment on the things that Mosaic has presented? Also, why is there no meteorologist here to talk about the weather patterns that have been around? One of the things is Irma came through Charlotte County, and the highest winds were 86 miles an hour up in DeSoto County. Charlie came through Charlotte County back in 2004, and it was a 150 mile an hour hurricane with gusts to 172 miles an hour. The representative said, well, we've got this thing set up so it'll handle 127 mile an hour winds. Well, category 4 is 130 plus. Who's going to stop that hurricane when it gets to 127 miles an hour? And what's going to happen? Why is DeSoto County reconsidering hearing a rezoning in 2023 when they turned it down in 2018? I can't fathom that. 5 people stood up there, or sat up there, and made a decision. Today, there's only one of you there that was there. And in 2023, after the 2022 election, how many of you all up there today will be there in 2023 to rule on this? We in Charlotte County are here to stand with those in DeSoto Countyans who will defend our waters and stand up and call out the commission to vote no in 2023. The only surefire way to prevent further contamination of our Florida waterways in Southwest Florida is stop Mosaic. When there is a leak in your water line at home, out between the street and your house, and your water bill goes up, that's the first sign you got a problem. But how long has that leak been going on? Well, that's what's happened with Mosaic in the past. They've had issues that were not visualized, not seen, not reported for days, weeks, and then FDEP's got to get involved. What's the damage done in a period of time? Thank you.
Thank you, Mr. Russell. Next, I'd like to call Mr. Tom Pafford. Mr. Tom, still here? There you are. Good afternoon.
How you doing? Commissioners, staff, my name is Tom Pafford. My address is 4152 Northwest North Road, Arcadia, / DeSoto County. My home is near the Peace River, and when it floods in the river, I am in the river. So I am part of the river. Earlier, a Mosaic rep said, with the hurricanes, they watch them very closely. I hope so. We all watch hurricanes very closely. As a weatherman in the U.S. Navy, we were accurate 50% of the time. Today, with all the technology, etc., that figure of 50% is still roughly the same. Clay settling areas are in serious jeopardy because of this figure. 50% accuracy. Hurricanes will always outsmart man, believe me. Hurricane Irma, 3 years ago, was my 23rd hurricane I went through in Florida. That's a bunch. I heard no mention today
from Mosaic about the pressure in clay settling areas. But simple mathematics, a typical clay settling area will be about 100 feet. And the pressure at the bottom of that area is 50 pounds per square inch. Now, if you want to figure out the typical person, what 50 pounds is, if you turn on your water spigot at home, that's roughly going to be 50 pounds. And to imagine that that pressure can be on a strata of Florida geology for, we don't know how long. We've said 100, 200, 300, 400, 500 years. We don't know. But we do know one thing. I believe this is a time bomb based on history, and I also believe that the Florida geological structure cannot handle this. Thank you very much.
Thank you, Mr. John. Ms. Jane Patrick? Good afternoon.
Hi. Jane Packard, 4152 Northwest North Road, DeSoto County. I was going to give my 3 minutes to Dr. Whitman, but he didn't need it. So I decided to come up and just ask you to please give a lot of thought to what he said, what Andy Mele said, what all these very educated, equally educated to their people have said. I think it's worth more than them because they weren't being paid to say it.
Amen.
So I'm asking you to do your job, stand by what you did before, refuse mosaic. Thank you.
Thank you, ma'am. Leonard Guggenheim. Leonard Guggenheimer. Good afternoon.
Good afternoon. I'm Leonard Guggenheimer. I am a resident in Charlotte County, and my address is 6301 Hawkins Street, Inglewood, Florida. And I'd like to just kind of touch on some of the things that have already been said concerning oversight. And there was a question about participation from the Florida Department of Environmental Protection. Where are they here? And also, will the U.S. EPA be involved with any of this oversight? So that's my comments. Thank you.
Thank you, sir. We are working to get the DEP to one of these workshops, our next one in January, so we'll be looking forward to having them here for an audience as well. Next, Ms. Vicki Steiner.
My name is Vicki Steiner. I live on Environmental Lab Street. I have a lot here, so I'm not going a tiny bit long. Why won't native trees grow on CSAs? Oaks and pine that are natural in the area. Why? The eucalyptus tree, I looked it up when Amy was talking, Mr. Arrington, is a terrible fire hazard, okay? Google this. When the leaves on the ground that are shed from those trees, this is a quote, when they heat up, they release flammable gas, which ignites into a fireball. That is a quote. So co-location commissioners now want to get to what I was going to say. Thank you for saying no to the chip stacks in DeSoto County, but we need to say no to all of this. Clay settling areas will be even worse. They call it clay settling areas, as if we believe that that's everything that's in them. The heavy metals, fuel oils, and radioactive components are what we know. We need to ask Mosaic what else is in there to leak and reach out till the end of time. We know that dirty oil in our cars is carcinogenic. We know that. They want to put 8 of these CSA monsters in DeSoto County and some near wetlands and crossing Christine Horse Creek. I know you've heard of that before. They are asking to build a CSA, I've been told, that's deeper and higher than has ever been built before, using a smaller hand footprint, using 1994 engineering technology, 27-year-old technology. You can verify that, I want to know. not taking into account climate change with stronger storms, 100-year floods occurring much more often these days. This is just crazy. Are we just a new experiment? I want to know how many gallons will be in each CSA. To my best estimate, and I could be off, I believe there's approximately 52 million gallons in each CSA. Please verify. I've been studying other dams and damage to that fast-flowing water that does for as much as 10 to 14 miles surrounding a community, if it breaks. Most of these dams burst in a matter of hours of breathing. They find it in the morning, and then in the afternoon it bursts. The area around this mine is much more populated than other mining areas. If it lets loose during a rainy day, how would they visibly be able to see a small leak starting if it's already to start giving way? We all know this county is not equipped for a large catastrophic event. What is their monitoring process exactly? Daylight only? I heard daily, I heard weekly, monthly. Which one is the real deal? Keith Allen said once a week. That's not enough. They also allow seepage in their plan. I'd like to get some more details on that. All of you commissioners have the power to turn this down, to protect our community from these CSAs that would be left for our children to deal with. You're the last line of defense. There is no one else coming to help stop this. This state is not going to come and save the day when there's a tragedy. There are already Superfund sites in DeSoto that are being ignored for decades now. The lives of thousands of people are all on your backs. Keep DeSoto beautiful, please. And I just have a couple quick questions. Mr. Arterman, did he say that they were built for 90-mile-an-hour winds? I thought I heard 90-mile-an-hour winds, or was it 127? And then, what kind of herbicides do you use? Roundup and their maintenance. How often is it applied, and how is it applied? Is it applied from the air, from the coving grass? That's all I got. Thank you.
Thank you, Ms. Baker. Next, Carrie Bowers. Ms. Carrie Bowers?
Yeah, she's going to be yielding her time.
Okay, she's going to yield her time to somebody else. I'll hang on to that one. Captain Paul DeGata. Appreciate you coming. I think some of your fellow fishermen had to leave. I hate that we missed them.
Yes, and Captain Paul DeGata, 2936 Peace River Drive, Punta Gorda, Florida, Commissioner, staff. As I always say, thank you for hearing from a downriver neighbor. We're, I guess, in a educational contest today, so I'm going to bust out my master's degree in public administration from Fort Hays State University. For you historians, that's where Custer left from. The head did a little bighorn. I also think I'm the only 1,600-ton sailing master in the room, so that too. But I also stand before you today as an eyewitness to the two most catastrophic events, man-made or otherwise, that occurred in the history of the Peace River. I lived on the river and saw the destructive power of phosphate spills of 1967 and 71, each caused by single CSA breaches. Aside from a state marine biologist under oath testifying the 71 spill killed 90% of the marine life in the 106-mile-long river, those single CSA spills wiped out dozens of species of fish and eliminated the seagrasses, building blocks of an estuary. I live on the river today, and none of those seagrasses have ever returned. They became the victim of phosphate legacy mud deposited there a half-century ago. Mosaic now wants you to consider a mine that has 8 CSAs along the banks of flood-prone Horse Creek that supplies water to parts of 3 Southwest Florida communities that are all in growth spurts. And we've had 2 Category 4 hurricanes pass through there since 1960. People sometimes forget Hurricane Donna. The only reason we're going through this nonsense is the threat of Mosaic filing suit, and to give them time to try and work their bad magic behind the scenes, like sponsoring DeSoto's Chamber of Commerce and manipulating who runs for office in 2020. Mr. Muhammad of Mosaic said they do a lot of testing. Well, you know what? So do the pharmaceutical companies on opioids. But the profit part of that equation prevented those tests ever seeing the light of day, and then we had an epidemic that 500,000 people have passed from. Those seepage sensors. Do they work as well as a turbidity monitor that Mosaic claimed was tripped by a cow in a Charlotte County meeting? Commissioner Gross asked about lingering effects of the clay. The Mosaic rep said eventually they break down. I think degradation was the term he used, but knew of no studies. Well, in 31 days, we will visit the anniversary, the 50th anniversary of the 1971 phosphate spill. That clay, that legacy mud has still prevented seagrasses from growing back, and that's killed more, that's never let things into the system that should have been. All those fish in their CSAs, they'll never match the deaths of those fishes that already occurred. We were, just last week, the Washington Post did a story on the Peace River and Mosaic. So we have national attention now. So the nation is watching us, what we do here. You made the right decision. Stick to it. Thank you.
Thank you, Captain Paul. Janet Funnerly. I might not have said that right, but it was you. You know it was you. I have one of those last names.
It's very Irish. Good afternoon, County Commissioners and everyone. My name is Janet Fennessy. With Mosaic's phosphogypsum stacks receiving most of the media attention, it must have been easy for another equally nefarious aspect of phosphate mining, clay settling areas, CSAs, to stay under the radar. With respect to the environment and those living in the state of Florida, CSAs, clay settling areas, provide multiple layers of some of the most dangerously toxic chemicals, disguised behind candy-coated terms like reagents, for example, fatty acids, fuel oil, sulfuric acid, ammonia, radon gas, etc., to be deposited deeply into the Florida landscape and aquifer for years, probably centuries to come, with a protracted outcome of morbidity and mortality. But what about all the new jobs that will be brought to the area? Yes, there will be new jobs, many of which will be in the healthcare, as there will be a significant need for oncology units as the environment becomes increasingly toxic from Mosaic. Thank you for your time.
Thank you, ma'am. Rachel Kern. Good afternoon.
Good afternoon, Rachel Curran, St. Petersburg, Florida. I'm a Florida licensed environmental attorney, and I work with People Protecting the Peace River. I'm here on their behalf. I just want to start by, got a lot to fit in 3 minutes, but I just want to start by saying we shouldn't even be here today. I brought this up before. I brought this up at the time that you guys signed that settlement agreement, but if it wasn't obvious before, it is now that that new rezoning application has been filed last week, or the week before. We're in a quasi-judicial setting right now. We're in a quasi-judicial posture. An entire day-long workshop with extrajudicial contact and communication between the applicant and the decision makers is highly inappropriate. It doesn't matter if you sign an agreement that provides for that, you're still violating the constitutionally protected right to due process that potentially interested parties, substantially affected persons, anyone in the public at large, we're violating those due process rights by having all of this extrajudicial exchange of information outside of a quasi-judicial setting. It's the equivalent of a judge ahead of the trial talking to the parties of the case. So I want to make that very clear. I brought it up before, but now that we have that new application, it needs to be said, and we object to that, and now you're aware if you weren't already before. Moving on to the CSAs. We've heard a lot of, not too many studies were cited by the applicant or your hired consultants, but the ones that were by the Florida Institute of Phosphate Research, and you're going to hear a lot of that from Mosaic because that's the majority of the science concerning phosphate mining. And I say science broadly, I don't really mean it's real science, because none of that, the vast majority of that is not peer-reviewed research published in respected scientific journals. It is simply an arm of the industry. While it is state-funded, don't let that confuse you. It is by statute, by Florida statute, those research directives are decided by the industry. A committee of 3 people, 2 of them are industry reps, 1 is an environmental representative apparently, always outvoted by those 2 industry reps. So it is the industry that is determining those study designs and those priorities. So that's why when you ask a question about, is there a study on this impact? The answer is going to be no, because it doesn't benefit the industry to study those. So please realize that not all studies are created equally. When you're comparing one study versus another, and one is peer-reviewed and published in a scientific journal with an extensive peer-review process, that should be weighted more heavily than a paper study that is basically a white paper, a trade organization sort of document that is designed to help the industry make more money, be more efficient, not make us safer. Just another quick point, something that really bothered me was there were a few pictures of some lease terms, and this to sort of support the idea that endangered species and wildlife love CSAs. That's not competent and substantial evidence. But what is would be a scientific peer-reviewed study, such as 2002 Mashinsky and McCoy, who looked at the biodiversity of all the species that were available on pre-mine lands, compared those to post-mine reclamation lands, and found biodiversity was drastically reduced. There are species that are gone and they never come back. And that's there's no disputing that. So a few pictures of some birds that happen to be on a random CSA doesn't mean anything. Got a lot more, but I've only got 3 minutes, and that's part of the problem.
May I yield my time to Rachel Curran? The name is Janice Ippolito.
Let's see. Didn't we already do your card?
No, sir.
No? Let me see.
It's okay.
Thank you, Rachel. I think our county attorney would like to respond to one of the things you mentioned.
Just very briefly, Mr. Chairman. As Ms. Kern indicated, Mosaic did file its rezoning application, I think it was last week or the week before. Any property owner in DeSoto County can read 1 year has passed if their initial application has been denied. Any property owner can do that. Mosaic filed an application for rezoning. That application has been stayed. That is, review of that application has been stayed. There is no review of that application going on at this point, and there will be none until at the earliest 2023. We are not in a quasi-judicial hearing here today. We're in a workshop. The discussion that is going on here today is for the purpose of sharing information, allowing the public to learn about the issues that are being discussed, allowing the commissioners to learn about these issues and to ask questions. But none of this discussion, none of the documents that are being submitted will be part of the eventual quasi-judicial hearing that will be held. This is not part of a quasi-judicial hearing. It is a workshop. Thank you.
Thank you, Tom. Next, Garrett Rainey. Good afternoon.
Hey, good afternoon. I brought my silver bullet here, just in case there's any werewolves lingering from Halloween. needs of the video. I'd like to give this to the county commissioners. It's a file. Up there, sir. It's like, the one that says planning. Hi, good afternoon. Garrett Ramey, 1205 Taylor Road in Mayaca City, Florida. I prepared a short video here, and I'm actually going to run it just a minute over. And I think Kerry Bowers is going to yield that time to me.
She did mention that to me, so.
Okay.
Gotcha.
Okay, great. Oh, thank you. Okay. All right, Garrett Ramey, 1205 Taylor Road, Mayaca City, Florida. Hello, Commissioners. Today I've traveled from Manatee County to share some concerns that bordering residents have living next to CSAs. We, the citizens of Manatee County, have our eyes closely affixed on DeSoto County for two reasons. Number one, Mosaic has land in Manatee County that cannot be accessed without approval from DeSoto County. Number two, every citizen that has lost their property values due to what Mosaic does is looking for a safe place to relocate. So we are monitoring very closely what is occurring in these workshops. One of the issues that we're having in Manatee County with phosphate mining is that once mining is approved, there is no negotiating or addressing issues or modifications that can be implemented. The white noise and the campaign contributions from Mosaic has made the county tone deaf. Manatee County has an additional branch of government dedicated to phosphate mining called Mining Services. Even with this government department in place, the citizens are left stranded when we question or inquire about any of the activities in the areas associated with phosphate mining. There is zero transparency. As you can see in this video right here, this is a CSA that's within 2 miles of my home. This is just the area, there's miles and miles of piping that we're concerned with. One of the issues we're having in Manatee County is when the phosphate mining is, once it's approved, there is no negotiating, addressing issues or modifications that can be implemented. The white noise and the campaign contributions from Mosaic have made the county tone deaf. Manatee County has an additional branch of government dedicated to phosphate mining called Mining Services, as I mentioned. Even with this governmental department in place, the citizens are left stranded when we try to question or inquire about any of the activities in the areas associated with phosphate mining. There is zero transparency, and even in the worst, dealing with the FDEP bodyguards. There was a couple questions here about, regarding FDEP, and FDEP is not here to protect us. This is why the citizens like myself are constantly monitoring activities in the area. The citizens feel that they are neglected when they attempt to report violations, request investigations, or modify mining ordinances to provide protection, and primarily, as I am attempting to convey today, an early warning to a catastrophic event. I'm here today to share firsthand what it is like living near phosphate mining in a CSA. I have one within 2 miles of my homestead. I am sharing these issues that we are facing, attempting to coexist with phosphate mining and how it has destroyed our community. Before approval of the Wingate East Tract of Manatee County, this was one of the concerns that I brought before the county commissioners during the quasi-judicial hearings. That concern was an early warning system to notify bordering residents of a catastrophic failure. For the last 5 years, we have been requesting that a system be put in place so that an incident like the one that occurred during Easter weekend of the evacuation of residents near Piney Point could be handled more effectively. A better example, Mosaic's sinkhole incident in Mulberry, or the phosphate mining accident that occurred in Brazil, wiping out an entire village with its when its tailings dam broke loose. Hundreds of Brazilians lost their life that day. These CSAs are very large and they contain a chemical cocktail reagents that Mosaic claims to be proprietary knowledge. Our local emergency services should have a list of all these ingredients so they know how to combat it. There is also miles of piping to be concerned with. It is not just day-to-day operations that we're concerned with. We are more concerned with a catastrophic event like a Category 5 hurricane. We are also very concerned with seepage into the groundwater. Many citizens have shallow wells in the area. As in the video, you can see that they are mining right behind the CSA. I don't know how intelligent it is to dig down 70 feet next to a structure that is elevated. Also, the transportation of these chemicals. We have had several incidents that would have never occurred if this industry's best mining practice didn't utilize and produce so much toxicity. I am encouraging DeSoto County to implement an early warning notification system and have this in place prior to an approval. Some of the suggestions would be a registry of the bordering residents, text alerts, air raid sirens, signage around the area of the CSAs, and access to the emergency broadcasting system. There's one thing that the applicant cannot be allowed to do, and that is to sugarcoat the threats that are posed from this industry's best mining practices. I want to thank you all for asking some really great and intelligent questions here today. This did not occur in Manatee County. Am I out of time?
I don't think the second buzzer.
Okay, 20 seconds. I just wanted to mention that we were protesting Mosaic's renewal permit for expansion of Lake Wales. On that day, FDEP and Mosaic was telling us how impermeable their liner is, how it's acid resistant, and on that same day, Mosaic filed with FDEP regarding a tear in their liner. That's all I have to say.
Thank you, Garrett.
I've also...
You ought to be an auctioneer, you can speak for
I got to get it out. Look, I've left my contact information here with some information, and if anybody would like to come meet with me, I'll give you a toxic tour of the area and show you what we're dealing with out there. So you'll know firsthand, okay?
Thank you, sir.
Thank you.
Okay, next, Bob Block and Jeremy Block both yielded their 2 cards to Miss Cheryl Burlon. She's got a little presentation. Oh, can you come up to the dais? Do we have a copy of your show?
I'm saving my time.
Yes.
To Emery Pullman.
Oh, okay, well, I think Henry's already done this.
It's a video that we turned in I talked to you about.
Oh, okay. So we'll play your video, Cheryl.
Thank you.
Do we have it?
Yeah, it's loaded.
Most of the attention with phosphate mining is directed towards the phosphogypsum stacks. Everyone can agree they're the biggest threat the industry poses to the environment. But there's another facet of this industry that has a dirty little secret that gets very little coverage. We're talking about clay settling areas. This is where the industry dumps their leftover clay after they extract the phosphate rock. The process of extracting the rock is done in a beneficiation plant, usually located next to the mining site. There's very little known about this process because rarely, if ever, gets investigated. The only study that we've seen about how the industry separates the phosphate rock happened 20 years ago in 2001. It was titled Fate and Consequences to the Environment of Regions Associated with Rock Phosphate Processing. And it was prepared by BCI engineers and scientists. Regions, by the way, is just a fancy word to describe the additives that the industry mixes with the rock to get it to separate. The first step in this process is to float the phosphate rock in a mixture of fatty acids and fuel oil used as a collector. The phosphate industry uses about 120 million pounds of fatty acid and double that quantity of fuel oil per year. After the first step, the phosphate rock still contains 10 to 20% of sand, so further upgrading in sand removal requires a second flotation that is accomplished by floating the sand using a cationic collector. Before this can be done, the residual fatty acid and fuel oil must be removed using a sulfuric acid wash. There are dozens of other reagents used in this separation process, and they include ammonia, amines, acetic acid, alcohols, glycols, and terpenes. All total, the Florida phosphate industry spends about $50 million per year to purchase a range of beneficiation reagents, and it is speculated that the ultimate fate of up to 30% of these reagents is unaccounted for and may be released into the environment. For every ton of fertilizer produced, the industry uses about 4.7 pounds of fatty acid, 12 pounds of fuel oil, 4.3 pounds of soda ash, and 1.8 pounds of amines. The reagent that's the biggest concern is fuel oil, and when the phosphate industry separates the clay, sand, and phosphate rock, the clay absorbs 65 to 80% of all these reagents, so it's safe to say the clay settling areas is where most of the fuel oil and other reagents end up. Clay is a coagulant, which means it sticks to impurities in water. are 4 times more radioactive than normal. They also give off radon gas, which we all know can cause cancer and harm the environment. The phosphate industry's separation process creates lots of clay, so they need thousands of acres of land to build these clay settling units. They usually use mined out land, so as soon as they strip all the phosphate out, they begin piling up dirt to make dikes for the clay settling areas. There's so much clay left over when they're done mining a piece of land that the settling ponds take up about 40% of the total land that they mine. Most clay settling ponds are built with a land bridge down the middle of the pond. This is so the clay will settle on one side and give the water a place to move to the other side. As the clay builds up, the water creates rivers as it migrates to the other side of this pond. These phosphate mines are located right in the middle of citrus country, and it should concern you that your orange juice might be growing within a stone's throw of one of these ponds. These clay settling areas are 50 to 60 feet of solid clay. It will eventually dry on the surface and become crusty, but the clay underneath will never dry out, and rainwater will never be able to permeate this clay and resupply the aquifer. Here are a couple ponds that have set for a while. Plants do start to grow back, but these are not the plants that were here before, and this habitat will not sustain the creatures that once lived here, and as you can see, there is very little, if any, life in these ponds. Before these clay settling areas were here, this land was home to lots of wildlife, including threatened and endangered species like panthers, gopher tortoises, indigo snakes, wood storks, and snail cats. Our government is supposed to be protecting these species, but instead they issue permits to these companies and allow them to destroy their habitats. These areas will never support life. They will be permanent dead zones for decades, if not centuries, to come.
All right. Next, I'd like to call Jane Armstrong.
Good afternoon. Honored to be here. My name is Jane Armstrong. I live at 1141 Ocelot Road, Venice. I was born in 1951. I grew up in Manatee County, and I've lived in Florida most of my life. Growing up, we kind of had a mindset about waters. There's too much of it. We talked about red tide, and it lasted 2 or 3 weeks that we had it. We talked about raising cattle. We talked about the citrus industry. We talked about tourists. And those were ways of generating revenue. This industry has been given a break since its inception because there is a mythology that got built around it, that it generated jobs, it helped the economy, and there was really no downside to it. In the 60s, my father, who was a plumber, started working for the union, and he helped build the Borden plant that was responsible for creating the Pine Point gypsum. I thought that was really awesome. We didn't have industry here. Industry's come to Florida. My dad's doing it. This is great. This is cool. I moved to Alabama, and I came back 5 years after that plant was built, and I was stunned when I drove by it and saw that for about a quarter mile, the entire place was covered with this dust. It looked nothing like it had when it was under construction. And as the years rolled by, I watched that gypsum, which you could see from I-75 going back and forth. I didn't understand what was going on. And you know, some of us who've always lived in Florida where there are no mountains could kind of romanticize about our own little mountain there. What we have done and what has happened in the state of Florida since its inception, we have commodified the state. We've commodified the people in it, our resources, all the wild things that allow us to live the lifestyle that we do and allow us to bring tourism here. I don't have all the details that a lot of people have presented here, and I appreciate the fact that they have. This mindset has got to change. I haven't heard anybody talk about sustainability. There is absolutely nothing sustainable about any aspect of this industry. As citizens of the state, we've got to look at that. Because if it's not sustainable, it's taking away from our present and it's stealing from our children's future. And it's a non-starter. Thank you.
Dr. Dave Woodman, what's your card up next? And we have 3 cards after you. I'm looking forward to getting to some board discussion and some questions. And then we also have our online folks possibly too. Hey, Dave.
Commissioners, thank you for this opportunity to not only get to be here once, but twice, so I consider that an honor. I have not been a resident of DeSoto County my whole life. I've only lived here now just shy of 5 years. And so my family and I moved here kind of when all of this process started with bringing Mosaic mining here to DeSoto County. I'll be honest with you, I'm one of the, I think, many people in our county that are really on the fence about all of this. We don't really know what to think. We don't know. We're not experts in mining. I think I've shared this with some of you that until just recently, I thought the phosphates, the only thing I knew about it was that it had something to do with my food. And so I just want to make a couple of comments and a few questions that I hope our board, as well as Mosaic, will consider here today. One of the things that was mentioned, and I want to address specifically the CSAs today. I was paying attention during the information that was presented, and one of the things they talked about is that we have not had a CSA accident since, I believe, approximately 1994, and correct me if I'm wrong. But what concerns me is that I'm not an expert, I'm not an engineer, but I know one thing. I know water's going to do what water's going to do. And no matter how good we engineer, no matter what technology, no matter how many simulations we run on a computer, at the end of the day, water is unpredictable at best. And I am concerned about what happens when, not if, but when something catastrophic happens. It's inevitable, and I think if we're being honest, we need to take that into consideration, and I believe it's been mentioned today already, and something I would like to know from that hopefully Mosaic can respond to at some point, is what are the effects of a major breach from the CSA? What happens when something catastrophic happens? The other question I have is simply, what is Mosaic's emergency action plan should a disaster happen? And then, how on earth are we supposed to respond to a disaster as a county? Because again, there are so many unknowns, so many variables. So I stand before you here today, someone who has been on the fence about this for a long time, but I'm beginning to believe that it's probably not in the best interest of our county to have phosphate mining operations happen in our county. And so again, I'm opining on that. That's my thoughts and feelings about it. But I think that there's some serious questions that we need to be prepared for that, frankly, I don't think we are. Commissioners, thank you so much for your time.
Thank you. Next, Bryn Curtis.
Okay, I'm changing my topic to the lease terms because I do surveys during the lease term breeding season. And our lease terns are having a rough time on the beaches, mainly because of people and tourists. But we also have predators, aerial, dog walkers, coyotes, and we also have more subtropical storms with surges that can take out a whole colony. So the reason the lease terms are running out of space, or as a result of the lease terms running out of space for nesting colonies, they end up going on roofs, old roofs, flat roofs with gravel on them. So they will go, and it gets very hot. It's not the most ideal situation. The chicks sometimes fall off. And so they are using lots of places because they've been driven out of their normal beaches. And so I don't think that's a very good point that Mosaic made earlier. The other point that I want to make is I listened to the video that you did with Nikki Fried earlier, and I think it sort of dawned on me that we may have the wrong premise, the wrong fundamental belief that agriculture and growing crops needs fertilizer. So I don't think that we really need phosphorus at all, because there are lots of sustainable agricultural processes. There's regenerative agriculture and permaculture, organic farming, and urban farming, urban gardens. There's lots of different ways that we can grow crops that are sustainable. Our belief, or the way agriculture has evolved, as it's become an industrialized agriculture with big machines. I mean, there was a news report with John Deere. There was a part that was missing because of the recent supply problem. They couldn't harvest their crops, so the combines were just laying idle. And that's part of the problem, is that a lot of this industrial agriculture is taking away the smaller farms and all the jobs that went along with that. So I think that we need to fundamentally just change our thinking and be more open to know that phosphorus is really not necessary and it's not sustainable for the future. So thank you.
Thank you, Ms. Curtis. Just from my personal perspective, I will have to share with you that as a farmer, I do know that NP and K are absolutely vital soil amendments to grow very much on very large of a scale. Now, you can also probably fill a whole day talking about more environmentally friendly ways to use them than the way they've been used in the past. And I think there is a lot of improvement room there for sure, but the idea that we can grow enough food to feed everybody without NP and K additives is, in my opinion, probably not the way things could possibly go. But that's just because I've known a whole lot of stuff for a long time. But next, I'd like to call Mr. Larry Grossman.
Members of the Commission, Larry Grossman, I live in Manatee County. I appreciate the comments of the county attorney regarding the right of the applicant to resubmit an application for rezoning after a year. The question I would have is the basis you're turning down the application originally based on facts and findings. The question is what's changed. So I just leave you with that. And if nothing's changed, I don't know why you reached a different conclusion. They have the right to reapply, and you have the right to deliberate on that and turn them down again, for the same reasons you turned them down originally. There's lots of questions, and people have brought up things that I was going to bring up regarding the, I'll just list them, the fact of the wildlife restoration to the original condition, or what's missing. And I'd like the Mosaic representatives to talk about what can be restored and what isn't going to be restored. I mean, there's a gap there. How much reagents, the quantities, how the microbes, are these aerobic microbes, how is the microbes accessing the fuel oil and biodegrading? Where are these microbes? Are they buried? Is the reagent buried? I don't understand that process. We really haven't talked about the role of water and how things are transported. And I'd like Mosaic to talk about the role of water in transporting that is the sand, or the clay, to the clay settlement area? How is that done in each phase of their operation? I guess I have a question about whether there's going to be a beneficiation plant in DeSoto County as part of this application. Where is the fertilizer plant going to be? How far can it be from the mines? I'd like them to address the life cycle of these mines. How long between the initiation of the mining and the last restoration area? How much time is going to be expended for that total, call it a life cycle of the mine? So how long will this be impacting? The question of radioactivity, there was a statement that there is no radioactive materials in the CSAs. I'd like that addressed before, because I think there's contradictory information. And I'll also just hit a few. Resiliency regarding climate change, how are they addressing this? What are their standards? And dust, because when I went out to Manatee County and saw the mines, what I was struck by is how much dust was all over the place. We got to talk about the impact of the air quality. Thank you very much.
Yes, sir. Thank you, Mr. Larry. I could give, I believe, correct me if I'm wrong, Mr. Khan, but a couple of those answers I could tell you off the cuff, I think, are the last application did include a beneficiation plant here, but not a fertilizer processing plant. So those are two different locations. Next, Caitlin Chase. Ms. Sylvia, do we have some folks online, or does Ms. Sarah have those over there? Okay. We do? Okay. We'll keep coming up to them just during your minute. Yes, ma'am.
Am I allowed to give my 3 minutes over back to Miss Rachel so she can keep talking for another 3 minutes?
Sure.
Hi, I'm back again. So just to finish up where I left off, I think what I found to be conspicuously absent from a lot of Mosaic's presentations today was the very brief mention of those spills. We've had that 67, 71, and then, what was it, 23 years later, two 94 spills near the Hopewell mine. That means that the last time the CSA standards were updated was in 94, prompted by those two 94 spills. But again, if you remember, the last major brief before that was a few decades prior. We're due for one. We're due for an update on those standards, and we don't have it. We've got climate science that is significantly different now than it was in 1994. We've got, in fact, an entirely different footprint that these CSAs are going to have. It's more of an experiment. It's the first time that it's great that we're reducing the acreage of a CSA, but we're not reducing the volume of waste. It's gonna be built up higher and deeper. We're gonna have the same amount of waste, which means more pressure coming from that higher stored waste, and more pressure on those dams. And yet, there's no requirement in state statute, and in your comprehensive plan, which I have reviewed, along with your LDRs, defers to DEP almost everywhere. You've got very little teeth and very little requirements that you can impose above and beyond the DEP's permit. So you're entirely reliant on a DEP who has, quite frankly, done a very poor job regulating this industry, as evident in news media and disasters across the state. You've got nothing that you can do to protect if you rezone this. You'll be stuck with what's on the books because you've agreed to do so, right? You signed an agreement saying you wouldn't change your comprehensive plan or LDRs. It's not basic black letter law to do that. The only reason you are stuck with a comprehensive plan that you've got up until the filing of this latest rezoning application was because you signed an agreement saying that you would. So now you have this application, the really only way you're going to be able to protect yourselves is to not allow that land to be rezoned at all. Want to talk about one more thing. In addition to that same volume of waste that you're going to have, even though you have a smaller footprint, the different type of CSA with the same type of standard, you also have, and just to really bring home the experimental nature of this deposit, this ore deposit, is considered low quality ore. I'm sure you guys have heard that, right? So we're at the end of the road here. Mosaic's on its way out. This is the last stop before they take off and go to their international holdings and focus there, and then they'll leave the state. So I really would caution you not to be the last ones holding the bag. They're going to have to use more beneficiation reagents than they've used in those northern mines because they have more waste to beneficiate out away from that ore. It's got more dolomite in there. They need to, and there's studies on this, there's newspaper studies, that's the whole reason it's more expensive to come down here. That's why they haven't done it until they really had to, until they ran out of anywhere else to go. More reagents, more toxic chemicals in those CSAs. It is not new and improved, it's not better, it's worse. So, and there's no studies on it because it's never been done before.
Thank you, Rachel. Now we will go ahead and go to our online speakers.
Okay, we just want to remind the online viewers to use the raise the hand feature, but we do have one ready. Elise Bennett. Just make sure on their side they need to be unmuted. And they have 3 minutes. Would you like them to state their name and address, Chairman?
Yes.
Yes, okay. Please state your name and address.
Good afternoon. My name is Elise Bennett, and I'm from Pinellas County, Florida. I'm a senior attorney at the Center for Biological Diversity's Florida office. Would you like them to state their name? Excuse me.
Yes.
Yes. Okay. I'm hearing some reverb. I'm not sure if you all are hearing that on your end. Okay. Thank you, Commissioners, for taking seriously your duty to understand the consequences of approving phosphate mining in clay settling areas in DeSoto County. The phosphate industry is leaving approximately 40% of the land it mines in clay settling areas. That's a substantial footprint that requires substantial consideration. This proceeding is highly irregular. The applicant, excuse me, the applicant has been provided unprecedented and unfair access to the Commission, which is draining county resources in the process. And even given this unprecedented opportunity, the applicant has failed to provide the Commission with substance regarding the impacts of the request to mine. In that vein, the Commission should hold the applicant accountable to provide real answers with regard to CSA impacts on regional hydrology. The Commissioner asked a thoughtful question: what happens when the applicant introduces enormous areas of largely impervious clay soils to the landscape? And the applicant failed to provide a thoughtful answer, or really any answer at all. Regardless, we do know that hydraulic conductivity, low hydraulic conductivity, leads to water logging and ponding of water on the surface of CSAs. That's from Wilson and Hamlin, 2012. In another study of CSAs, Ross and others, 2014, a CSA restricted recharge to an underlying aquifer and exhibited higher surface flows than surrounding natural areas. And finally, we know that CSAs reclaimed by conversions to wetlands will discharge less surface and subsurface flows to surrounding water bodies and aquifers when compared to average unmined lands. That's from Ross et al. 2014 as well. In short, these studies suggest that CSAs represent radical alterations to existing hydrology, and the applicant needs to provide clear and transparent answers regarding the impact of CSAs on that regional hydrology. With regard to wildlife impacts, I'd like to highlight that the applicant essentially showed you beauty shots of birds and alligators. What the applicant failed to detail was the impact on the full and irreplaceable biodiversity of DeSoto County, particularly on species that do not have the benefit of simply flying away when the conditions become too poor for them to survive, like the federally protected eastern indigo snake for the state protected gopher tortoise, which provides homes to 360 other species in their burrows. Turning the landscape into a place settling argue that active CSAs support the same biodiversity that the unmined landscape supports, and indeed they did not. They also failed to provide any peer-reviewed studies that compare biodiversity before and after it reclaims a clay settling area, and we're not aware of any such study that exists. But we can glean from studies of phosphate mine reclamation generally that these sites will never sustain the biodiversity they did pre-mining. A study by Durbin et al. In 2008 concluded that attempts to reclaim wildlife habitat are so complex that it is extremely difficult to reliably maintain or regenerate fish and wildlife habitat for the entire community of native vertebrates in the area. And that's assuming the entire community can even be identified. Please hold the applicant accountable for answers regarding their impacts to DeSoto County's biodiversity. And lastly, I just wanted to highlight that the applicant failed to discuss limits on the uses of reclaimed CSAs. Because phosphatic clays easily shrink and swell depending on the presence of water, they are unsuitable foundations for buildings or other structures. Farming clay is highly energy intensive and can cause substantial wear on farm equipment. And there's also a study that compares soils of mined and non-mined areas that shows superior soils in the areas that have not been mined. And that was done within this region. And so I'll thank you. I'll stop there with my comments and thank you for your time today.
Okay, thank you. Chairman, there's no other speakers.
No other speakers right now? Oh, I hear somebody.
Please raise your hand if you'd like to speak from our virtual.
Can you hit the raise your hand function so we can tell who you are?
If you'd like to speak, the raise your hand features under the reaction. Okay, now we have one. Maybe the tool's at the bottom. There's a reaction tool. That's where you find the raise your hand feature. Okay, so we have Chris. Unmute yourself, Chris, and...
Tonight, Tuesday, 8 to 10 p.m., we'll cover this again. As we have in the past, we've had on Eric Brown, of course, host of Phosphate, spelled PHOSFATE, phosphatemovie.com. That was mentioned, and several activists we've had on the lab expedition after the 2018 victory, so we will continue to report on this. Also have a new show on RBN, Republic Broadcasting Network, that is Sundays, 11 a.m. to 1 p.m. Eastern Time. That's republicbroadcasting.org. And I'm really kind of shocked that this issue is regarding water fluoridation. This county, Pinellas County, being able to end water fluoridation in 2012 and restarted in 2013. Of course, the industrial discharge, known as water fluoridation, is what's being used from the phosphate mining. It's on the annual water quality analysis. FluorideAlert.org has a lot of good information. The Fluoride Action Network, FluorideAlert.org. Although farmers feel dependent on using the fertilizer, and that's called forced growth, the phosphate, nitrogen, potassium, those three numbers you see on the front of the bag, those are what most plants need to grow well, though they don't do very well. They have poor immunity, although what they do well with is mineral ions, as in from water ionizers, by the way, glyphosate, that's the main ingredient of Roundup herbicide, that binds with mineral ions. What's the solution is more mineral ions. And so farmers, when they use forced growth farming methods, potassium, nitrogen, phosphorus, then they feel dependent on pesticides, fungicides, and herbicides because the plants have terrible immune systems. And so mineral ions just simply sprayed on. I've noticed that does very well. You can do a search of videos for mineral ions and 2001, electric water kills plant plant food pathogens that shows that it kills fungus as well. The acidic ionized water and spray on the freshly ionized alkaline water for other benefits like antioxidant. But it's Mosaic wants to rehab green areas with ionized water. They can spray it on. I don't suspect they would be doing so. That would prove the obsolescence of their fertilizer, drive their stock prices down a little further, hopefully.
Okay.
And
Excuse me, Chris.
the history of Mosaic not having to pay for properly disposing of radiological waste, not just the place settling areas, gypsum stacks.
Chris, you have less than a minute.
Radioactive waste rock formerly approved by the EPA to be used on roads. One selling point must have been blowing roads will save on road lighting. There's also...
This isn't the forum to promote your radio show. Do we have any other speakers online?
No one else at this time.
Okay, if somebody does raise their hand, just let me know. Yes, ma'am.
So I would fill, after that, we just saw him, I said, I'll come up.
Phyllis?
My name is, Janice Ippolito.
Janice. Okay, thank you.
I'm at 9463 Rosebud Circle in Port Charlotte, which is out on the Cape Hayes Peninsula. And I'm a farmer's daughter from the Garden State. I've been here for 6 years. I'm bringing down, I'm very proud to bring this down. Don't have to. Last night at 7 o'clock, I got the Charlotte County Democratic Executive Committee to agree to a resolution. Perhaps you may have seen it in your email this morning. It just simply says that we wish to take a stand on the pending applications for the Mosaic Company to be granted permits in DeSoto County to allow the mining operation of phosphate, and that said operation could negatively affect the water quality of the Peace River and our beautiful Charlotte Harbor. Charlotte Harbor depends, the business that comes out of the harbor, Charlotte depends on it. And although it hasn't happened yet, I just, there's that fear. I just also wanted to talk about when they talk about the quasi-judicial thing here, and not from a technical point of view, but just for the fact that I feel like, the antagonists, the judge and jury. And I wanted to thank you guys over here for coming today. Oh, you're not all here now. You're the experts. And I thank you guys for inviting them. I just think it brings to the open conversation of it. And, perhaps I wish you were coming here because you were saying no, but that's what the rest of us that are here for. Even the residents are about saying no to this whole thing. I picked up some key guideline words today, just briefly. It's in this one. Acceptable levels, highly regulated, within the guidelines. And I say to myself, it's not the mining, it's the fear of the enforcement of the mining that really horrifies me, that scares the catastrophe that will happen. I know when Keith Bearswell said some inspections are 2 times a day, some inspections are 3 times a day, and I could think to myself, why is there a difference? When I was here in June, I said to you people, I understood then that there's a lot of regulations that you as a board can put on each individual mining operation. And again, I just urge you to be, if you can't say no, you have to be as stringent as possible. This is just not right for Florida. Thank you. Or as one of the other speakers said, the analogy, don't jump off the roof before you go to the doctor. Thank you.
Thank you. All right. I would like to, I think we spend a lot of time here and we've heard a lot of things, but our board needs an opportunity we've assimilated some of the things that we've heard, and we have some of our own questions and thoughts that we need to talk about, and that is really important, so we've got to take some time to do that. One of the first things that I would like to start out with is a question, and I'm going to try to make it concise and hopefully get concise answers so we can move through some of these things, because we don't have a whole lot of time left before dinner time, and I feel like there's a ton of ground to cover. So my question is, the first one, and then I'll yield to one of my peers up here and we'll just take turns, is the reagents. Is there a place where we can find a rolling 3-month average of the type and quantity of reagents that are used at the beneficiation plant? So we can get a good idea for the quantity of when there's 30% that go unaccounted for, how many gallons or pounds does that equate to? So that's what I'd like to know. Is there a governmental entity where that stuff is logged, the amount of those things that are purchased for a plant per month? Or is that private information that we could ask be disclosed to us? I've heard some figures quoted about the industry, what the industry buys and uses, but I think it's important for us to know what a plant buys and uses so that we can interpret what that means for our community.
Yes, we do track the volume and quantity of reagents we use at all of our sites. We don't have that information on us, but we can provide that to you. We track it on a daily basis.
Oh, would you give us your name?
I'm sorry, I'm Keith Allen. I'm the Senior Engineering Manager for the Florida Mines.
So you do have it?
Yep.
Is it available for us to see?
That I'm not sure. I'd have to defer to our leaders if we can provide it, but we do have it accessible.
Okay. Is there anybody that could give us the answer to that one? Okay, thank you. Okay, I'll make a note here that that's an action item to be forthcoming. All right, would one of y'all like to? Commissioner Cooney?
I was curious on the seed essays. Does Mosaic have any mining sites that don't include CSAs? And can a mine exist without a CSA?
So no, we don't have any mines without CSAs. The clay is part of the matrix we mine. If it's there and we mine it, we have to, have a CSA to deal with it. Any other? Does that answer your question?
If the CSAs in DeSoto, will there be waste from other counties that will utilize CSAs in DeSoto?
The familiarity I have with the application is it's strictly clays from DeSoto County disposed of in DeSoto County CSAs. So I'm not aware of any. I've heard that a couple of times. I'm not aware of any. Anybody else have anything to add to it?
Very good.
I have a question on the CSAs, on the outfall structure that allows it to go back into the circulation. Is that water tested with the reagents and what levels are in that? And then the other part to that is, I know we talked about the microbes, and when you unearth, and I'm not a scientist by any means, but when you unearth fallow ground that doesn't have a lot of nutrients, it's been stripped of that, it's not a very beneficial place for microbes to live and feed. And so I'm just kind of curious, how is that population accounted for? And is there a release of certain type of microbes? I know in the farming world, we release microbes under our plants and in the soil to help benefit our plant health. And so I'm just curious on that part.
answer part one of your
Okay.
question. This is Beth Neese. I'm the Senior Manager Environmental. So for the testing, we test at our outfall structures, which I think is different than what you're asking. You're asking the spillway, which are two different things. So the spillway structure allows the water to be recirculated back into our mining process. And then the outfall structure is where water leaves our property through the permitted NPDES outfall. We do monitor lots of parameters at our outfalls. We talked about it quite a bit at the last workshop. We monitor our normal DMR is the discharge monitoring report that goes to the state. And in that report, some of our mines have an oil and grease parameter that's monitored, and it's always below the permitted maximum at that outfall. We also do what Sabrata had talked about is the 2CS monitoring that's got 170 odd parameters that we look at, including materials that are found in the reagents and are always, non-detect or very, very low at the outfall structure. But we do not monitor at the spillway structure. That's part of the
From the CSA.
CSA.
And that's what I was curious on. I mean, is if you're putting these reagents in and that byproduct ends up in the CSA, I get that it's recirculated and it's rerun, but just curious on if there was any measures to calculate based on what you're going to put more into it, or if you can reuse it. The reagents is kind of what I'm getting at.
Yeah, no, we don't monitor at the outfall. There's no regulatory requirement for us to monitor at that point. We just monitor at the discharge point.
I think mostly because of the accumulation and as a farmer, I speak for myself, but we watch our inputs and we're constantly monitoring, and if we can save on putting NP or K out on the ground, I'm not going to do it based on my soil and tissue samples of what the plants tell me to do. So that's the only reason I'm asking.
Yeah, that's a good point.
Thank you.
Oh,
I think he's got the second part of the question. Sorry.
Gotcha.
Good afternoon, Subrata Bendy, answering the second part of your question. For bacterial growth, there are three essential things that you need. First of all, bacteria is naturally occurring. Anywhere you touch, you have bacteria. And bacteria can grow, mutate, and potentially enhance its population based on the food that it gets. So bacteria needs carbon source, and it comes from the organics that we already have in the soil system. Bacteria needs oxygen if it's an aerobic bacteria. Our bacteria can also work in absence of oxygen, that is anaerobic degradation. And then bacteria needs nutrients. Now in the CSAs, you have plenty of nutrients because there is phosphorus in it. There is water that's recirculating, that's oxygenation happening all the time. And you have naturally occurring diversity of microbes that gets enhanced over the time because that's the food they are being exposed to. Bacteria does not degrade hydrocarbon as their primary food source. It's called co-metabolism. The metabolism happens on the basic food, on organics that they feed on, and as a part of the process, other chemicals, other processes take place, and that's called co-metabolism. And that's how these long chain compounds get degraded to smaller compounds, and then eventually completely gets degraded to carbon dioxide. If that answers the question.
Thank you.
Thank you.
Thank you. I think that we have Dr. Sorry. Would like to respond as well to that. Come up to the mic there. Dr. Whitman, sorry.
It's all right. Yes, I've published on degradation decomposition of PAHs and organic matter, and I can tell you from the literature that I presented to you that there is no evidence to me of the polyaromatic hydrocarbon degradations at 3350 feet. And if there was, I think the petro industry would be very interested and perhaps disturbed. Thank you.
Thank you. Is that a complete enough answer to your question, Commissioner Gross?
Yes. I have one other question, and it's to the future uses of the CSAs in agriculture and stuff like that. And I think it maybe goes to a little bit of what Bart was talking about as far as their grazing and plants and what can be done on that. And I know that that you say there's going to be some studies of 50 acres of doing some different trials. Is there any data on, and you might have it, I don't know, of what the production was on the stuff that you did grow, like the peppers, the tomatoes, stuff like that, and the land that was used, was it mosaic doing, or was it leased sharecroppers, I guess?
Well, the study that I referenced does show that. It does give all that data on the things that they grew. We have some data that we collected, and of the things that we've grown on not just clay settling areas, but reclaimed land, the yields are comparable to unmined land. So, but there are some things that we've tried on properties that didn't work, and obviously there's some things that will work and won't work, but that's the same on unmined land as well.
Sure. Okay. As far as invasive species, Bart, like the Kogan's grass and stuff like that, I mean, how do you guys have a plan to maintain that? And I mean, it is invasive.
It is invasive, and it is a challenge, right?
Yeah.
Right. And actually, it can be grazed. It's certainly not ideal. What we have done is we've actually have a little trial area, and where we've managed to eradicate it and then oversee it in the future. We've tried on some reclaimed land. So I don't think we've tried that on clay settling areas necessarily, but I don't think the results would be much different. So.
Okay, thank you.
I'd like to add on to that question something you just started to hit on there, and Bart might be the right guy to answer. Bart, in your presentation and Ms. Lisa's, the finished product pictures of land that's being used that was mined in the past, they both showed extensive Kogan grass coverage, super extensive. So all of us who manage land in agriculture around here, and I think across most of the state, we consider Kogan almost a mortal enemy, and we spend a lot of money eradicating it. So given that there was a couple slides of y'all's land that is supposed to be the way it should look when it's done being mined, and it's covered with Kogan, what is Mosaic's stance on Kogan grass? If they were mining here, what would they be doing to make sure it doesn't look like all of the other land where they've mined before?
Well, Kogan grass is our mortal enemy too. So we don't like it any more than anybody else. So, and as Lisa was telling you, the time is always, can sometimes be a challenge, because before we are allowed to beneficially use the land, it has to be released. So that's when some of the Kogan grass starts to move in before we can get cattle on it. So we're working on ways to shorten that time and get areas released so that we can get beneficial use on that before it starts to become a problem. So, but wherever it's grown, we're going to have to deal with it like I talked about. We're going to have to eradicate it, and then once it's eradicated, and have beneficial use started on it, so its ability to come back is diminished. But moving forward on land, we're going through that process. We're trying to get grasses on there that will, and different types of vegetation on them, shape that out so that it doesn't become a problem. But yes, we don't want it, and we work diligently to keep it off, and we are certainly, if you guys are doing something that works, we're open to suggestions as well, so.
So as stewards of the land, your idle land and the land that's in agriculture production that's outside of the mining footprint, do you guys have a proactive stance to eradicate and push back the coping grass?
Where we can, yes, where we can.
That's right. Yeah, there's nothing worse than having a neighbor that doesn't care about the coping grass if you're spending all your money trying to keep it out.
Correct.
Well, there could be something worse, but I can't imagine it. Thank you. Commissioner Schaefer, did you have a question you'd like to bring up? Thank
Yes,
you, Bart.
I do. I'm not sure whether it's Lisa or Keith.
Mic a little closer.
I'm not sure whether it's Lisa or Keith or who it was, but my understanding from back when, because my issue was the clay settling ponds. And I felt that they needed a liner, not just the clay that settles down. And I understood at the beginning from then that you don't have to have the liners. Today I heard somebody, and I don't know if it was somebody from here or if it was somebody from over here, not sure, but said something about the liner had a leak in it. So, do we or do we, oh, you did. Okay. Do we or do we not have liners for the clay settling ponds, or is there a possibility for them? I'm just asking.
Scott Witchick with Mosaic. I believe that the reference that I heard, I think it was the same one, was to a leak in a liner on the day our permit was issued from New Wales, I think is what they were referencing. That was not a clay settling area. That was a lined water channel at one of our concentrate plants. So no, we don't have liners in clay settling areas.
Okay. Well, that's what I want to clarify with me on that one. The other thing is, you said you were told, or we was told, and I think Mohammed was the one that made this comment about it, that there's been no dam fails since 1994 in Florida. Has there been any more that has failed anywhere else in another state or in another country that you deal with? After this, after that, whatever.
The answer is dams fail, and there are dam failures all over the world. That happens, but typically they don't go under the same scrutiny and regulatory that these clay settling areas go through. So obviously, I mean, everybody's familiar with the Brazil dam failure a few years ago. There were videos there, and it's under investigation. And that's prompted changes in the rules in Brazil and regulations of clay settling, not tailing dams. That was a tailing dam, not clay settling areas. But dam failures occur for many reasons, as I mentioned them in my presentation. So there was dam failures all over the world.
So they've had some since then?
Since '94?
Yeah.
Yes.
Okay.
Phosphate mining?
Not to my knowledge of phosphate mining. No.
Okay, I think that's
Yeah. Okay. The only other thing that I want to ask is, Keith, I think it was, Fearswell, made the comment that they do 2 to 3 inspections a day with the testings and stuff that you do. Is it just strictly just right there in your area? Or do you do it like with a certain space that's around this area?
Sure. So Keith Beresford with Mosaic Company. I'm a lead geotechnical engineer. I appreciate the question. And I apologize for the confusion on that. So the inspections are done daily per shift by shift workers at each of the facilities. And so the differentiation between 2 and 3 inspections per day is based on the shift operation schedule of the individual facility. Those are generally dictated by the actual operations themselves as to how they run the shifts for the operations. So, but to answer your question in more detail, each clay settling area that is active is inspected once per shift, 24 hours a day, 365 days a year. The 2 to 3 inspections is simply dictated on the schedule.
Okay, but that is just in your area.
No, that's all active clay
And
settling
then
areas.
outside of the area, the perimeter there?
The perimeters are inspected as well.
Okay, that's what I want to know. Okay, thank you.
Sure.
I'm through.
Okay. Commissioner, do you have some more questions?
I just had a couple more. I know that there haven't been any failures at any of your CSAs. Have there been any citations or fines?
Thanks again. I'm not aware of any fines that we have received at a clay settling area.
So that's not a no, just not aware, or?
I don't recall any since I've been with the company since 2007. I've never seen a fine at a clay settling area.
Who monitors the land after you're done using it for a CSA? I know that you change the land, use it for other things. Who continues to monitor the CSA, and is there any responsibility on the county down the road? I mean, do you leave after 25 years? Just, you know.
So we're required by the state and by the county to reclaim clay settling areas to meet standards. So until those clay settling areas meet that standard and are released and reconnected back into the watershed, we are, inspected by the state and by the county to make sure we're operating under or reclaiming to that standard. Once they meet those requirements, we utilize that land for, like Bart talked about, agricultural activities, just like it was any other land in the state.
And so then does any testing of waters, it ceases at that point once it's released?
Well, once the clay settling area is released, it's no longer monitored for reclamation requirements, but on the water quality monitoring side, we will monitor the entire site according to the development order or the master mine plan or whatever each county has as their environmental monitoring plan, as well as through our ERP, which is the environmental resource permit. They both have environmental monitoring and our NPDES permit that goes through the outfall. They all have environmental monitoring that will be conducted through the life of the mine until everything in the entire site is done and complete and we're released.
Thank you. I was curious, I mean, there was a lot of things that Dr. Whitman shared, and there was like a most recent study, and I just wanted to know if there was any rebuttal to what he had to say.
I think along those lines too, it would be good to ask our folks that are here after Mosaic's done responding, if they have any knowledge about those things, because I had some questions about that too. Thank you.
Commissioner Kuhn, I wanted to follow up on that. I want to just make sure that you understand that once it's reclaimed, there's no water there to monitor afterwards. So I just want to make that clarification as well.
So Dr. Whitman, just to restate Commissioner Kuhn's question, had talked about a USGS study where there was a whole bunch of parameters where there seemed to be detection of unhealthy substances. And my question is, what more do we know about that? Were those substances at levels that were above the standard thresholds that are accepted? Because the list looks pretty comprehensive and pretty bad, but I don't know what the levels were.
Excellent question. They're all, I think they're all on the EPA priority pollutant list. I don't know if they exceeded any particular standard. I do know the one got a lot of numbers in chlorines and so forth. The hexane and the benzenes were in at least site 11 were at 200 to 300, I believe. That's the order of magnitude for sure, of parts per billion. Okay, but a lot of the others, and remember this is back in, I think they were probably sampling about 1994, published in 97. So GC mass spec had really just come of age without, and they didn't have all the residues standards that they needed. It needs, I think Dr. Peller and I both say that we need to go back to those sites and to other sites and resample. The technology has come a really long way. But a lot of them were in a few parts per billion, but some of them were in 50, 100. Okay, and I can send that to you.
Thank you, I appreciate that. Does anybody here know if those test sites that were referenced in his talk are currently still being sampled? I think nobody knows that. So we'll have to do some research on that. Anything you could forward on to us to where we can do a little bit of verification and further discovery, we would certainly appreciate that. Commissioner, did you have any other thoughts along those lines?
No, the only other question I have for our experts that were here on behalf of the county, if they could, listening to both, proponents and opponents of the mining and the CSAs, if they had anything that they could share with us about the risk or safety of CSAs.
That's a pretty broad question.
It is.
For me, as a geotechnical engineer, John Delishaw with the Grid CPWG, a geotechnical engineer in the studies and having done the seepage analyses that Mohammed referred to and the stability analyses, and knowing from what we did 30 years ago to what we do now, the testing and the analytical methods are so much better and we're still using the same safety factors, and you've got better data and better analytical techniques. And so from that point, I don't see, the dam stability, the improvements after the 94 with the seepage. That's how it works are the bad actors in dam. And so that was a big change that really helped. As far as seepage down, the clay is very low permeability. And it takes a long time for it to consolidate and to strengthen and to be able to support equipment.
I have a question along Commissioner Kuhn's thoughts. I know that it's probably very expensive, but have you studied or are you aware of any case studies where someone has placed topsoil or overburden over a CSA to try to maybe make it a little more conducive to a good ecosystem post reclamation, like put 3 or 4 feet of native soil over the top of it so that you can try to develop a more natural seed bed and maybe a little bit more natural water absorption to some degree? Or do you know anything about that?
Michael Mosley's very experienced in reclamation, but even in my initial studies, we did the non-mandatory reclamation plans. And it started with sluice sand tailings over the clays just because you need to get something over top of the soft clay so you don't create a mud wave. If you start putting something too heavy too fast, it just sinks into the clay and moves ahead. So you kind of have to get a light, but then once you get something on it, then you can put more, and then you can have the reclamation plan is going to have anywhere from upland to wetland type species. It's the whole plan, and that's how the other question about how do you have so much runoff. There's parts of the reclamation plan you have to capture the whole, and so that's all part of the development of the reclamation plan as far as topsoil.
I believe there some studies have been done about spraying sand tails out over clay, and I don't remember. I know the studies have been done, but I don't know the results of the study. But I think there has been in the past. I don't remember which, but Pipper may have that information.
Okay. Do you have another question you want to get in there? No? All right. Do you have, Sylvia, do you have that picture I gave you? This picture made me think a lot about potential CSAs in DeSoto County. This picture is about 4 weeks old, and there was a guy driving this tractor named Nate, and he was operating it, and he broke through that crust. I'm not sure how old the crust was there or what the status of that was, but they thought it was strong enough to support the machine, but as a result of him getting pulled out, probably not by the best methods, but he passed away a couple weeks ago because the cable broke and it came through the window and killed him. So when we're talking about uses of CSAs down the road, I want to know about safety, how things like this can happen, and what can be done to make sure that they don't happen in the future. Speak to that, I would appreciate it. But I want to get as much information about this as possible.
I've seen that situation so many times, it's not funny. It's easy for stuff to go through the crust, and it happens, and it's just a matter of time allowing the crust to develop. They talked about internal ditching, that's all got to be done, it's all got to be checked, but I don't know how many times we've had to tow out things that have broken through the crust when we thought there was ability to handle that. So, yeah, it's unfortunate that safety precautions weren't taken enough to be able to get that out. But, yeah.
Well, I think that clearly part of the root cause of that young man's demise was a poor effort at trying to retrieve that piece of equipment, but also part of the root cause was the fact that he was driving heavy machinery on top of an unstable surface. So I'm just thinking about down the road, is there a number of years you could use as a standard where you know that they are safe? Is it 50 years? Does the crust need to be 2 feet thick, or does it need to be 10 feet thick? And should we be doing geological testing on CSAs that are about to be released to make sure that they're safe for people to build things on, to build solar fields on, to do agriculture on? Those may be some questions you might not have the answers to. I'm just trying to come up with some ideas.
Yeah, they can test them and test how deep the clay crust is. Generally, I'd want to put a tractor out there that had pretty high flotation tires. I wouldn't want to put something out there that was just a standard tractor.
That machine was actually a track tractor, especially made for the very lowest ground pressure that you can get on a big tractor.
Yeah, it's testing, see how thick your crust is, how firm it is. I mean, I don't think you have to. We put tractors out within 5-10 years. I mean, it's not. We're not talking about 50 years. So it's. I would guess it's quite a bit to dry out a settling area. A lot of ditching to be done. A lot of disking. The deeper the disc you can go, the better. Because what you're trying to do is when it rains, the water runs off the ditch real quickly, and you don't want it to be seeping into the soil. So you want to have close enough ditches so that you can get that water off. You don't want to eliminate the ditches. You want to keep them there, and you want to keep positive drainage on it all the time.
Do you know if it's a standard to do geological testing before we determine that a CSA is safe to use? Is that an industry standard right now, or?
I haven't. I don't know. I have never done that.
Okay. It's just kind of a test the waters kind of method.
See what kind of equipment you can put on it, and we've sunk in this stuff just about everything you can imagine, especially in the learning curve. You know, I was starting in 1980, so we weren't even trying to do anything with clay settling areas, even trying to get out on them. And it was a learning curve in how to put the perimeter ditch around, the interior ditches, the type of equipment you can put out there to plow it. If you plow it, you're exposing it to sunlight and drying it out. So the deeper you can do that, the better.
Very good. Well, I guess the last question that I have is there been a lot of study to stabilizing the material by mixing it with another type of soil or aggregate?
A little bit of that's been done. I know Madrid did a little bit of that. I wasn't part of that, but I know they were involved in that. And like I say, they've tried spraying sand out on it. I don't know if that was what the issue was, whether it didn't work or was too expensive, or I don't know the results of not doing that. When you push out the dam, of course you're putting stuff, the farther out you can get the material, the better. And so you don't want to do it too early, or you'll get this big mud wave ahead of you. So it's a kind of an art and people that have worked on it for years, they have an idea of how far they can push that clay, because 2 feet down it's like toothpaste, and it's pretty hard to walk around on toothpaste. So.
Yeah. All right, thank you. I appreciate that perspective. Does our applicant, do y'all have any light you could shed on that situation and what our remedy would be going forward and trying to utilize these things down the road?
Yeah, in terms of testing, you could do a lot of tests before you put any equipment there. And typically, you try to limit the equipment to the strength of the foundations you're running on. So there is cone penetration test at the CBT. You could do SPT and get the CBT. It's a cone. It has a load cell at the end. It has a cell on the sleeve, and you push it down. It gives you tip resistance, sleeve friction, and based on the results of tip resistance, sleeve friction, you could correlate that to strength of the material and the classification of the material. If it's clay, pure clay, if it has some sand in it. So you could do a lot of kind of testing. SPT is where you try to drive a spoon down the soil, and based on how many times you have to hit it with a hammer from a drill rig, it will tell you how strong the soil is. So you could test and you could determine how thick that cap is, and you could determine from bearing capacity what type of material you could run on it. And you could limit your equipment to what you could run on it until such time where you could run heavier equipment as the material consolidates and gains strength. To answer your second question, has anything been done? Well, we did a lot of research actually on sand clay mixing, and it did not work from practicality point of view, because as you pump it the mix into this clay settling area segregates. And as you know, the coarse material will settle first, and then you carry the final material to the other end. So that really did not work very well. Now, other industries actually that had clays, like oil sand industry in Canada, they have a lot of fine mature clay, and they did a lot of research at the University of Alberta, and they did actually some experimenting in the field by mixing the fine clays with gypsum actually to break the chemistry of the clay and get it stronger, and that seemed to have worked well for them. So there are a lot of research on mixing fine clays with other material to get it stronger or get it to dewater faster.
So I don't know exactly how old the CSA was where that young man passed away recently, but are now like ones that are going to be closed soon, ones that are current contemporary CSAs, is there a testing process right now other than just to drive out and check it with your machine? If it sinks, stop, and if it doesn't sink, keep going? Is there any other type of safer method that's being used to ascertain whether it is safe to be driven on or not?
Yeah, I'm not sure what Zach is doing other than what you just mentioned, but just to say something about the photo and the gentleman who passed away with that unfortunate accident. I mean, that could have happened at the muck area. I mean, you could drive this equipment into natural Florida muck and get it stuck the same way this thing is stuck, and unfortunately safety precautions were not taken properly, and obviously the cap did not have a gauge on it, and there are certain ways to pull equipment from soft material, but that could have happened in any area. I mean, you have lots of soft areas, not only in Florida, but all over the United States and the world.
But the hazards that we create are different than the hazards that nature created. So that's why I'm thinking proactively.
No, I mean, from the proactive point of view, I agree with you. I think there are other things and you could do to test the soil, to test the cap, and limit the size of equipment you could run on it. And you could do things if you want to in terms of mixing it with other material, but typically we don't want to mix. I mean, you don't want to bring material from somewhere else and mix it with this material.
Gotcha.
I don't know if okay.
I appreciate that. Thank you. Yes, sir.
And just from my personal experience in having a contract where we were keeping track of a 2-year program where they were doing the ditching, and I think we did quarterly sampling of the clay just to get moisture content, to see how it was drying, and to see if, as the crust started to develop, okay, this quarter is only a foot thick. By testing the moisture content, you can see, and then, okay, so now the next time they go out for this quarter's ditching, go deeper. Because if you try and ditch it when it's too wet, it'll just flow back in. But if it starts to dry out, then the ditch will hold size. And as Michael said, the deeper you go, the more the crust you develop, and then the more the clays will consolidate. So the testing we did was very specialty equipment to get out there. We had to go with, there's a few contractors that specialize in that, and they developed some pretty innovative, very low ground pressure pieces of equipment that can get out there to do that ditching. But that's what we were on. I was personally on there sampling it, but that was how we were testing progress.
Thank you, I appreciate that. I'm thinking on those trenches that you cut through the CSA to finish drying it out, is it surface water running into them, or does the water table in the CSA actually, is it able to migrate through the clay and into that ditch?
It's both.
Both.
I mean, you get a little bit, the disking part opens up cracks, and you get some of the drying just from evaporation. But then in all those nooks and crannies, there's always standing water in there that's coming out of the clay. But then also, if there's rainwater in there, you want it to try to get out and not re-wet those clays that you're just trying to dry out. So that's the idea of trying to get positive drainage. And you can draw up a plan that's very structured and grid-like, but the clay, some areas are going to be low, so the first round of ditching is really connecting the standing water and try and get all the water off, and then you kind of progress the program from there.
Understood. Thank you. Yes, sir, Commissioner Gross.
Quick question that kind of stemmed from that talk. I mean, I know from the start to the turnover, I think it was quoted in like 45 years, something like that, or when a CSA is turned over. Is that wrong or right? Right, but from the time they start a CSA, it could be the length of the mine be 45 years, something like that. Is that wrong or right?
Hi, this is Lisa Lannon with Mosaic. Now you're asking from the initial construction through final release of reclamation. And the answer, it depends on the orientation, the size of the clay properties, how many times we're able to let it rest and go through that stage filling. Because again, we want to use it as long as possible, but in general, it's about 25 years.
Okay.
Yes.
And this is a follow-up question, is there any land, CSAs today that have been turned over north of here that have put agriculture use on? I think I know the question, but they have some north of Bartow or Polk County that are actively doing grazing, farming practices on?
Yes, I believe that there are.
Okay.
Absolutely. We have turned over, I've probably done probably at least 100 settling areas, and they've been turned over to agriculture, and they're farming it or cows are on it. In fact, I believe we did one, put the house on it, I think. It wasn't a straight settling area. In the old days, they used to leave the mine pits and then run the clay through the mine pits. And so you had a solid ground and clay and solid ground. And we've actually, Madrid's actually built a house on top of clay. They have some geofoam that's real light and it will actually float. So yeah, absolutely. We've actually released, and they are mainly pasture. Trying to think of any that are, well, you got the blueberries up in just south of Bartow. But yeah, there's a lot of them that have pasture on.
And that was a clay settling, or was that
Yeah.
a sand? Was it?
Yeah,
Okay.
clay settling.
Thank you.
Thank you. So I've got something that I've been after for a number of years and haven't been able to find, and maybe there's enough experts in the room that we could figure out how to get it. Because it would be most helpful, I think, for us. That would be a map with 3 overlays. A map that shows pre-mandatory land on it. So you look at that overlay and you can say, all of this is stuff that was mined before there was mandatory reclamation. And then a map, the next overlay would be post-mandatory land that's been mined. And then the third overlay would be all of the areas that have been fully reclaimed and restored. So that a person who's got all of these things to consider about what's being done right, what lessons that have been learned from the past, can actually look at a concise map and say, okay, this is the way things were done before, and I can tell by these aerials and then in turn driving out to the site that this new post-mandatory reclamation and indeed the projects that have been released either do look noticeably different than the other stuff or don't. Because I fly over the mine area a lot, and I have for a number of years, but since I've been a commissioner, I'm a lot more interested in it. And I just look really hard and I have no idea what's what. So I think with some of our GIS experts, we could probably put that together. I just don't have any idea why we don't already have that.
I can address that a little bit. Don't remember exactly the website, but it's part of the...
Give us your name real quick, sorry.
Brian Murphy with Madrid, CPWG. FDEP in the, on their website
has a GIS system that shows that, or much of what you've asked for. I can go back and do a little bit of searching around to find the specific URL and let you have that, but that does exist already.
Okay, great. I guess a follow-up to that, I'm going to be ecstatic when I can find that, because I've been looking for it and haven't been able to find it. But a follow-up to that would be the land that's reclaimed now, does it have to be free of Kogan grass, or can it be completely covered with Kogan grass and still be released as complete? That would probably be a question for the applicant. Yes, ma'am.
Lisa Lannon, Mosaic. We have a certain permit criteria that we have to meet for undesirable vegetation on all reclaimed lands, and it varies from permit to permit. Some of our mines have older permits that have that allow for a little more nuisance species. Some of the newer ones, it just ranges in percentages. But all of our reclaimed areas have to have, our mitigation areas have to have monitoring and meet that nuisance criteria.
Do you know what that population is? Is it like, is there a percentage of exotics that are acceptable? Is it like 5% or?
It's most areas are 10. Some permits are 5. So it's just a range between the two.
I see that's where that map would come in great, because I could go out and look at the stuff that's been reclaimed, and I could actually put my boots on the ground and see what the situation is with exotics and all those kinds of things, and get a comfort level with how it turns out. Thank you.
Yes, you're welcome.
Oh, who said that? Oh. Okay, thanks. All right, does any other board have some other questions they'd like to bring up?
No, sir.
I did notice y'all are folks that are representing us for the county. I noticed y'all taking copious notes. So if there's something that came to mind that you feel like should be, the Google age makes us all feel like we're experts on everything, but I know that we cannot actually, in fact, all be experts on everything. I was thinking about some of the native species. Gopher tortoises, are they known to inhabit the soils and CSAs post-reclamation? Do we get normal populations of gophers out on those areas? Anybody know the answer to that question?
Good afternoon again, Commissioners. Bill Bramble, Senior Manager, Mine Permitting at Mosaic. No, those would not be suitable gopher tortoise habitat. Typically, any wetland is not suitable gopher tortoise habitat. Gopher tortoises prefer dry, sandy soil, so we actually do get them that actually, on occasion, get close to the dam walls of CSA, so we actively have to take them off the dam walls. But a CSA would be suitable habitat, but we would reclaim other suitable upland habitats for gopher tortoises.
Okay, thank you.
Sure.
Just another thing that's constantly coming up and across my mind is climate change, thinking about how that pertains to facilities that we build and develop. Right now, we seem to be getting different temperatures and different frequency of storms. Probably some of those are natural cycles, and maybe some of them could be attributed to climate change, but is that an area of focus in the mining industry going forward, thinking about the next 30 years? And the reason that I ask that is, as things are changing, again, we do all like to eat, and the food that we consume does have to be fertilized. I'm just thinking about the way that we get these resources to grow these crops, and what can we do to increase sustainability, and also make sure that we're prepared for these huge rain events where we get 15, 20 inches of rain. Maybe back-to-back hurricanes or 3 in a row, those kind of things.
So Scott Witchick with Mosaic, I don't think I can talk to, agricultural practices or that end of the spectrum, but we're certainly, in terms of CSAs, we design around these 1 in 100-year storms and those things. So those standards can change as you observe changes in weather. But also today, as a result, I think we talked about a dam failure in Brazil, and so there's a new thing out there on the horizon called the Global Industry Standard on Tailings Management. It is a international standard, and a lot of those things are encompassed in that. It was just published last year, June maybe. You have to check. I'm not sure I have the date right, but sometime in the last year. And it has about a 3 to 5 year plan for implementation for folks like Mosaic and others that have dams. So a lot of that stuff around sustainability and climate change is all embodied in that. So it's something we've been looking at closely since the standard came out. It is a standard, it's not a technical reference or a specification, so it takes some time to interpret and understand what it means and how it applies to you. But yes, we certainly look at that.
That's called the Global Industry Standard on Tailings Management? Okay, thank you, I appreciate that. Hi, Sarah, do we have anybody else pop up with their hand up? Commissioner Gross, did you already ask the question about testing the processed water in a CSA?
Yes, sir.
You did, okay. I think it would be really helpful for us if we are able to get some information on the volume and names of the reagents that are used in that beneficiation process. That 30% that's unaccounted for is really an interesting idea, and it would help us a lot if we kind of knew the volumes of those fuel oils and acids. And some of them seem innocuous and others seem less innocuous, but when we think about pumping them out there in the CSA where they're going to be for quite some time, it would help us a lot to know about the quantity we're talking about, because sometimes you could spill 2 teaspoons of hydraulic oil and it might not be a big deal, but if you spill 2 totes, it might be a whole different deal. Get some perspective on that.
Yeah, I think that's why I posed the question about the testing and, knowing what's residual is there.
Yes, sir. Come on up.
Just 2 questions that came up during the discussion, and one of them I think I know the answer, but I think it would be helpful to hear the answer. Are there situations where the configuration of the dams at the fetch length, for example, lead to design freeboard that's greater than the minimum requirement of 5 feet? And I think the answer is yes, but they can address it. The second one is really because I'm not a chemical or environmental engineer. The statement that fuel oil, it degrades at a slower rate. It begs the question, how slow is slower? And it also, there was a statement that says it's capable of degrading. But the question is, do they degrade? So those are the two questions.
Thank you, John, I appreciate that. Oh, and let's let him respond, please. And then Brooks, you can have the floor next. Appreciate your patience.
So there is a detailed methodology about designing a freeboard, and that takes into consideration the wind speed and the pitch and the shape and the size of the compartment. So when you do that calculation, you look at the effective pitch going with the predominant wind direction and wind speed, and you take that calculation, which is going to generate a height of a wave. So that's height of wave, you're going to add to it a factor of safety. And that's the freeboard that you put on a place settling area. So you don't only go with what the number that you get from the calculation, you're going to add another number to it. And in the case here, 127 miles per hour was used in the design of the freeboard. But to put things in perspective, I heard a lot of people concerned about hurricanes, and I'm concerned about hurricanes. Remember that we have all these place settling areas in Polk County and Hardy County, and we had all these hurricanes, and none of them overtopped. So that should tell you something about the design of these freeboards. Thank you.
Did you have the answer to that second question about the... Oh, okay. The rate of degradation of the fuel oils?
Yeah, Subrata Andy. Yes, petroleum hydrocarbons do degrade. The rate at which it degrades depends on a lot of different factors. The mine is a very dynamic situation. You have new water coming in, you have continuous degradation that's going on, both chemical and biological. So at any point of time, if a data is collected, that's going to be valid only for that moment, because it's truly a very, very dynamic situation. Depending on which place settling area we're talking about, depending on the age of that, all of those would be variables that we have to take into account. But I do not have a number in terms of how fast or how slow it will degrade. Again, it depends on the availability of nutrients, the organic sources, and the fresh oxygenation that happens, new water that comes in. Those would definitely expedite that. But depending on the length of the CSA, which is 25 years, that is long enough to degrade petroleum hydrocarbons.
Has there been any core samples done on CSAs in the past, and is there data logged on what's found on an old CSA? I would think that, like if I own that land, I would definitely do core samples on it to see what's going on there 10 or 15 years later.
And not to my knowledge, unless Mosaic has any other data point.
Seems like that'd be a great thing to study.
Yeah, it's considered a closed system and nothing escapes. So the importance is put on to what is exposed to the environment, which is the water that goes out, and that is tested continuously.
I know that this is kind of it goes a little bit in the opposite direction of the point we were discussing earlier about it being an impervious surface, but if those ditches do dry the land out by letting water move horizontally into the ditch through the clay, then I think that means it's probably not a completely closed system.
So leaching happens mostly one way, or transfer of constituents happens mostly one way, from liquid to the clay. The clay does not necessarily release any of the constituents into water, because most of these are very low solubility in water, so they love to stay within the clay particles.
So they're binding to the clay?
Yes.
Oh yeah, that makes sense.
Thank you.
Thank you. Appreciate those thoughts, John. Yes, sir.
Couple of things. Because I've been looking at this study, and I'm not, I'm in an arena here with a bunch of chemists and scientists. I'm not one of them. But I did look at this study, and you brought up the exact question that I thought of. And why not drive some core samples into these CSAs? Why has nobody done that? Also, when you're using chemicals, okay, now there may be a good answer for this, but when you're using chemicals to wash the fuel oil off of the final product, and that waste product goes back into the CSAs, aren't those chemicals also working on that fuel oil to dislodge it from the clay as well? It's like washing your hands with, how do you get oil off your hands? A little gasoline does it well. So that's one part of the question of what I wanted to say. Another thing, you asked about the amounts. Can we get a good idea of the amounts of these reagents? What I handed you there is Mosaic's own data. That's from the mastermind plan. Those are their estimates on that front page. That mastermind plan from 2016 still resides in your library here. So that's where all of those numbers were taken from. That 3.8 pounds of fuel per ton of concentrate produced, that's a number which was much lower than I would have thought it had been if I had just looked at the FIPR study. We went up to FIPR itself and talked to Dr. Zhang, who is their 30-year expert on clay settling areas. And we said, is this number accurate? He says about half of what it used to be. Back in the days of 2001, we're using about half. Okay. So, okay, well, so be it. And when I looked at their mastermind, the mastermind plan number there, that bears out, because the FIPR study is showing 4 to 10 pounds of fuel oil used per ton of concentrate. Okay, in one place it even says 12 pounds. So there's probably some, like the guys have said, depends on the mine, the product that they're pulling out of the ground, it's going to be different, a little different formulation for each beneficiation plant. But as far as numbers go, like I said, and I had to ask Dr. Zhang what the percentage was that goes into the clay settling areas as opposed goes into other parts of the environment, such as the sand tailings. So, actually it was this, I'm sorry, excuse me, the study itself says that 65 to 75% of the 30%, if you follow me, the calculation is easy, it's right there. You do 30% going to the environment. That's what the study is all about. Of that 30%, 65 to 75% is going into the clays. So it's an easy calculation. That's where I get that number of 7 million gallons going into the 8 DeSoto clay settling areas over they say I believe it was a 13-year mining life. In other words, they'd be mining for 13 or 14 years. So, you know, I think you can get a good idea of the numbers.
Yeah, I appreciate that. This is a lot of information you have here, and I think if we can get some numbers from Mosaic, and that'll help us line the two up, and then we can ask some questions where they either align or don't align.
Well, my point is that those numbers are from Mosaic.
Yeah.
Thank you.
Yes, sir. Thank you. Yes, ma'am.
Sorry, Beth Neese again with Mosaic. I just wanted to make a clarification to Commissioner Gross's question about testing for the residual of the reagents, and so I don't know if I did the best job of explaining it before, but so the water that's coming out of the spillway in the clay settling area is the water that recirculates in the mine and is reused. But if you don't need that water, it will go to the outfall, which is where we do our monitoring. So essentially the water coming out of the CSA is the same water that could go to the outfall and be discharged, which is where we do our sampling. So I wasn't sure if I made that clear before.
Thank you.
Yep.
So the water that is just been pumped into the CSA and has made its way to the other end, it is the same water that gets recirculated back to the plant. It meets the quality level to go right out to the BDES outfall.
Correct. It could go from a CSA to an outfall. Outfall isn't right at the CSA. It's throughout the mine site. There's usually 1, 2, 3, maybe more outfalls that it could make its way to, and it be the same water that's coming out of the CSA. But it's not discharged right at the CSA. It makes its way to the outfall if it's not needed in our process.
So the water that helps transport the clay all the way through all those pipes and pumps back to the CSA, as soon as the solids drop out of it and it makes its way through the clarifying pond, it could only have trace elements of whatever.
Correct. So at that point, when it gets to the outfall, it meets the requirements to discharge through the outfall, which we monitor monthly for our monthly DMR, but we also are required to do a more extensive for our permit renewal, which is the 170 parameters or so that looks for those types of constituents and is non-detect.
So the reagents that were in that when it was being transported through the pipe must have stayed with the clay and fell out, and it's that simple. Am I missing something there?
Well, yes, anything that isn't part of the product or, that goes with the process, correct. It's not in the water that goes to the outfall.
Because when it goes into the pipeline at the beneficiation plant to get pumped to the CSA, there is reagents in there.
Small amounts, yes.
Do you have any questions? I think I pictured from your question before, kind of like you have a processed water that is. You're going to tackle some of these other questions?
I'll try. Subrata Vendi. So the first question that I wanna mention or I wanna address. Let me talk about the framework as to how permits are written. If based on testing, if there is a reason for the regulator to include a parameter in the permit, that's the only time that analyte or that parameter shows up in your permit for regular checking and regular testing. So for the 5-year renewal, Beth indicated that we run 170 parameters, and if there is no detect, then there is no reason for the permit to have those parameters included. But since processes change, every renewal comes in, we are required to run the entire suite of 170 parameters. That's for the water sample that is discharged into the surface water bodies. Now come to the sand tailings question. Sand tailings are tested once a year, and we test for oil and grease. Oil and grease is a combined parameter that looks into all kinds of oils, fats, and grease, and wax, and everything else. That lump parameter, if comes under the threshold limit, there is no reason to believe that we need to go into any more detail because the lump parameter itself is lower than what would be regulated. So that's the reason once a year the sand tailings are looked at. Once during the permit renewal, those long list of parameters are looked at. And things that are of concern.
If there's a way that we could do some core sampling and select a few old CSAs and drill in there and split sample them and see what's down in there. I think that would be great data for us to know we can share with our constituents, and we can either find the boogeyman or dismiss him. So that, I might be a little bit oversimplified, but that seemed like a good course of action for us to explore taking. Of course, they're on private property, so we have to have permission to do that. So I put that question out there. If we could get, at least discuss the logistics of doing that and the expense and what we could find from that.
John Dose, I'm the CBWG. My first 4 years in Florida was doing clay sampling on old settling areas. And one of the things that I learned, not from being around in Florida, not from being familiar with mining, is if you're in waste clay, you can smell it. I mean, I think deeper in the clay body, that those oils are there. It smells. You have the hydrocarbon odor. That was when we have other other previously mined areas where sometimes it's clay mixed and sand mixed, and you don't know. And so you have the overburden soils that have clays in them sometimes as well, and you have very low blow count. But if it's very low blow count and it smells with hydrocarbon, it usually gets part of the waste clay. That's my only direct observation.
That's definitely some useful experience. I appreciate that. Now for our experts over here, I'd like to get some input from both sides, but one of my probably last questions is, I've got this idea, I don't know if it's been done, but it seems like the 3-section theory might make sense as a way to approach things. I know it's a different scale than what's been done before. But if you had 3 640-acre sections of land, and they were basically phase 1, phase 2, and phase 3 of a mining operation. You take the first one and you put your clay settling area and your mine cut area and your sand tailings. You fit all those things on there however they fit best with the geology and layout of the land. And you do it all contained in that 1 mile by 1 mile area. And you dig the whole thing in however long it takes to dig it. If it's 1 year, just for our example's sake, then the next year you move to the second one. And you keep digging. That way you never have to shut down, because we all know that big, huge operations can't just stop. They have to keep going. And then you start fixing the first one. Well, then the third year, before you go into the third, or not the third year, but before you're able to start the third section, and this could be scaled, but before you move into that third section, the first one has to be right, or at least very close to right, to being everything straightened out, post-mine, it's all good, so that you kind of get on this rolling 3-section deal where you don't wind up with a third of your county exposed in mine cuts. That may sound oversimplified, but it seems like it would have alleviated at least a good bit of the concerns that I've heard through all these workshops about massive areas open, massive areas unreclaimed, and all these different issues. So is that concept too oversimplified, or could that concept, it could be scaled to 2 sections or whatever, but not scaled to 20 sections, or it would be the same thing? I'd just like to have a little bit of input on that. Maybe I'm oversimplifying. But I'm just trying to think about the concerns, the environmental concerns, and I'm also trying to balance it with the fact that there is no way that we're all going to quit eating. We are going to have NPK to continue to eat. So just like paradigms have shifted in the past and we're doing many practices different than we used to, maybe there's an opportunity there to do some of these things differently and minimize some of the risk. I don't see anybody jumping up. What's that?
Scott Witchick with Mosaic. So that is in essence what the plan normally is. One of my slides I talked about material balance, so you're kind of at the mercy of that material balance, right? You have to build a clay settling area, so that occupies a certain part of your land. And then you produce X amount of tailings, so that determines how much you can backfill.
So I think the plan that's in the operating permit application or the rezoning app, whatever, you know, I'm not conversant in the application world right now, but that is the plan, you know, that works with the material balance that's laid out for the facility. So we can revisit that another time and kind of lay out what that sequence looks like in the timing.
I'm just wondering about the limited footprint for these CSAs and limited exposure.
It's Brian Murphy with Madrid CPWG. Some of the counties have in the past utilized a mining unit concept wherein you start out in mining unit 1, proceed to the next unit, and then to the next unit, and it's at least partially tied to the reclamation release that you were talking about, but it has to be looked at on the mass balance that he was talking about as to how large a footprint, and it depends in large part on the type of area that is being reclaimed. Your initial mining unit will have a clay settling area on unmined ground, unless you happen to have a neighbor with a big hole in their property. So there's a lot of factors that come into play in the mining unit concept. The mine reclamation regulations stipulate a specific time period for most of the reclamation projects to be completed. So that time frame for completion and release factors into the timing and the size of your mining units.
I guess just thinking back about some of the conversation we've already had too, it takes like 3 or 4 years before you can drive on a CSA, so that's not going to be ready to fix the following year. 10 to 20 years. Yes, sir, Mr. Bart.
Yes, sir, Mr. Chairman. I understand what you're trying to do. You said you want to kind of disturb the land and watch how it progresses and see if it needs to move forward. And in fact, that's kind of how your system is set up now. You permit through your system. Obviously, when we came before you before, it was just for rezoning property. We did not talk about how the permitting process works from a mining standpoint. So what happens is that we submit what's submitted is an overall master plan for the mine, okay? And it shows you how we're going to proceed through the property. It is a rolling process. You know, so as you get an area done and it starts to backfill, you know, the reclamation comes in behind it. So that all kind of occurs in a rolling. So when you look at it, sometimes you think, well, when you disturb it, you're going to disturb all of it and then reclaim it all at one time. Well, that's not how it is. As you're mining it, you can move back afterwards and reclaim some of the areas where you can't. Now, some of the areas you can't, because some could be clay settling areas. And so to the point there, we designed for the maximum number of clay settling areas. But if we don't have to build them, we won't. And then we'll reclaim the property appropriately. So that's kind of the rolling process that already happens, number one. Number two, your permitting process is in 2 steps from a mine. One's overall master plan is like a master plan for subdivision, okay? And then you come in for an operating permit that's like 5 years, okay? 5 years, what gives you the ability to mine a certain area, okay? So once that 5-year area is near complete, we would have to come in for the second phase of that. So another operating permit. As a part of the review of that second phase, you have the ability to look and see how the first 5-year operating permit was done and how you can correct the things that need to be corrected, or whatever. Okay, so the current concerns that came up during that first 5 years can be addressed as it progresses. So hopefully that answers your question a little bit. But the reason why we haven't talked about any of that, because we have not asked for the permit to mine to this date. We have just asked for a rezoning of the property. Okay, so.
Yep. I may have inadvertently skewed slightly off topic with my question. Go ahead, Commissioner Grace.
I just had a follow-up question to that. And so, Bart, don't sit down yet. You need to stretch anyway.
Getting your steps in.
Yeah. So the mine land adjacent to the CSA, that land could be reclaimed well before the CSA is able to be, is that correct?
Correct,
Okay.
yes, a lot of times it can, of course. And the first CSAs that are used, what will happen is that once we determine the need for the second and the third, those will be built. And what will happen is that the first one will be used, and like we talked about before, well, you start using the second one to start stage filling, to pull the water off of it so that it can consolidate a little bit at that time. And then once it consolidates enough, then we can start using water, putting water back in there to start. So that's why that's why we start using those. But if not all of them are needed, then we won't build all of them. So, but those are really the only areas. Like when you look over, if you fly over some of our South Fork Mead property, there's some areas that have been reclaimed, and there's some areas that are clearly not. And you know, why is that in the middle of all that? Well, that's because that is an area that could be a clay settling area if it's needed. But if it's not, then it can be reclaimed to uplands or wetlands or whatever.
Okay.
And I'm certainly not a reclamation expert, so Lisa can correct me if I say something incorrect.
Very good. Thank you, Bart. Any other questions from commissioners? I think as we're wrapping up, there's a few items here that we don't really, I don't feel like we got a real definitive answer to. So if there's some of these things that the applicant can assemble or give us access to later, that would be great, and we can turn around and make those available to the public. We've all made some notes here and probably know what those key things are, but I'll be reviewing the notes too. And
we have a list of questions that we've started from the previous workshop, so if each of the commissioners, I'll have Allison transcribe all of your questions that you asked today, and we'll add those too, and then give you a little bit of time because we've been communicating that we would be submitting those questions to the industry to give them time to answer them. And so I'd like to get that to them within the next 30 days so they have plenty of time to answer them before our next workshop. And I'll get those to you just as soon as we get them transcribed.
is that including the ones from last time?
Yes, sir. Okay. We'll just build on that one and give them one big packet of requests.
Great, great. Well, I think that today was a productive day, and it was importantly a respectful day. I appreciate everybody that came, and I feel bad for those that had to leave early, but I know taking a whole day off of work is difficult. But thank y'all long haulers that stayed the whole time too. A lot of very intelligent conversation and very civil, and I really appreciate that. It means a lot. It's difficult to be up here and be like a ringmaster conducting a circus. That being said, if there is not anything else, any other comments from our commissioners or from our public, I think we've accomplished what we set out to do today.
Will it be on your website?
Well, what? A video? I don't know, man. What?
Yes, Mosaic sponsors that for us, so they video and audio the entire thing. It takes usually a couple weeks for it to come back to us, but once it is, it'll be on just like the previous 5 workshops have been, or 4 workshops. Yes, ma'am.
Great. I want to thank you folks for joining us today and the information that you shared with us. It was very helpful, and we look forward to working with y'all going forward. And I'd also like to thank the applicant. I realize we have a lot of very high-paid people in this room all day long, and I appreciate y'all bringing your best resources to help us get answers to our questions. Thank you. And thank you to the public again, and also to our sound folks over there for setting us all up, making us look good. Thank you, guys. And if there's nothing else, then we're going to go ahead and call that the end of the workshop. Thank y'all.